We live in an era of digitalization where trillions of bits of data are generated every minute. Not only that, but this rate of data generation is growing at an astronomical rate with an increase in internet adoption and rapid technological advancements. Just to give you a glimpse of this data generation, let me present one fact to you guys. According to the research done by World Economic Forum, by 2025, the amount of data generated each day will reach a mammoth number of 463 exabytes on a global scale. And not making use of this monstrous amount of data for the betterment of human race, new discoveries and innovations will be completely unethical, right? And that's where the field of data science comes into play. Since its mainstream incarnation in 2008, data science has become the buzzword in industry. There are currently thrice the amount of job openings for data science profiles across the globe than the current number of data scientists itself. This demand speaks the volume about the field of data science. And to get you started in the field, Intellipaat brings you this extensive session on basics of data science. But before we begin with technical jargon, make sure to enable that subscribe button and bell icon so that you don't miss out on any update coming from our team. First of all, let's discuss the agenda. We'll begin this session on a friendly note by talking about introduction to Python, Numpy array mathematics and array elementwise operations. What is array arithmetic, explaining math function and what is basic statistics. Next, we'll talk about array manipulation, introduction to Python Pandas framework, difference between series and data frames, pie charts and histograms as well as scatter plots. Moving forward, we shall discuss more basic concepts such as applying functions, basics of data visualization, what is bubble chart and box plot, along with concepts of inheritance and polymorphism in Python. And finally, we shall cover the interview questions and answers that are most commonly asked in data science interviews regarding this data science basics parts. I hope I have made myself clear with the agenda. So let's dive into the session directly.
Data science. In a world that is increasingly becoming a digital space, organizations deal with zettabytes and yottabytes of structured and unstructured data every day. Evolving technologies have enabled cost savings and smarter storage spaces to store critical data. Now, organizations can analyze this data to understand global market trends and enable their business to thrive. Data science can also predict future events based on the present and past data. Data science is a field of computer science that involves creating algorithms and models to extract, process, visualize, and find hidden patterns from the raw information. Data extraction and transformation, statistical analysis, data manipulation, visualization, machine learning, and predictive modeling are some of the most popular fields in computer science that utilize data science techniques. Every day, 2.5 quintillion bytes of data are generated, and it is more accelerated with the growth of IoT. This data comes from all possible sources such as sensors used in shopping malls to gather shoppers' information, posts on social media platforms, digital pictures and videos captured on our phones, and purchase transactions made through e-commerce. Now this data is known as big data. Companies are flooded with colossal amounts of data. Thus, it is very important to know what to do with this exploding data and how to utilize it. Amazon needs data scientists to find out customer mindset and enhance the geographical reach of both e-commerce and cloud domains among other business-driven goals. Similarly, Visa is an online financial gateway for many companies. Visa does transactions worth hundreds and millions in a single day. Due to this, the need for data scientists is huge at Visa to generate more revenue, check fraudulent transactions, and customize products and services as per customer requirements, etc. Now we have 5 stages of data science life cycle. We have data discovery. It includes ways to discover data from various sources, which could be in an unstructured format like videos or images, or in a structured format like in text files, or it could be from relational database systems. Next stage we have is data preparation. It includes converting disparate data into a common format in order to work with it seamlessly. This process involves collecting clean data subsets and inserting suitable defaults, And it also can involve more complex methods like identifying missing values by modeling and so on. Third stage we have is mathematical models. These models are planned and built by the data scientist in order to suit the specific need of business organizations. Then we have getting things in action. Once the data is prepared and the models are built, it is time to get these models working in order to achieve the desired results. And the last stage we have is communication. The data scientists need to be liaison between various teams and should be able to seamlessly communicate his findings to key stakeholders and decision makers in the organizations so that actions can be taken based on the recommendations of the data scientist. In India, data analysts with 1 to 4 years of industry experience earn an average salary of 4,14,000 per year. Expert data analysts with experience of more than 10 years can earn 9 lakhs per year. In the USA, at the entry level, you can expect around 66,994 US dollars. A data analyst with 3 to 5 years of experience would take around $74,860, while an experienced data analyst with 10 plus years of experience would be around 83,673 US dollars.
So guys, I'm making one of the report of this project file in the real-time industry. Whenever we are getting any of the project, guys, on that time we need to submit the report of the project to the client, because we cannot submit the code now. We can only submit the report. If someone gives you the data set, whatever the inferences you can find it, you can submit the project. So the task is the retail store has multiple outlets. I think everyone is aware about Walmart. What is Walmart, guys? Walmart is the multinational retail corporation that operates a chain of stores, chains of hypermarkets, discount department stores, grocery stores, right? Basically, the Walmart Walmart is from in the USA. Walmart is the one of the largest retailer in the world. Over 11,000 stores in the 27 countries. And 2.22 more than 2.2 million, I think 2.2 or 2.3 million employees all over the globe. So guys, we are working with the Walmart data. A retail store have multiple outlets across the country are facing issues in managing the inventories to matching the demand with respect to supply. Right? So data set information is present in front of you here. 6, 4, 3, 5 rows and 8 columns are there. The column names are store, means store number, date, week of sales, weekly sales, sales for the given store in the week, holiday flag, if it is a holiday week, temperature on the day of the sale, fuel price, cost of the fuel in the region, CPI, customer price index, and then unemployment rate.
Let's have a quick quiz question, guys, and the question is, which of the following is not a data structure provided by Numpy library? And your options are ND array, matrix or data frame. Please mention your answers in the comment section below.
So guys, now what is the task? The task is you are providing with the weekly sales data for their various outlets. Use statistical analysis, EDA outliers analysis, and handle the missing values to come up with the various insights that can give them a clear perspective on the followings. In this one, the first task is saying, if a weekly sales are affected by the unemployment rate, like if yes, which stores are suffering the most? If a weekly sales are affected by the employment rate, if yes, which stores are suffering the most? In this, how many stores are there? Total 45 stores are there, 45 different stores. If I'm checking with the correlation, I think on that time I'm getting the clear perspective, no? Guys, highly unemployment rate may show weak sales and the weakest stores will be suffering, correct? Now, if the weekly sales show the seasonal trend, when and what could be the reason? So I think whenever the seasonal trend and something are there, that means which algorithm we can use whenever you're finding trend, seasonality, these type of things. Time series. So guys, does the temperature affect the weekly sales in any manner? Yes, of course. I think of course it's affected if the I think some of the European countries have temperature in minus. On that time, no one wants to go market and purchasing the things. in winter, in I think highly in summer season mostly. No one wants to go outside from in your home, right?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, how the customer price index affecting the weekly sale on? So I think with the help of, I think this question, and this question, we can solve it with the help of graphs. Correct? Customer price index of the weekly sales of various stores. Top performing store to the historical data. I think on that time we are checking the maximum. With the help of bar chart, we can find it. Now the worst stores and how significantly is different between the highest and lowest stores. I think with the help of bar chart, we can easily find these type of things. Now, this one is the important one. Now question is saying, use predictive modeling techniques to forecast the sales for each store of the next 12 weeks. Difference between forecasting and predicting. Guys, forecasting and predictions are two related concepts basically, but they have two distinct meaning and or we can say that the implications. Forecasting refers to the process of estimating or predicting future events or trends based on their historical data, right? Or statistical model or other quantitative methods. Forecasting is typically what they say is used to make informed decision about the future outcomes such as sales, demands, financial performance. So forecasts are often based on assumptions about the future condition and subject to uncertain and error. But prediction, in other hand, refers to the act of making an informed guess or projection. Prediction means guessing. Forecasting means prediction the things they help. Yes, I can give you the example of forecasting. Forecasting means the company, like any company, the company could use historical sale data of the similar product, then market research data and other relevant factors such as pricing, advertising, and campaigning, anything, to develop a statistical model that predict the future sales of new product. Future sales of new product. This process of using historical data, quantitative method, estimation, future sales is an example of forecasting. Prediction. Example of prediction is like a sales manager of the company might make a prediction based on their intuitions and experience in the market, so that the new product is going to be successful and will have high sales in the future. So the prediction might be based on the personal opinion, industrial knowledge, or non-quantitative factors that cannot be easily quantified or measured. So in this data, what we use, prediction or forecasting, we need to forecast the thing, correct? Whenever we need to forecast the things, guys, so I think on that time we are using one of the famous algorithm is there, time series, correct? Time series. I'm writing time series, TS. So guys, time series have different algorithm. We have ARIMA, we have SARIMA, we have FV Prophet, we have Neuro. There are different algorithms are there, but mostly we are preferring these two, right? Whatever you have learned till now, you have only preferring these two, na? So with the help of these two, I can show you how to work on it. Now, but here the task, guys, what do you think? If we can directly put the model and we can find it the sale, then I never recommend you can add this project in your resume. Guys, here total 45 different stores are there. And if you want to predict store-wise prediction, then how to do that? That is the task. Total 45 stores are there. So here the question is, with the predictive modeling technique to forecast the sales for each store for next 12 week, means 45 stores are there, guys. 1, 2, 3 till 45. So how many times we can use time series? 45 times. First of all, we need to filter every store na, one by one. Store 1, store 2, store 3 till store 5, 45. Then we need to check the stationarity of data. Like store 1 have the stationarity, store 2 don't have the stationarity. Store 3 have the stationarity, store 4 doesn't have a stationarity. Then, guys, if I'll make a user defined, then one by one store. Wait, I can show you one of the sample. Guys, whatever the sample I can show it to you, I'm not saying that is 100% accurate or 100% okay. Whatever I can show you, that is the demo. You can make it more interactive. I can show you one of the report. On that particular report, one by one, I can use the algorithm, and I will in detail I can write how it's work. Here, first of all, I'm loading the data set, libraries, and loading the data set. So this is my data set, store one, date, weekly sale, holiday flags, temperature, fuel price, CPI, unemployment rates. Correct? After that, I will convert my date column as an index, because I'm working it as a time series. Now, this one. There are about 45 different stores in the data set. Correct? So let's select any of the store ID from 1 to 25. I'll make it as a user defined here. Like here, if I'm selecting store 7. So first of all, he's filtering all the store 7. And guys, this is my report, which I'm making it. So guys, this is the project one. This is the table of content. In this project, whatever we are using, like problem statement, project objective, data description, data pre-processing steps and inspiration, choosing algorithm for project, motivation and reason for choosing algorithm, assumptions, model evaluation and technique, inferences from the same, future possibility of the project, conclusion and references, everything, right? After that, the problem statements. Whatever the problem statements we have, right? Then objective of the project. The retail company will multiple outlets across with the company. After that, data description about the data. How many records we have? About in detailed description, 45 stores, date of record, weekly sales, flags 1 and 0, everything. Detailed description. Okay. After that, this one, data pre-processing steps and inspirations. So model evaluation and technique. So which model I can select it? Why I'm selecting it? Model evaluation technique, regression model, ARIMA model, everything guys in very detail. Model evaluation and technique, right? And after that, what, like in correlation, as you told me, sir, with the help of correlation, we can check it. So here you can see that I'm attaching some graphs, whatever we can find on that time. Holiday flag, which model we can use it, what is the use of that? In ARIMA, what we find, mean error, forecast, inferences of this project, forecast before detrending, forecast after detrending, inferences of this project, regression model is coming like this, inferences of this project using the ARIMA model, inferences of the project, everything guys in very detail, you can see it till last, everything. Future possibilities of this project and conclusion of this project, at last references, some of the references we can add. Just after that guys, I'm making one more report for all of you. This is the coding part, which we used generally, which we used to do that. Ada, Fuller, everything in very detail. From here, I am cut paste the graph and paste it in my report. So some of the graphs are missing here because I already cut and paste and add it on that particular part. You can see it. Everything is there. That is the actual file. That is the actual way of doing the projects. Till now, whatever we are doing, that is only the hands-on. In real time, we are working this like this. Maximum forecast, minimum forecast, and average forecast of every store. So guys, okay, I can show you one of the demo key how to do that. So first of all, I'm loading the data set. After that, converting the date column as an index column. And Richard is Richard is one of my learner. He's making the previous report, but coding file I'll make for all of you. At least you are at least aware about that, what to do. He need to submit in his college, so we can we can sit and I can explain you what to do. So he is making it, so I like it. I think I can show you to all of you. First of all, I need to select the store wise, like enter the store number, whatever store, because first of all, like total 45 stores are there. What is your first approach, guys? First, you need to filter it, na, store wise. Like if you want to filter store 1, store 2, store 3. Okay. So all these stores, dates are there, stores are there, weekly sales are there, holiday flags are there, temperature, fuel price, CPI, unemployment. So just after that, guys, I'm converting everything into a data frame and group by with this sum. So I'm only taking date and weekly sales. Whatever I need to predict it. So guys, after that we are checking the data stationarity or not. We can reset the index first of all and converting the date column into date time. Why I'm doing this? Date and weekly sales are there, right? And checking the seasonality. In my data, seasonality is there or not, trends are there or not. Correct? Means overall we need to check now my data is stationarity or not. Guys, if in my data set, if there any means in my data set is stationary, it's not a stationarity, then how we know that, like in my data set seasonality are there? So how we know that in my data set stationarity are there or not? Okay. So guys, here I'm checking my data set. This is my original data set, trends, seasonality, and this is the residual values. Residual values means leftover values. Means no stationarity are there. But tell me one thing, like with the, I'm only checking one store, right? So we can say that no stationarity are there. In a second store, if it's possible, stationarity is there or not? Yes or no? So I think, tell me which algorithm we can use, ARIMA or SARIMA? Guys, if you don't want to check your data is stationarity or not every time and you need to reduce the step on that time, I think SARIMA is the best model. Seasonal ARIMA. On that time, there is no need to check your data is stationarity or not. It's automatically doing it, directly checking the seasonality. Correct? So the same thing, first of all, I need to check sales dot I'll convert date as an index and try to plot a graph. So here with the different dates, which type of sales we have. So I think sometimes I'm getting the highest sales also. You can see these trends. So guys, I'm loading the data set. I'll converting date column as an index column, right? And here I'm using a user defined function. So in the user defined function, guys, like I'm selecting store 7. Wait a minute, I'll execute it one by one. Sorry, here I'm executing, like I'm writing store 17. So everywhere store 17 is coming and all the parameters are there, right? Then I'm converting my data frame, pd.data frame store weekly requirements group by the means date and weekly requirements, because I need to predict the weekly sales na, of every store after 12 weeks. So date and the weekly sales, right? After that, remove date from index to change data type, because it's clearly isn't acceptable na, whenever you need to decompose the data. So I'm converting date into date time format and checking the decomposition method. So guys, whenever you have seen this decomposition in my data set, trends and seasonality is visible to you or not? If the trends and seasonality are there, that means my data set is not stationarity. Yes. So that means if I'm using ARIMA, so first I need to convert into a stationarity data, then we need to do that. In a second store, if it is already stationarity, then again we can do that. So I think it's a waste of time. So instead of that, I'm directly using SeriMax, seasonal ARIMA. Guys, this is the original data. This is the trend which we have. This is the seasonality which we have. And this is the residual values. Correct. Repetitive patterns and trends. Correct. So I'm resetting back date to an index and try to plot this one. So this is for the store 17. Date wise, the store for the sales forecasting. So guys, if you've seen this graph, so what inference you can find it from here? We have the huge peak in the holiday, means there is an upward trends in the sale. So we can compare with any other store. Like here, let's compare the 2012 data of 2 stores. Let's take store 5 analysis. So I'm taking store 5 here, store 5, data.store 5, and convert into a data frame, sum it. with the help of two data. And now comparing two data set. Instead of store 4 and 5, now my store is store, wait a minute, here store 17 and 5 on 2012. Store 17 and 5. Actually, I need to compare it, na? Whatever the weekly sales store 17 and whatever the weekly sales of store 5. So guys, where I'm getting the profit? Which store is in profit now? Guys, you can see it. Y1 2012 plot is there. And in Y1, you can see it what we stored. Round graph is profit due to high sales. My racing for top one, profit is more. Guys, which one is for 17? Which one is for 5? Brown 17, 5. Chocolate is 17 and Turkish is 5. So guys, that means in 17 we are getting more profit, right? So clearly we can see the irregularities. So now time to find the order. So guys, in SediMax, how to find the order? There is some more inferences from 17. This is a spike is sale 2. Yes, correct. Guys, whenever you need to find the order, best order of Sarima, like in Arima, I think with the help of that report, whatever we fetch, right, in Arima, we know that the best order. But if we directly using Sarima, on that time, how to take a best order? So guys, how to do that? Like in Arima, we know that how to find the best order, but in Sarima, how to take a best order? So guys, Sarima means basically seasonal autoregressive integrated moving average is the full form of Sarima. Seasonal autoregressive integrated moving average. Okay. So in the time series method, that extend the Arima model to to account for seasonal pattern in the data. So Sarima model can commonly used in the field of finance, economics, and engineering to forecast future values of a time series based on their historical data. So guys, basically Sarima is the combination of three components: SAR, SI, and SME. So guys, SAR means seasonal autoregression. SI means seasonal integration. And SMA means seasonal moving average. So guys, seasonal autoregressive means the component model, the relationship between the variable and its own lagged values, taking into account patterns in the data. And seasonal integration means this components model, the difference of the variables with its seasonal lags, which can helps to remove seasonal trends in the data, which helps to remove the seasonal trends. What is that? Seasonal integration, with the help of seasonal integration. And seasonal moving average means, guys, the component model, the relationship between like the variables and the seasonal moving average, which can helps to smooth out any noise in the data. That means he's automatically removing the stationarity, right? Removing these trends and smoothing the data. So the Sarima model specify using three parameters: P, D, Q for non-seasonal components and PDQ for seasonal components. Small PDQ for non-seasonal and capital PDQ for um, seasonal components. So and S for the seasonality. So the PDQ parameter like specify the order of non-seasonal autoregressive, differencing and moving average. Okay, so overall Sarima model can useful for forecasting time series data with seasonal patterns, but require careful tuning of the model parameters to achieve a good performance. Because here we are not converting manually, everything is converting automatically. Smoothing of data, removing the trends, everything is doing automatically. Guys, I'm giving you the little bit overview of the Sarima model and how it's differ from Arima. Guys, Arima means autoregressive integrated moving average. Arima autoregressive integrated moving average, and Sarima means seasonal autoregressive integrated moving average. Are both time series forecasting model correct? That are used to predict future values in a time series based on the past value. The main difference between the model of Arima and Sarima is like Sarima takes an account of seasonal patterns in the data, while Arima does not. That is the main difference. Okay, that means Arima model are used in the time series data that do not exhibit seasonal pattern, while Sarima model are used for time series data that exhibits seasonal pattern. In ARIMA, we have guys three things, na? AR means auto regression, differencing means I, and moving average is MA. So these components capture non-seasonal pattern in the data, correct? But in Sarima model, including three components as ARIMA model, but also includes seasonal components like SAR, seasonal auto regression, SI means seasonal differencing, and seasonal moving average. In ARIMA is normal, no? Auto regression, integration, moving average means differencing and moving average. Here everything before seasonality is including with that. Basically, now coming on to finding the order. How to find the order of both the things. Like in ARIMA, we know that with the help of that particular thing we can find it, right? But here we are using one term named iter tools for finding the value of PDQ. P is the, guys, what is P here? Auto regression, right? Seasonal auto regression, SAR. I is, D means, guys, here D means differencing, and Q means moving average, right? So now the order of Sarima model can be determined by the examine of autocorrelation and partial autocorrelation plot, right? For the time series. So however, manually examine all the possible combination of order can be time consuming process. Yes. So to automate this process, we can use iter tools module. This one, iterative modules. So in Python, to generate all possible combinations of order and evaluate the model performance for each combination, we use iter tools. So in this one, guys, here, your PDQ values always lies between 0 to 5, not more than 5. I think 5 is more than enough. We are never getting 5. 1, 0, 1, 1, 0, 2 like this, no? 5 is the highest value. Correct? Now, I'm adding one column and I will show you seasonal PDQ. So this is all the possible outcomes, 0, 0, 0, 52, 0, 0, 1, 52. So whatever the possible outcomes are present, all the possible outcomes, it is showing to you. Whatever the best possible outcomes. So here, this is, guys, this is the AR, this is the differencing, this is the Q, and this is the seasonal. Like 12 weeks means total 52 days or 52 weeks, whatever you want. Here, once we have generated all the possible combinations of order, we can evaluate the performance of each module using the, like we can use AIC or BIC value to select, na? And select the model as lowest matrix. So guys, as I already discussed, PDQ value means, PDQ value have three components, right? So basically here, Sarima means, okay, I'll add comment like hash S Sarima. So Sarima have total 3 items, guys. SAR. SAR means seasonal auto regression. Auto regression. After that, after SAR, we have SI. SI means, guys, seasonal integration. Or we can say that seasonal differencing. Seasonal differencing. And after that, at last, we have SMA. SMA means seasonal moving average. 12 months means 52 weeks. Correct? So this is your P, this is your D, and this is your Q. Correct? So here I am selecting PDQ value range. PDQ list, I can iterate all the possible values of PDQ. So 0, 1, 2, start from 0, 1, 2 until 52 weeks. With the help of loop, we can iterate it. Everywhere the seasonality is same, 52 weeks. Correct? Now, after that, now statsmodel.api as SM. With the help of that, I'm importing this Remax here. So order I am choosing it 443, and seasonal order I am choosing in 110 and 52. I am enforcing the stationarity is equals to false here. Enforce. So guys, one more thing I think we need to execute from here, and here I am taking 443. Guys, actually here I am taking it randomly, right? But in the real time, we are choosing the order which is repeated here. I'm choosing this one. In real time, we can select it. Whatever the repeated patterns, we can choose that one. But here, I can only showing a demo. I need to introduce iter tools. So that's why I'm only using it, because the rest of the time, I think mostly like last time which we used, with the help of that chart, you are finding the best ARIMA model, no? Best ARIMA or best ARIMA model. I'm choosing this pattern because this is the repeated pattern which we used in earlier also, matlab upcoming session, in upcoming also. This is the Sarima best Sarima order, right? Okay, wait, I will do one thing. Here also I'm using 110, 110. Now it's fine. Order and seasonal order are same. But if you remember, I think when we are doing air passenger, so on that time we are finding one chart. On that particular chart, we are discussing about AIC value. The low AIC is the good value. Remember, that are the parameters which we used to selecting a best order. Here also we are doing the same thing. So I'm selecting a model, fitting the model and checking the summary. So this is the summary which we find. And if you remember this type of a summary, I will take a screenshot and add in my report on that time, right? So this type of summary of different stores, I will add it according to stores, right? After that, this is I try to plot some graphs like the standard residual values, your histogram plus estimation density, your normal QQ graph, correliogram, everything is there, right? So guys, you ever find these type of inferences ever, like histogram, KDE value and everything? Before that, you are checking these type of graphs or not? Okay, so standard residual of W. So here something in I think in 0 we have some line, right? After that, this is the histogram, means you can easily find the KDE value, histogram, and 0 to 1 value are finding it, right? This is the 0. Normally distributed or not, you can easily find it, the density and everything, right? Then this is the QQ line. This is the best fit line and where your data lies. And this is the correliogram. With the help of that, I think we are finding the best model. Okay, so guys, correliogram, first of all, I can give you some idea about correliogram. So guys, correliogram is also known as autocorrelation plot or ACF plot. Now you are aware about that in a graphical tool. Correliogram is also known as autocorrelation plot or ACF plot. It is a graphical tool used to visualize the autocorrelation functions of a time series. So it's measure the linear relationship between the lagged value of a time series, and it is usually identifying the pattern in the data that may be used for modeling and forecasting, in which conditions they are supposed to be used ideally. Ideally, I think we doesn't say anything ki only this graph is enough for that particular thing. We are checking the decomposition graph, right? So you know that in your data seasonality things are there or not. If you are plotting this graph, if you're checking the diagnostic of your model, on that time he can give you everything about your model, whatever the necessary graph, he can plot all the things and show you the necessary information. In the if you check the relationship between your model, your data is not lies on that best fit line, no? Your data is not lies. This is not normally distributed. Standard residual values, the best fitted line, whatever the values which is, listen, whatever the values which is outside the like residual error, you know that or not? Standard residual, okay, what is the, okay, Khushbu, standard residual is also known as standardized residual or normalized residuals. It's a measure of goodness of fit of a statistic model. It just measures the goodness of fit of a statistical model. So in this context, the time series analysis, standardized residuals are used to access accuracy of model prediction and identifying the potential outliers or unusual observations in the data. So in this one, we calculate by dividing the residual values. Residual values means like the difference between the observed value and the predicted value from the model. So by the estimated standard deviation. So the result value are similar to Z score, na? And therefore standardized with mean of 0 and standard deviation of 1. So we are using this one for you finding it. Standardized residual of W. I think histogram already everyone is aware. We are checking the density and everything. Okay, Muraj, actually standardization. This is standardized residual error. Standardized residual error is also known as like studentized residual, or we can say that normalized residuals. So here we are measures of the goodness of fit of this statistical model. So in the if I'm talking about the time series analysis, so here you can see that standardized residual error are used to assess the accuracy of the model prediction and to identify the potential outlier or any unusual observations in the data. Like this is the line, any unusual observation in the data, we can find it from here. And how to calculate it, if you want to know that, here we are dividing by the residual values. Standard residuals are calculated by dividing residual values by the estimate standard deviation of that particular value. Estimate standard deviation. So what type of result we are getting? We are getting the similar Z scores where so guys, still here it's clear for everyone, I hope, right? What we are doing, why we are doing it. Then after making a model, what's my next step? After training a model, prediction. So prediction, result.get prediction, start with the date, whatever the first date, and here I am follows the dynamic plot and plot it. Now my prediction values are stored in prediction CI. And now the value starts from 2010 and plot label observed, whatever the observed value. So prediction mean plot, average plot, guys. We can call this as a dynamic plot. Whatever the plot you have seen, you never seen before, this is like a dynamic plot. Observed value in blue, in green is one step ahead from forecasting. This one. So here I am filling the distance between your CI index value, and we can log between first and the second observed and one step ahead for that. This is the prediction, whatever the prediction we can find it, right? And whatever the forecast, whatever we can forecast it accordingly. This type of graph we call it as dynamic. Here I'm starting the data from 27/7/2012, right? Start date, pd.date time. Here I'm taking data from 2010 till last. Okay, so predicted mean plot. This is almost average plot now. So AX is equals to AX. AX means your whatever the mode we have using it. Label is one step ahead from forecast. Alpha, I think everyone is aware what is the use of alpha here. You can find, if you want to see, you can see it from here. Everything, the difference between everything. What is the use of alpha, legend, logs, everything. If you want to use X-text, anything, everything is present here. Clear? If I'm using alpha is something else, on that time is increase the size. So now, prediction of first and the second one, first column and second column, right? Of all the rows. I'm writing color K. If you want to use color anything else, like you can use color B. So blue is there. If you want to use yellow, okay, like instead of this, if I'm using alpha 5, the dark color you can see in it. Yeah, it is more readable, right? If I'm using a light color. So with the help of time period, 2010, 2010, 159, then 11, 159, then 12, 159, then 13, 1. Right? So after that, I'm checking the mean squared error of my model, whatever the model we can predict it. So guys, seen, this is my mean squared error. So according to you, how many of you have say that this is the good model? So guys, how to reduce this value? And how I'm getting that much huge value? Actually, what happened? First of all, why I'm getting this much of error? Because no one observed in weekly sale we have that much of values, that much huge values. Correct? First of all, whenever we are working with that much huge values, what first of, for the easy calculation, what we did, rescale it. We are doing it or not? Guys, here rescaling is working fine or not? If I'm using rescaling or anything. Guys, yes, no, anything. I couldn't follow. Okay. Anyone else? Guys, first of all, whenever we have that much of huge values, right? So first we rescale our data. After that, we can perform all these steps. But if I'm using rescaling also, on that time, we can only rescale the data. We can reduce the number of error, but I'm getting the error, na? My model is not accurate, not up to date. Only I can rescale this error in one particular range, right? But what happened, na? Like removing the unwanted data, but here, because of weekly sales, here are the values are very high, very large. So error is also coming very large, now, because when we sum it, mean squared error is there, average error. If I calculate all the weekly sales, you can assume how much numbers are there. Number is coming in exponential. So guys, I can show you. Like now, I'm predicting it again by I'm taking the dynamic is equals to true, and the same thing. Now I'm trying to plot it again. Now I'm getting this type of graph, and instead of this, I'm using yellow color instead of K and alpha. So here prediction and forecasting is working almost correct. It's not properly correct, but almost is correct. It is giving me some inferences, but I'm getting that much error. So now if I'll try to show you the prediction average value. So guys, you can see it in this date, that much sales, the predicted sales we have. The value is coming in exponential, that much huge values we have. So if we have that much huge values on that time, if I'll see it, so this is the smaller number of error, na? The size of error is very small. It's not coming in exponential. If I rescale it on that time, when you are getting the error between, you are getting error like 0 point something on that time, you think it's working good. But on that time, we can rescale the data, no? Correct? And this is the truth value of 2017. And after that, again, if I'm checking the root mean square error, now you can see it. Now we have reduced it, reduce the error. Guys, how we reduce the error? Here you can see it. Here I'm getting the highest value, correct? Highest error value. That much error value. But if I want accurate result, if means if I want to if I want genuinely, if I want to work and if I want accurate result on that time with the help of this data, we can only use ARIMA. There are different models also there. I can show it to you. Guys, rest of the things are there. If I forecast it, this is the forecasting which we find. There's green color, this is the forecasting. Same data set, same way, but different approach. I can told you, like I can show you all the approaches, whatever the wherever the possibilities are there, you can see it. Importing the libraries, importing the data set, analyze the data, everything. Weekly sales, everything. But here I'm using some part of AI. That's why I'm not sharing this one. Here I'm checking the correlation. This is the another type of graph of correlation. Score everything, whatever the possible. All the insights we can find it, highest sales and everything. But here I'm using AI. That's why guys, I'm not showing it to you. You can see it. Here I'm using time series. Guys, I'm using different model. Whenever before coming to the session, I will try my all the possible outcomes. Whatever the things are possible with, means you can, if you are telling me any other approach, I can already try that one. Or if I think you are telling me something new, after that I will definitely try it. This date, whatever the actual value, whatever the prediction value, and I'm getting this much of RMSC and this much of RMSC by mean. Guys, I can tell you one thing. In this project, basically, we need to forecast the thing. But this is the complex data. Complex data means total 45 stores are there. If we have that type of, means that much stores, if we have that, because in real life, guys, we never find a simple data like air passenger. We never find this type of data which we directly apply the time series. If we directly apply the time series, no one hire the person to doing this type of things. I'm working with this type of data, like one of the file is there. Here I'm totally using AI, NLP. So bagging means reviews data, I can take it, finding these positive or negative sentiments. So EDA process, we can do that. Some words where we want to stop, some stop words. I'll deploy some features, bag of words are there. And at last, model deployment. So here I'm starting the model deployment with the help of pickle. Here I'm using the pickle and deploy the model, import pickle and deploy the model. After deploying it, whenever I'm giving any syntax, like here I'm giving predict bad product, don't buy this. So 0 and giving the negative is a negative review. So if this one is print, it's a good buy, it's good to buy. Buy this, waste of money. One positive. Positive and negative, we can deploy the model with the help of pickle. If you here I'm using beautiful soap and everything because I need to beautify it. Here it is not showing properly because Jupyter don't have that much, means that type of interface. If you want to properly deploy, you need to use PyCharm or VS Code for proper deployment.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
So guys, I think Numpy or Numpy, we pronounce a bit differently. It's very, very important, one of the important and key libraries in Python. Numpy stands for numerical Python. I think it was created in the year, developed in the year 2005 by Travis Oliphant, right? Basically, it is used for mathematical computations or scientific computing research areas a lot. But Pandas, a lot of functionality can be, well coordinated with Numpy as well. So I can take a quick example like np.where, right? So sometimes you can use this np.where function in your data frame as well to identify certain, to search certain criteria or to identify anything which you're trying to highlight in the data frame. And it can also be used in visualization as well. So let's say you want to, highlight a certain measure or certain value. If let's say profit is negative and you want to identify where the profit is negative in the data frame, and I want to color that profit as red because the profit is not actually profit negative means loss, right? So we want to highlight it with red color. So that kind of, quick to do things can be done with the help of Numpy as well. So Numpy, a lot of, functions can be directly used for your data analytics or data science, operations. So as and when required, I'll keep telling you these things. Numpy is actually, I would say, going to help you with a lot of matrix manipulation. So think about more like you're doing a scientific research and you're dealing with a lot of matrices, n-dimension matrices. There you can do a lot of linear algebraic operation with the help of Numpy. And that's where I believe that Numpy is solid alternative to MATLAB. Okay. And the cool thing about Numpy is that it is computationally very faster, given that it is developed on the back of C or C++. Okay. It is memory efficient, right? Because it stores its elements in the continuous memory. So I think I have a good comparison at the end of the Numpy that I'll show you, where I'll run some calculation on the list and same calculation on Numpy, and you will realize that Numpy is faster than list operations. Okay. Then I think I started with an example that why do we use Numpy? So there I gave you two lists, as you can see there, right, guys? So I gave you two lists, and I asked you that if I want to do element-wise multiplication, which I mean to say, if I multiply 1 into 2 or 2 into 4, right? So I am expecting that output should come as 1 are 2 is 2, 2 are 4 is 8, 3 are 8 is 24, and like that. So we realized that we cannot do a quick multiplication, just like, doing list 1 multiplied with list 2, it doesn't work. So inherently, Python is not designed to do vectorized operation. Later on, I showed you that if you can create the same thing in right in Numpy array, right? So it's very easy to do that. So how did I create a list? I can show you. I am taking a list 1. So let me run these boxes. So I'm taking a list 1, right? And if you can see what is my list 1, if I can print list 1, Okay, so this is my list one. So to get this list into array, so there is syntax np.array. So you can use this function and you can put it there, the list as it is, and you will get the first array. So that's how we are printing the list. Printing the array. Similarly, here printing the array 2 here, and then to multiply these two, you have to just do a simple multiplication of these two arrays, which is array 1 into array 2, this asterisk mark, and you can print it. You can see that it comes out to be 2, 8, 24, 40. So that's how we started, and then I explained, that what is one-dimensional array or two-dimensional array or three-dimensional array looks like. So one-dimensional array you will see here, right? So it's more of the concept of x-axis, y-axis, and z-axis. And there I took a very good example of sitting you in a room. So you can see this as x-axis, this is y, this is z. So likewise, if you think x is 0 is your x-axis, it's one dimension. If it is you are having two axes, x and y, it is two dimension. And the moment you go into more like a Rubik form, which I showed below, you have seen the Rubik's cube, right? So the moment you are looking at something as a 3D structure, that is your 3D array. So to visualize it better, I need to go to my writing pad. If you look at anything, so this is what 1D array. Okay, so it's like a line. The moment you look at a sheet, think as a paper, right? Sheet of paper. So, sheet of paper is what? You have x-axis, you have y-axis. What is this, guys? 2D array. The moment you think of a, out of the paper, you can create a sheet, cube like this structure. And wherever you're sitting, so let's say this is your x, okay? This is your y, and this is your z. It is your 3D structure. 3D means volume, right? You can put some volume into it. But if you want to look at exactly on this image, if I go back to this image, let me copy this image and put it on my Jamboard. Okay, so if you look at this, axis 0 is something that you will be concerned. What is axis 0 when you say that, sir? So axis 0, it your rows, right? Axis 0 in terms of Python, it is what? Row. Axis 1 is what? All the columns. That's what you have done in Pandas as well, if you have done earlier. But anyway, I'll teach Pandas. I'll explain more. So guys, this is one dimension array, axis 0. Axis 0 in two dimensional array is this one. So how many rows are there, guys? How many columns are there? 1, 2, 3, 3 columns. So that's why you can think it's more like a matrix, because matrix is, general matrix is what? 2D matrix, row and column, right? R by C. And what is the order for this? 2 by 3. Don't do 6. 2 into 3 is not 6. 2 by 3. Okay. What about this three-dimensional array, right? So think like that you have more number of 2D array stacked one behind the other. Think like that. Visualize in your head like this. So this is one 2D array, then you have another, then you have another, then you have another, and it keeps going like this. But looking at this, can you see that you have axis 0? Definitely, these are the rows. This is your axis 1, means what? These are your columns. And then the width, look at the width. Think like more like an object, like a matchbox. So width of this is what the third thing, right? So this is how many rows? 4 rows. How many elements in each of the rows? 3 elements. Can you see that? So that is 4 by 3. And how many matrices you are seeing? So it is 4, 3, 2. So I did one dimensional array. You have to import numpy as np. If you don't have numpy install, you have to do pip install. Okay, you have to do pip install, but it should run. You can also do import os. Sometime I need to check what is my current working directory. Now what I've done, you can see I've used this function np.array. You can go into this and understand the documentation. What is the syntax there? So we have to give an object. The object I've taken is as a list, and then I can also define data type. By default, it will be integer 32 bits, right? So if I 7 to 9, 10, right? Exactly, this is what I have taken. So what is this? This is my first array, which is what? I can also write 1D array, one dimensional array. Yeah, 1D array was 7 to 9, 10. Now I can check the type of this type. So what that should be, it should come as a array. Then I talked about some, numpy basic functions. So there are, 5, 6 functions. Number of dimension is given by endim. shape of the array can be fetched from the end. I think it should be the array. So let's say my first array dot shape, the size of each dimension. Size is total size of the array. Data type is data type. We know that item size is byte size of each array element. And if you multiply item size into total size of the array, that will give you the total memory used by the array itself. So let me explain one by one. Okay. So if I do my first array ndim, okay, if I run this is one dimensional, it will show one. So what is the meaning of this one? It is one dimension, right? Can you see that it is one dimension, just one axis? Now if I do shape, what do you guys think shape? It shows me the size of each dimension. So how many elements you have stored there? Sorry, what is my by default size of each element there? Okay, that is coming as 4 because there are four elements in that array. If I make it 12, let me show quickly. If I make it 12 means there are 5 elements. So if I run this, what will happen, guys? There are 5 elements in it. So ideally what it's doing, guys, in the array, it's counting how many elements are there. So as of now, I have just made it 5. It's showing me 5. Okay. So what? Let me, I think there is one typo there. So let me write. So what np dot shape does, it returns a tuple with each index having the number of corresponding elements. So it's more like number of elements. Okay. And those who might not be able to understand what is the data type here, you can go there and you can say print my first array dot shape type. Okay. So you can also print what is the type of this. Let me do in a new line and you will see that it is a tuple. So what is it? It's a tuple. I think tuple is a data type which you must have been taught, right? Now let's talk about size. What does size do? So if you look at that, it's a tuple, right? So if here it's a one dimension, the size is in each of the dimension, how many elements are there, right? So ideally it is total element for an axis given in that. That's why I've written total size of the array. So it's correct only. It's just that here it is one dimension. It seems to be all same. But let me go into two dimension and see the difference. Data type, it is in data type is integer 32. And there I also highlighted in the next line that if I take an array and if you force a string in the array, then you know that arrays are homogeneous. If you try to force a string with the numeric numbers there, right, integers, it will throw an error. And what is error? Error is that it cannot take heterogeneous data types. So one data type is int, the other is string. It cannot take that. So that's the error we have printed here. Okay. Now, what is item size here? So item size is byte size of each. So it is 4 bytes. Okay. This is by default. So it is 4 bytes. Item size in byte. And now if I do what is the n byte, it will show 20. Why? Because each element is stored in 4 bytes. And let me talk about it. I have my first array and let's say I'm storing there, 4 elements, 1, 2, 3, 4. Each of the element is going to be stored in how many bytes? 4 bytes. What is 1 byte? What is 1 byte? 1 byte is equal to how many bits? It is 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So similarly, you will be looking at, something like this. So this one is getting stored in how many bytes? 4 bytes. Essentially, I'm saying 32 bits, right? So if I go back there, what is this function is doing n byte? It's showing the total memory. Let me also write it. So I have changed the example. I'll write 4 5 equal to 20 bytes. That's your total memory stored. Total stored memory. So how much memory it needs? 32 bytes in the continuous memory. Okay, cool. Item size means what? Each element stored in how many bytes? So byte size of each array element. So that's exactly I was explaining, right? Each of this element is stored in what? How many bytes? 4 bytes. That's by default in array. Okay. That is your item size. Each element stored in how many bytes? By default, it is 4 bytes. That's your item size. Now, how many elements you have? You have 5 elements. Each stores in 4 bytes. You have 5 elements. each. So that's what I have created array 2D. That's coming from me. Okay. And I'll print it and I'll make this as raw format so that it doesn't run. Let's write all those basic functions. What is that? First, endim. So let me print endim. Let's print and start looking at it. What do you guys think? What should be the output? I'll not run. I'll first write everything. Then do shape. Okay. Then do what? Size. Then do item size. Come on. What is next? Then do n bytes. Okay. In case you're not comfortable with the syntax, you can always do tab. Let me run. How many array? How many dimension there? Let me also print. This is what dimension of the array. Okay, how many it is? It is 2 dimension. What is the shape? So you can also do this, right, guys? I think you are champion now. So what is the shape? 2, 3. 2, 3 means what? 2 rows, 3 columns. Now, what is the size? Size of array. So size of array is total number of elements. Remember that? So now you are not defining one axis, axis 0, axis 1. You are saying complete total size of the array. That's what I've written, right? It counts the number of elements along a given axis. By default, it will count total number of elements in the array. Please write it, which I have written earlier as well in array. Okay. So what is the size of the array? 6. You can see, right? 2 elements in the rows. 3 elements in the row and 2 elements in the column. 2 into 3 is 6. What is the item size? Item size is what here, guys? Come on, tell me. Size of item. So now, guys, you can see it is float, and float stores by default how many bytes? 8 bytes, guys. Come on, 8 bytes. So that's why it is 8 bytes. And what is total bytes of array? So how much it is? 48. 8 into 6, 48. Simple math. So this is all about your 2-dimensional array. I think now I will take the questions. So Abhishek, can we reshape it? Yes, we will do it. So array manipulation is something we'll do it later, Abhishek. Okay, so let's not jump to that topic. I'll teach you everything which you might have listened, you might have heard, you might have Googled. So wait for that. Okay, don't worry on it. Okay, last bit. Let's do a 3-dimensional array, and you will create for me. Let me show you the array on the screen. You can take any 3-dimensional array of your choice, because I don't have anything to give you as the image there. Okay, I used to have one image, a 3-dimensional array. Yeah. So yes, I got the image. Everybody will create this image. Create the array. Check the type of the array, whether it is array or not, right? And third, endim. Can you do that? Hint is, first let me show you 2 dimension. Let me cut this, guys. Okay, so this is your 2D one. Okay, please pay attention, guys. Please pay attention. So this is the first layer which I have taken, and I am saying np.array, right? And then within that, if I print it, array 2D1, it's a 2-dimensional array, exactly what we are seeing here. Whenever you do that, it is going to be 2-dimensional array. Means you will see that you are having how many lists? You are having one list within the other, nesting one list within the other list. So what is the outer list, guys? Please pay attention. Let me go into full zoom in mode so that you can see, my dear friend. See here, can you see this is the outer list, layer number 1. Within that, we have how many lists? We have 3 lists for each of the rows. Think like this. Let me break it. Then you will understand. Now, can you see that? You have one more nesting happening. Can you guys see that? Let me go. Now, can you see that there is one more list, which is the outer list? Then we have one list, which is the second layer, and then we have the third layer. Can you see that? 1, 2, 3 square braces, right? So ideally what we will do, we will create the 2D array. This is one 2D array, guys. That's your first layer. Let me comment it there. Section is what? Second layer of your diagram. This is your third layer, right? If I run it, bingo. See, first layer, second layer, and this is your third layer. Guys, I think this is tricky. If you are feeling it tricky, you are feeling it right. So you can do dot and them, right? You can do dot shape, then you can do size, total count of the elements, then you can do item size, then you can do what? Dot and bytes, and print everything, guys. Come on. Okay. This is something I hated. So there is a magic command in Jupyter that will print everything like this as well. But ideally, we should be in the habit of writing print, 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 because in Jupyter, even if you don't write print, it sometimes it works all the time, but in other IDE it doesn't work. So it's a good habit. I know it's a lot of typing there, but you should do it. So guys, please pay attention. N means dimension is 3. The shape is what? Row 3, column 3, and the layer 3, right? Total size is 3 into 3 into 3, 27. It is integer. Integer is by default stored in 4 bytes. So 27 into 4 is total bytes, 108. Can you please explain item size? So item size is default size of the, so let me go where I've defined it. So item size is byte size, default byte size of each array element. So integer is getting stored as 4 byte, float as 8 byte. So that's your item size. So for example, Shri, if you focus here, what is the item size for this? It is 4, right? So 4 byte. What is it? 4 byte. 1 byte is equal to 8 bits. So total n byte is what? Item size into size, which is 27 into 4, 108. What about data type, like for 1D array? So by default, data type will be integer. If you are putting a float numbers in your data, it will be float. So that's how, so right, your arrays are smart, so they can take the data type as they wish. Okay. So but if you want to give any data type, specific data type, you can always do that by using d type. Okay, which I'm not using, but you can always do that. So for example, let me show you one. So if I go there, I can say the data type is integer. You can see here 1, 2, 3, 4, it's integer. But if you change it to what? I think float 64. See, now it is coming as decimal. So that way you can also code it, right? You can put the data type. Now, let me put a new heading. So I want to teach you the next topic as initializing different types of arrays. Okay. So when you will be doing machine learning, right? So you might be creating some prototype code, and you might be looking at creating some random array. You might want to create an identity array, all elements fill up some same values, zero arrays, right? So all the elements coming as 0 there. So you can go ahead and think of like initializing different arrays as per your need. And that's where this topic is going to help you a lot when you're doing data analysis or data science thing. Okay. So guys, let me create my first array, which I want to fill with zeros. Okay. So I want to fill with zeros. If you look at this, syntax of, so you can give the shape of the array, and then it will do what? It will create a float data type. You can give the shape of the array. So I want, 2, 3, 3, 4, 3, 3, 3, like whatever. It will create that array. It will fill with all as zeros, which is 0 point, because the data type is float. Okay. And so I want to create, let's say 3, 4. So I want 3 rows and 4 columns. So total, how many elements I should be looking at? 12 elements. So this is my APC underscore 0 array. Look at that. Let me also print it, and you can see that it is what? So it will all 0, 0. You can't say that I want 3, 40. That you can also do that. There's no harm. You can do what? 3, 3, 3 as well. See, magic. So it's a 3-dimensional array. It is what? 2-dimensional array. And if I just say 3, it is what? 1-dimensional array. But all elements are filled with what? 0 values. Now guys, so this is your creating. So this is what? This is what initialize. Please let me fill this. Initialize with all the elements with 0. So that's the first thing we did, right? With 0. I can also do fill it with 1. How will I do 1? It's very simple. I'll just say APC 1, and there is a function in Numpy. What is it? 1, and just do that, and you will see that it's working. So all the elements will be 1. Can you see that? So Jitendra, I think I answered your question. Then you might think, no, I want to initialize with element of my choice. I like MS Dhoni, and I want to initialize all the elements of my choice with any fixed number, right? So I like MS Dhoni. I might think that I want to fill it with what? 7. So how will you do that? And that's where you will use np.full, right? np.full. You can see that in the documentation. What is it? Filled with the value, and you can take that value as any number there, right? So let me show you. I think syntax you can see later. So you can do np.full, and that's where you have to also give a number. I want to give 7, right? So it's call it as APC full. So with any fixed number, I am doing with 7. What do you guys think? It will work? The only difference, if you observe clearly, that I have given a number 7, right? So that's why this 7 is coming. If you want to do Sachin jersey number, you can do 99. Can you see that, guys? Come on. Then somebody say, no, I don't like this. I want to put my name there. You can put your name. You can say what name you want. I can put my name, APC, APC, APC. Can you see that, guys? Come on. By default, it will try to see what is the data type. Okay, so you can do that, right? So APC full, let's see what is D type there. See, so that's for string. Okay, U3 string here. Okay, what about here? Come on, APC once. What is it? It is float. By default, it will take float. Even if you are writing as integer, it will take float. Let's see. So you can do that. APC once is float, but not APC full, right? So no, sorry, this is okay. This is anyway float. You can do that. And let me do APC full. What is it? I need to run this, huh? So first I'll run this because then only I'll know it. What is it? Integer 32, guys. Can you see that? So since it is integer, APC full is what? Integer data type. APC1 is what? Float. It is float. You can also fill random numbers. So you can also fill random numbers in an array of dimension x by y. Okay, x by y. So how can you do that? Let me show you guys. For that, we have a function, and that says, let's say APC random. And what is it? It is np dot random, and it has a lot of, so you have a lot of the random integers, random sample, right? So explore through everything, right? So what is random integers here? You can explore everything, but by default, let's start with random first, right? So when I say random, you can take, right, random numbers of any shape. So I can say 3, 3. Now you can see if I print, just remember this syntax for a moment. Even if you don't remember, that's fine. But you can see that it can fill, right, with random numbers, right, of the shape 3 by 3, 3 by 3 by 3. Can you guys see that? So this random numbers, right, it's going to be very, very important for your machine learning thing. So suppose you want to randomize few things there, right? So what you can do, you can start here, you can create random numbers using these functions, right? So random is very, very important. You can also look at random integers. What is random integers? So if I ask you to get random integers number, print random integers of any shape of your choice, 2 by 3, 3 by 3. Random integers will be your integers. This is what? This is float, and that is between 0 and 1. I am trying to ask, can you plot random integers? Integers will be like, integers, right? 1, 2, 3, 6, 7, 100, 200. That's integer. You are not interested in float. You are interested in integer. How will you do that? So the syntax is np.array. Then let's say you want to create 1D. You're interested in creating 2D array. So what you will do? See, you will start with one square braces, and then within that you will put another list. Can you see that? And then you will say, let's say 1, 2, 3. Okay, that's one list. And then you'll create another list after comma. So you can enter that and then press enter there, right? Did you notice what I did? So first I created one square braces. Within that I created one more. I completed 1, 2, 3 there, and then I created another. But before I did that, I put a comma there and I'll write 4, 5, 6. Is it okay? So now this is your 2D array. Izada, this is for you I am doing, okay? This is your 2D array. How will you check it? You can check apc.ndim. Please copy it, okay? Now, similarly, you can go and do a 3-dimensional array. How will I do it? So for that, let me show you again. So for 3-dimensional array, I need two 2-dimensional array minimum. So what I'll do, please pay attention, observe very clearly. Guys, give me one moment. I need to help your fellow students. For that, now you need minimum two 2-dimensional array. So what I'll do, I'll create one more outer list. Can you see that? See, and then before this, I'll put a comma and I'll press enter. I'll copy this 2D array, which is this one, as you can see, and I'll paste it here. Okay, and you can put some different number there, right? Random numbers. See, now if you focus, there are 3 complete square braces. Okay, and this is your 3D array. Let me show you. So now can you see that? This is what? This is 3D. I hope you should be good now. I don't think you did not have got it, right? So random integers of any shape of your choice, I can say APC random integer. I'm naming my object. How will I do it? So the function says, what is it? np dot random dot rand int, right? Rand integers. And then what you have to that, you have to look at the syntax in case you are not sure about it, but it's very easy. Okay, let's focus on it. So you can put any list, any array there. Then what is it? It says, size and data type integer. By default, it is going to be integer. There's no data type option as such, right? So whenever you want to get into the syntax suggestion or document, you do shift tab. So you write that function. So guys, there are basically 2 tabs, two press buttons. When I write np dot, if I do tab, you will see all the available functions. Now I want, so I vaguely remember it is random. So I'll write RA. Then I see, okay, random. I'll select by moving the arrow. I'll press enter. Then I say, let's say what is within that. So I'll do tab. Then I see all those things are there. Now I vaguely remember that is rand int. So I'll do rand int. And I want to go into the documentation. I'll do shift tab. So for documentation of syntax, shift tab. For suggestion on the libraries within libraries or functions, you will do that. Okay, you will do tab. So I'll say low equal to 0. Let's say high equal to 10. Okay, and size equal to 5. Let's see what happens. What do you guys think? What did I get? So low and high is more like lower bound, upper bound. If you say something, can you see that? So it can take number which is within this range, right? Okay. If you don't give it, what do you guys think? It will run or not? Come on, guys, think about it. It will not run. You need to initiate it. Okay. But let's see if I don't give high, what will happen? Come on. It will not run, right? Because we need to highlight it. Okay. That what is within the range. Okay, cool. Now this is just a very simple way of initiating it. Okay, guys. Let's say I want 2, 3. So 2 rows, 3 columns. Okay. And I want these guys have to be in between 0 to 10. Can you guys see that? Beauty. So what is this? This is your 2D random integers array. So that's how it creates. np.random is a very useful function within the Numpy. Numpy library. Okay, so within that you have a random function generator that has been written. We are not going to run it or write it again. That is already written there. We are just leveraging that function. If you are asking what is the syntax there, so low means lowest value, high means highest value of the integer, and size you already know it. So random integer, definitely there is a big logic running behind it. Let's not get into it. Okay, it's none of our business also. Okay, we are not learning that here. Now let's say I want to create a 3D array. How will I do it, my dear friend? Size is more like shape, 3 comma 3 comma 3, and I want number between 0 to 100. Okay, look at this. So guys, if you focus here, np.random dot rand, right? There are so many random functions are there. Random sample is also something you will learn more on when you are doing a machine learning thing. So I'm just telling you important in the key ones, and you guys know it, right? Python is really vast thing. It's like ocean. We cannot boil the ocean in this, these 40 hours. Please be mindful about it. Good. So if we are good, so we learned how to create numbers, random numbers. I think we are good. Now let's say if I ask you, how can you create an identity matrix of 3 by 3 by 3? So let's write print an identity matrix of order. First, let's do 3 by 3. 3 by 3. So it's like 3 by 3 is what? Shape is 3 by 3 means what? It's a 2D array, right, guys? It's a 2D array. How will I do that? 2D IM, identity matrix. What is that? APC, sorry, identity matrix 2D. Okay. So I'll say, np dot identity, right? And what you will do, you will say now some of the guys are asking what is an identity matrix. So let me talk about it quickly. How will you get integer data type here? Come on. So if you go into the syntax, right, you can assign the data type. So you can say d type, please pay attention, comma d type equal to int 32. So that data type is by default float. You can actually handle it and you can make it, integer. Okay. What else? So this is good. This is good. Now, guys, let me go into the very, very important topic, and that is indexing and slicing. So now, guys, let's put here the new heading, which is what? Indexing and slicing. I think indexing and slicing something you must have been taught. For this batch, I have taught indexing slicing list. Similarly, we are going to do here as well. Okay, so what is the difference between indexing and slicing? So please write index is what? Index refers to the position of an element in the array. Okay. So if you see here, so I've written here Monty Python. Can you guys see that? Monty Python. So think like it's a list. For now, think it like a list. So guys, you know that indexing Python starts from 0. It doesn't start from 1. You guys should be aware of this thing. Indexing in Python starts from 0. It doesn't start from 1. Always keep that in mind. So it is starting from 0, right? Now you can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then this is like going towards positive indexing. Can you see that? This is called as what? Positive indexing. And if you go from, so this is going from what? Left to right. And this is like what? What? Right to left. So it starts from -1. So think like that. How does it happen? So this is like 0, 1, 2. If you go left to right, the moment you go backwards, so backward is like this. More like, starting from -1, -2, -3, -4, -5, and all that. Okay, clear? So that's what we call it as index, right? So you go and actually search or check, right? What is at 0? What is at 1? What is at 2? So to show that, I know this is not a very good annotations we have done here, but still I'll keep it. I think there's some issue today. I don't know. Something is happening. I'm not aware. But let it be part of the notes. Left to right, positive indexing. Right to left, it is negative indexing. Okay, cool. Let me take this example. Okay. So if I take a simple list, 1, 5, 8, 12. This is a simple list. Let me run it and print it quickly. Now, if I do APC 0, what do you guys think what I'll get? 1. If I do -1, guys, what I'll get? Come on, help me out here. I'm just recapping what you must have learned in the list, right? -1 is 12. So that's indexing. Okay. Now, what is slicing, my dear friend? Slicing is like, creating a subset of an array. So you can slice across multiple dimension in Numpy, right? It's more like taking a segment out of it. So it's like, you have a big thing there. So let me take quickly here another image. So guys, what is slicing? Slicing, have you sliced butter with a knife? Everybody must have done it, right? So slicing is just like slicing a butter. So what do I mean by that when I say that? So you're looking at this, right? This is a 2D array. Can you see that? Now it's working fine. Very good. I'm happy. This is a 2D array. Now let's say I want to slice this piece. I think we can do that, right? I want an array out of an array. Can you see that? I'm interested in this guy, 5, 6, 8, 9. Later on, I'll show you when we do it, right? So this is what we call it as what? Slicing. And you might have seen syntax like, colon, colon. Remember that? Something like that from list. Something you should remember that. So this is how you will use it. Okay.
Let's have a quick quiz question, guys. And the question is, which of the following is a common method used to select a subset of data from Pandas data frame? And your options are filter, select, slice, or iLock. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Cool. So now let's say I'm interested only in a row, right? Let's say I'm interested in a row, only first row. So let's say this is your array. Let's say this is my array 1. So I can say array underscore 1. If I do 0, what it will do, guys? Come on. It will include all the elements from the first row. Let's go there, right? Let's code it there. Why to waste time? So let's code it there. Let me take this, not this. I will just take this part of the image. I'll place it here to explain slicing. So now what is slicing? Let me quickly write. Slicing helps to build. Please write with me. Oh, you can ignore. I'll share the notes. Build new arrays out of an existing array. Can slice across multiple dimensions. So these are the 2 bullet points. I think we should have it with us. Okay. So this is about slicing. This is about indexing. Cool. Now let's go into the coding bit. So let me take the same array. So array 2D. Let's take it, guys. What is it? np.array. Everybody will do with me. np.array. List within the list. And I'll take 1, 2, 3. Come on, guys. It's very easy. We can create it fast. Bingo. Let's guys do it. 4, 5, 6. Don't miss this commas, very important. And what is it? 7, 8, 9. Everybody needs to code. If I am coding, guys, I'm not just copying pasting the code, right? You can see that I'm coding with you. You are supposed to code, else you will not run, else you will not learn. Okay, guys? Aap seekh nahi payenge. That's very important. You do that. This is my 2D array. Give me the first. So if I do array, just focus, guys. If I do array 2D, now if I do 0, let's see. I'll get the first row. What do you guys think so? Right? I'll get the first row. If I do 1, I'll get the what row? Second row, guys. Come on, can you see that? 4, 5, 6. Likewise, if I do 0, 1, 2, I'll get what? If I do 2 means what? It will be third row. Always n minus 1. You want nth row, you have to do n minus 1. Is it clear, guys? Come on. Everybody is okay? So this is a general intuition towards it, right? This is a general intuition towards it. But this is not enough, right? This is not enough, because this is going to be a very, very, strong indexing or slicing. And what you are looking at is not enough, trust me. And for that, let me show you the nitty gritty of, slicing. So whenever you are doing a slicing, let me show you a diagram, okay, which we have created for you. So I means row and J means column. So let me take, can you see this diagram, guys? So here I means what? Rows, and J means what? Columns. So even in matrix, right, you must have heard about, right, I comma J, isn't it, guys? Come on, I comma J, right? So I means what? Row, please keep this in your mind, and J means column. So if you want to go across the rows, can you see this arrow? It is I. If you want to go across the column, it is J. And this is what? This is a two-dimensional array. For now, just focus on two-dimension. Two-dimension. Don't focus on three-dimension. You will not understand it. For now, just focus on two-dimension. So if you notice the syntax right here, so please focus. I means what? I selects the, let me write, I selects the row, J selects the column. Let me give you this. Okay, this is part of the image. Okay, guys. If I'm interested in row number, sorry, if I'm interested in element 5, how will I get 5? Print element 5 from the array. It is what? Array underscore 2D. And just keep this in mind. You have to do indexing there, right? I'll say don't do parenthesis. It is what? Second row, second column. So it should be what? 2 comma 2. No, sorry, 0 1 0 1. So guys, always remember that it is starting from 0 0 1 2 0 1 2. So it is in what position? 1 comma 1. I think I also missed that. That happens actually. That's okay. Now tell me, how will I get 7? Print element 7, guys. Now what is this? That is at second position, but index is 0 for that. Correct, guys? Column index is 0. Now, guys, I am interested in the last column. How will I do it? So what is the syntax? Print the last column. Now you remember the syntax that if you write colon, it means every row element you need. Then you will do comma. So what does this guy mean? This colon means what? Please write here. Colon means, so this is like accessing through positive indexing. So I do positive because I am positive. I was COVID positive. I am a positive personality. This is just kidding. Huh? Don't take it seriously. But yeah, I had COVID here. So COVID positive is something. Everybody is good about life, right? They want to be positive in life, but nobody wants to be positive for COVID test, right, guys? Just on a lighter note, okay? This is my matrix, right? Or array, 2D array. Okay, everybody please pay attention. So when you write within this, right, comma, so if you do put colon here, which means what? Please focus. So let's say this is your 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'm interested in fetching what? I am trying to get this column. So what is this column? Where it is? Please pay attention. It is at what location? Index 0, 1, 2 column. So it is column number 2, right? At the location 2. What is the row here? 0, 1, 2. If I'm interested in this particular set of element, does it have all rows? Guys, come on. All row means what? Rows is like this. Yes or no, guys? It is a yes. Hello? So I want all the rows means what? I'll do colon before the comma. It says all rows. Now I'm only interested in this position. I'll put 2 here. That's exactly we have done, right? What I've done, focus, colon all rows, comma 2. And negative indexing is what? -1. How does negative indexing work? The moment you go circular like this, you will do what? -1, -2, and -3. So this is how do you play with your 2D array. So let's, if I need the middle one, can you get me 5, 6, 8, 9? So this is your 5, 6, 8, 9. Let me fit in there. Okay, this is your 5, 6, 8, 9. So it is what? It is starting at index 1. So row 1 till the row 2, column 2 till the column, sorry, second column till third column. We don't need this guy. We don't need this guy. So it's more like matrix determinant, right? So you used to eliminate this row, this column, right? And then you used to get this 5, 6, 8, 9. How do you find determinant? Remember that. So what is the code for it? How will you answer it? It's very easy. It's array 2D. Now I need all the rows starting from one column. So guys, let's figure it out. See how we can go there. So I want to get what column? I want to start from 1 till the end. So I'll start from 1. So column is, comma is what? After column is after comma. So I want everything starting from 1. Let me do just play with you guys, right? What is this? This is all the rows for the columns what? 1, 2, sorry, 2, 3, 5, 6, 8, 9. Can you guys see that I've got it? 2, 3, 5, 6, 8, 9. How did I get it? This means what? Till the end, right? So if I start from 1 and I want to get all the columns there. So what is it? This is column number 1. Till the end means what? I'll get this column and I'll get this column. See, you need to understand the syntax, right? So within the square bracket, we have comma. Now we have this dot, start, stop, right? So if I say, so index is 0, 1, 2, don't forget that. Across the columns, across the rows. So this is your rows and this is your columns. So the moment I write one column and I stop there, what it mean? It means I'll start from here, follow the green color. I'll start from here and I'll go till the end of the columns. I don't know how many columns are there. If it is more, I'll take more, but I'll go there. That's what I mean. So this is like start and there is no stop. Stop till the end of them, right? Similarly, if I say I want to start from row 1 and I want to go till the end, means what? I'll start from row 1. I'll go from till the end means what? Start from row 1 and start from column 1, where these two lines are intersecting, guys. Come on. At position, at element 5. Can you guys see that? So I will actually capturing everything which is coming in this box. Let me replay for you guys what I did. If I'm starting from second column till the end, so this is what this box will. Try to create these lines, guys, in your head. And if I start from second row onward till the end, so the line will look like this, guys. Can you see this intersection point of these two swastik? Good, got it? Everybody, give it a shot, you'll understand. So now tell me, what is it? It's very easy now. I'll start at row 1, I'll start at index column 1, I'll print it. See, the output is in front of you. So what I need, guys, always think through. 4, 5, 7, 8 means I'll start from what column? Column 0, but I'm not going till the end. So how will I start? So how will I write it? I want to start at column 0, but I want to stop at 1. And you know that in Python, anything which you write after colon, it is not included. Okay, so we'll stop at 1, right? Or you can also think, so I need 4, 5, 7, 8. So I'll start from 0 and I need to stop at 1. So I'll write 2 because 2 is not included. So start from, and then I'll say 1. Let's see what is it. Right? Done? Then there are other answer as well, right? So I'll do what, sir? I'll do 1 colon, comma, colon 2. Yes, you'll get the answer. But you need to understand what you're doing in each of the cases. What I've written here and written here, it's same. Because if I'm not saying from where to start, I will start from the start. Or you say it explicitly, I'll start from 0. What is happening here? You are saying that same thing. So these two are the same only, right? Now last question on this, and then we are good. Give it this. I want just 2 5. 2 5. So I am trying to fetch. I am trying to get this guy. 2 5. 2 5 means what? What is this position? 1. And how many rows are there, guys, which are included there? This means rows is what? 0 to 1. Column is just 1. So ideally, when you do from here to here, right, something like this, and you just take this column, this column, so it's very easy now. You will take row 0 and row 1. So you will just take continuous from 0 and 1. So that will include 2 and 5, 1, 4, and 3, 6. And then you will say, I need one column. So it will be just column 1, means column 1 is what? Index 1. So how will you do it, my dear friend? See, no slicing here. Why is slicing? It's just one column. So just 1. And you start from where to where? 0 till 2. Done. You start from 0 till 2. Remember that 2. When you write 2, 2 is not included. Why this is just 1? Because it is just one column there. This is a single column. So whenever you are writing a single column, single row, you just write the position. Come on. You don't do this, you don't do this column thing, slicing thing. You're not doing slicing. Slicing is to get into subset, means more than one. Okay. Now, guys, I have to do bigger tasks. Indexing and slicing in 3 dimensions. But I am not sure, are you ready for it? So let me give you the 3 dimension which we created earlier, right? So this is the 3-dimension array, array underscore 3D. And I can print and show you how does it look like. And the good news is that I also have the image there. Okay. So that's how it looks like. Please pay attention. This is like stacked 10, 11, 12, 13, 14, 15, one behind the other. And if I can show you what is one behind the other, the image looks like this. So there are 3 2-dimensional arrays. We can also say that. Or there is one 3-dimensional array. This is the array we have already printed for you guys. There should not be any doubt. Now, how will you index it? Or how will you index or slice it? So guys, first you understand the logic here. So can you see there is a red arrow button I? So in 2D, I means row. J means column. Please mind it. In 3D, I means what? It doesn't mean row or column. It doesn't mean row or column. I means select the matrix. There are 3 matrices, one behind the other. What is J means? Select the row. What is K means? Select the column. I am interested in 23, 24, 25. Cool. So I was trying to reduce the size of the image, but that's fine. So let's call this, what is the array name I have given? Array underscore 3D. Guys, let's discuss this first, right? So how will you crack this? So I know a lot of people must have got it. First thing first, you have to select the layer. So how will you select the layer? You will say array underscore 3D square bracket. First, what is the layer? 0, 1, 2. Indexing is always like that. So which layer we are interested in, guys? First 0 in there. Hello? So I'll say 1. This is as good at selling what? This is 0, 1, 2. So first row, and you want everything there. I think this should work, right, guys? Let's try. I am also not getting the detail of it. I will just code it. So what is it? Array equal to, sorry, square bracket 1 comma. First, I can just write this. It will work. 23, 24. I don't need to go into the detail. If I just do this, which I have written, still it is same, right? So guys, you can stop here. That's fine. But the good practice is to write this. It means what? Column is what? All the columns. All the columns. 23, 24, 25 is all the columns. Okay? It's very simple. But other way of doing it, what? You can just write this. Should be fine. Okay? Now, guys, I'm interested in something else. I'm interested in the last guy, 32, 35, 38. So I am interested in 32, 35, 38. Surely hold on the negative indexing. First you learn positive. Let's not try to jump, to difficult part. You can practice, explore later, but first let us learn this. Guys, I'm interested in the last one. How will I get it? Always remember that, guys. When you write this, what does it mean? It means full slice. In this case, full slice, right? Whenever you just write column, it is full slice. What is this? This is also what? Full slice, but this is full slice across the rows. So how can you write it? You can say I am interested in 2 position, all the rows, but see, last column. Isn't it, guys? Come on. You can also explore. If I don't do this, what will happen? If I just say this, what will happen? It will give me the last layer. Can you guys see that? It is printing the last layer because you are taking the full slice, but you are interested in all the rows but the last column. So once you will explore this, you will get it more. So that's what you should do tomorrow morning. Now I'm going to ask you something difficult, okay? Something difficult. What I'm interested in, guys? I'm interested in number 15, number 25, and number 35. I'm interested in 15, 25, 35. So guys, you need to pick one from the first layer, one from the second layer, one from the third layer. So definitely you need something from all the layer. So all the layer means full slice. Then what? See, you need full slice. See, if I do full slice, what does it mean? It means everything. If I do full slice, a comma, still everything. If I do full slice full, still everything. Full slice first column, 11, 14, 17, 21, 24, 20, 17, 31, 34, 37. Means it has taken the second column from each layer. Last column from each layer. If I do 3 means what? Error, because index is out of bound. The highest is 2. Negative index. Negative index means what? The last column only. Minus 3 means the first column only. If I do this column means full slice. Full slice. Now I want to start only first layer. First layer full slice. See? All the rows, all the column from the first layer. Second layer, all the rows, all the column from the second layer. Third layer, all the rows, all the column from the third layer. All the layers. Column means all the layers. Full slice means all the layers. Now I want only the middle layer. Middle layer, all the rows, my bad. All the layer, but second row. 13, 14, 15, 23, 24, 25, 33, 34, 35. Now we are not interested in that, right? This is all chindi. This is very easy. We are interested in something else. So see, the moment you say 15 here, 25 here, 35 here, it means what? You need every layer with you, because if you take one layer out, you cannot get it. That's pretty simple. I need 15. Where is 15, by the way? Can you see a pattern there? 15, 25, 35. Yes, there is a pattern. What is this position in this layer? It is what? 0, 1. There is a pattern, and if you see the pattern, you can clearly see that what is the pattern? This is 0, 1, 2, 0, 1, 2. This guy is sitting where? The position is what? 1, 2. Same here, 1, 2. Same here, 1, 2. Means what? You need every layer, but you just need one position, and you say, I can do in mean layer. So Numpy is going all for you, right? So now I am interested in what? I am interested in this guy. I am interested in 13, 14, 16, 17, 23, 24, 26, 27. Only these two guys. So guys, this is in the first 2 layers. So you know you need to do that slicing. So array underscore 3D, and I need first 2 layer means what? I'll start from, so see, comma, comma. This is like every layer, but I just need 0 till 2. So I'll do 0 to 2. And full slice, full slice. See, Means it is giving me first two layer. You can go in, you should build it like this. So 0 to 2 means what? 2 is not included. You remember that, right? Last, whenever you write after colon, 2 is not included. That's why 0, 1. So these two layers you are seeing, and all the rows, all the columns. Okay. But do I need all the rows, all the columns? No. I need last two rows, first two columns. Can I say that? Last two rows, first two columns. I'll say I need to start from 1 till the end. This is 1 till the end. And this is also 1. No, sorry. 1 till the end. This is correct. And colon is not like that. Colon is first two column. So we'll say 0 to 2. See how easily I'm doing it. And that way you will be able to do when you practice like me. Think, go watch my lecture, follow through how I'm teaching, how I'm doing, and that will help you to get it done. Okay.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
3D is something you might not be able to understand if I would not have shown you these images. So definitely credits go to the right people who have created this visualization, but a bit of credit should come to me as well that I'm using this in my session. Isn't it, guys? I could have started saying, okay, visualize 3D, and you will not be able to visualize 3D, right? But anyway, that's how I teach, and definitely it's always a team effort. Somebody must have created these kind of images, and I'm smart. I'm using it, and definitely I'm giving the credit. So let's say one day when you find these images somewhere, you know that that person has done a good job. Okay. So, but at the same time, it's very important that you see the images, because a picture is worth 1,000 words, right? When I'll teach visualization, I'll keep showing you images. So a visualization is always, worth 1,000 words, right? You can write 1,000 words and you just show one image, it's equivalent. Do you guys think we should do mathematics? Okay, so please put the heading, guys, array mathematics. So first, I'll quickly give you the importance of array mathematics. And this is just going to the beginning of it, because a lot of things I'll teach here. And these are the functions you should know. These are very straightforward, written in plain English. So let's talk about one by one. So what is sum? So you want to do addition of, two arrays. You can do that, a comma b. So np dot sum, right? Difference, np dot subtract, divide, dividing a with b, multiply, exponential, square root, sine, cos, log, right? So these functions you should just keep in mind, and I'll also put it here. But this is just the starting. I'll do a lot of juggling with the maths as well. So I intend to teach you the matrix addition, transpose, multiplication, matrix, multiplication, addition, subtraction, that's fine. I'll also teach you, vector, dot product, cross product. So a bit of maths I'll teach, okay, being the maths teacher here. But trust me, ideally we will not be using everything here, but let's do it. Okay, it doesn't harm. So you can do a simple np dot sum as well, by the way, and you can take two numbers and you can sum it. So that's like the simplest summation. So you have two numbers within this and you can sum it up. Okay. Similarly, you can go one step further and you can have two arrays there. So let me take two arrays. So I think array 1 we don't have. Okay. So let's have array 1 np dot array, and it is, let's say, 1, 2, 3, print array 1. Let's create a couple of arrays. Yeah. Let's create another array, guys. Let's call this array 2, and let's call it as 4, 3, and 2. Okay. Now, so if I want to add this to array, I'll say np dot sum array 1 comma array 2. We need to do this. Yeah. So what it has done, it has summed everything. because you have not written whether you want to sum at what level. So you have to sum it at axis 0. See, did you notice something, guys? If I give you the syntax, go into the syntax. What is it? So A is your array element. Axis means what? You know, across the rows or across the column. So you can sum it. If I don't give it means what? It will sum everything to everything. So 555 is 15. Can you see that? But if I say axis 0, it will sum along the row. So it will be 1 plus 4, 5, 2 plus 3, 5, and 3 plus 2, 5. Now this summation can be tricky, that if you say, okay, I need, 2D array. What is 2D array here? So this is a 2D array. Okay, very good. Now I want to change something in this array. So I want to also access the array and I change the value there. Can I manipulate it? I think I can do that. Every position on the rows, and in the second column, I want to put 100. And if I print it, I have replaced last column of this guy. What was this? Now, since we have changed this array, so we can't do much. That's fine. So it was 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? You can see that 1, 2, 3, 4, 5, 6, 7, 9. What I've done, I have taken this position and I have called it as 100. Okay. So everywhere it has worked it fine. So 1, 2, 4, 5, 6, 8, 9, right? Import numpy as np, and then you run this code, it should work. Guys, please pay attention. Now, what I'm trying to say is that you have one array like this. It's a 2D array. Okay, so let me create 2D array, two 2D arrays, and then I want to add these two arrays. Okay, so let's see, can we do that or not? Okay, so this is one 2D array, and I want to create array 2D2, and I'll do np.array list within the list. So I'll say, 99, 98, 0. Ta-da. Then it is what? 96, 95, 0, and then 93, 92, 0. So that's my another array. So why I have intentionally taken this, so that when I add, this will become 100, 100, 100, 100 everywhere. Right, guys? Do you think it will become 100, 100 everywhere? I think so. Okay, let's see. So now this function which we are doing, np.sum, now this is your array 2D. That's the first array, guys. And this is your second 2D2. And I want to add across the column. Look at this. So what has happened? Across the column is what? You have added this guy. What is array 2D? Array 2D is this. I think 2D, well, 15, 300. So I understand why it is coming 300. No, this is not something I was trying to do. I'll do this in a different way. And then I'll just do plus. Okay. This should work. Yeah, this is what I was trying to do. So guys, that's another way of doing array element-wise operation. The moment you put plus, it will add one element with the other element at the right position. So 1, 1 will add to 1, 1, 1, 2 will add to 1, 2. That's why you're getting 100, 100. That's exactly I was wishing, right? So that is something you will also learn, which is known as arithmetic operator. This is based on operator, not on np.sum. np.sum is not what we have done there. np.sum I have done in the first case. So now, guys, I'll quickly get into the. So this is all about summation, which I was thinking. We will discuss more, right? Summation in different ways, right? It's not that just we will do that. There are a lot of things we will do. Okay, it's not only about it. Now let me go and show you np.subtraction. Okay, np.subtract. So suppose I take the same two arrays, np.subtract, and I'll take what? I'll take array 1 comma array 2. Now I need to focus. What was array 1? Array 1 is 1, 2, 3. So let me first print, then only you will understand. Print array 1, print array 2. It has subtracted, right, like this. 1 minus 4 minus 3, 2 minus 3 minus 1, and 3 minus 2, 1. That's how it has subtracted. Since you are not telling how to subtract, okay? But let's say if I say, and if you can go to the syntax, what is it? It says, give me two arrays, x1, x2, and then there is no access thing they're telling, right? So you can also do basic like 1 comma 4, whatever you put, it will subtract. So it will do 1 minus 4, okay? Yeah, so that's the basic thing it does, okay? Now if I want to do in a matrix, right? So let's say you have a two-dimensional array, what will happen? So if I say np dot subtract, right, and if I say array 2D and comma array 2D2. So what had happened, guys? Can you see that? Please pay attention. First, you should know what are these two arrays, huh? Otherwise you will always be confused. Print array 2D and print, because so many arrays we have created now today. Yeah. So what it does, guys, 1 minus 99 element wise minus 98. 4 minus 96 means what? Minus 92. 7 minus 93. How much is that? Minus 86. That's what it subtracts here. Subtract the second array from the first array element wise. Now you want to subtract within the array. That's also possible. That also possible, right? So if in the matrix, I can give an application here. So when you are doing a matrix thing, right? So if I go to the Jambo, so if you are doing a matrix thing and you want to do, so you have a matrix, let's say you have 10, 8, 7, 5, 15, 12, 10, 20, 15, 12. Now in matrix, you must have seen a calculation like this, R2 minus R1, right? And R3 minus R1. So for this, what you will get the output here in matrix, this will be same because this is your base row, row number 1. But when you say R2 row 2, so this is R2, this is R1, this is R3, you'll replace R2 with what? 15 minus 10, 5, 12 minus 8, 4, 10 minus 7, 3. So 20 minus 10 is what? 10. I'm not able to write. Yeah, this is 10. 15 minus 8, 7. 12 minus 7 is 5. 10, 7, 5. This is something we need. This is something we need. And how we can do that in Python? So first you create this, you create this matrix mat equal to np dot array. So I can do that. Somebody can help me out here, or I can just print it. 10, 8, 7. So I'll not take much time. It will be real fast. Then 15, 12, 10, comma. And what is it next? 20, 15, 12. Okay. Now this is the array which we are interested in. Print mat. Okay, guys. 10, 8, 7, 15, 12, 10, 20, 15, 12. Now I want this operation row wise. How will I do that? So then we have a function called np.diff, difference, right? More for matrix application. And you have a matrix array and you want to do what? Do this across the rows. We will do this. But does it exactly give what I need? This will not work. So it gives 5, 4, 3, 5, 4, 3. Okay, so it does R2 minus R1. Okay, so guys, what it has done, sorry, my bad. So there is a change. It does sequentially, not like this, not like typical matrix here. So I'll tell you what it has done. Let me just make that correction from my side. It's my bad. So this is not the step we have done. What we have done, my dear friend, we have done R3 replaced with R3 minus R2. So basically, this is fine. The last step will be what? It will be what? 5, 3, and 12 minus 10, 2. Okay, guys. So, and then it prints only the last two because that's the output of it. So 5, 4, 3, 5, 3, 2. So that's what you will see as the outcome here. Okay, this is the outcome you will see there. So let me, so not exactly matrix 1. I thought it will do that, my mistake. I think there's a different function for it, but not this one. So this is what you will get one level down. So it's more like a minor of that matrix. Okay, correct. So guys, let me take the screenshot again and put it, because that's what I have put it is not exactly the function I was trying to explain. Okay. Good. Everybody's clear. Just please correct it in your head that what I've just shown you guys is what it gives you a sub matrix. You can think like a sub matrix, but delta of what? R2 minus R1 and then R3 minus R2. Clear? But you might ask where I will use and all. So I cannot exactly tell where you will use, because this is, that's why I told you, right? Pandas is going to be the biggest thing, not Numpy. But we are supposed to do everything, right? Now, if you want to do access across columns, what will happen? Now it will be, right? It will be what? 10 minus 8, 15 minus 12, right? So do that. So it will now subtract across the columns. So what has happened? 8 minus 10, 12 minus 15, 15 minus 20. So minus 2, minus 3, minus 5, and then 7 minus 8, 10 minus 12, 12 minus 15, which is minus 1, minus 2, minus 3. Okay. So these are, so other functions are also there. You can play around. Let's say our array 1D. Guys, you need to do this import. If you're restarting your notebooks, you have to do this as a part of ritual. So let's take array 1D, and I need to create an array, np.array. And I can say 1, 2, 3, 4, and let me print array 1D. So this is the array. So I think in this array, if I'm interested in getting the, let's do for the first, 1D array, easy to understand. So the question is, guys, how to get first and last element of the array, right? I think a lot of people said that you can do this, but I think what he's trying to ask, not like individually, right? So you can do this, that's there, right? I think this is something we can do that. So this is first and last element. So you wanted to get it in one go, not like individually, right? There is one operator, double slice, right? So if you do double type colon, it means it will print. Let me also discuss this real quick. Print all the elements in the list, means it's full slice, row and column in the array, sorry, not list. So you can see, right, if I do this, it does print. Guys, please focus. Now let me take a shot here, okay? And now I need your full attention here. So if I do this, what it does, it will print all the elements of the array. Is it okay, guys? Cool. Now please pay attention. If I do this, it prints all the element. If I say 2, right? So that is something I think we did not discuss. Every other element means alternate elements. Alternate element. Okay, let's focus. Ta-da. So it starts from 1 and then it will print 3. So let's say you have more. Let's say you have more. 5, 6, 7, 8. So it will print 1, 3, 5, 7. Like, looking at odd even here. Okay. That's every other element. Okay. But alternate. You can say, no, I don't want to start from, 1. I want to start from, let's say 5, or let's say 4. So it is 0, 1, 2, 3. So you can say that start from 3 means 3 means what? 4, and then do the alternate 4, 6, 8. Can you guys see that? Indexing and slicing is playing a big role here. Okay. So I think this is something I did not discuss earlier, but you can take a look quickly. So now, when I say every other element, so you can understand what I say. Now you can also start from somewhere, right? So what you can do, you can say starting from index position 3. Okay, now guys, clear? So now to get into this, to get into this, what I can think of, there has to be a way, and the way out is here. You need to find the length of the array, because see, we need to do first and last. So the logic is everything but alternate, right? Alternate. Are you getting, guys? Alternate. So for alternate in a dynamic way, see, if I want 1 and 8, I need to skip these guys. Come on, everybody's cool there. Hello. I want 1 and 8. I need to skip these guys. And to skip, this is the one which will help us. So first I'll say length of my array, and I'll say length of array. What is that array? Cool. So what is it? It will print 8. But you know that you don't need to skip 8. So for example, if I write array 1D, now I would say double slice, which is full slice. And if I say length, now just print and see. It will just print 1 because it has skipped 8 elements. But ideally it is not 8. It is always 1 less than that. Remember that? So here you go. First and last. So you need to think on the logic and get it done. And I'm not saying this is the only way. Okay. There can be different ways out there. Okay. Everybody is cool with the solution here. Okay. I just thought it cracked, right? Not necessarily every time we'll be able to do live like this, but it was a good question. I think they can ask this question in interview, right? So take it as a very good question, interview question, I would say. I'll just put it here, need to highlight it. Good. Double full slice gives you everything. Then I said, when you put here 2, right? It means what? It skips every other element. Means if you want to skip one element, you will put 2 there, right? So exactly. So that's what I was trying to write and explain. Yeah. So yeah, it works. So let's say I want to print 1, 2, 3, 4, 5, 6, 7, 8. I'm interested in getting only 1 or 8. So I need to skip these guys. Come on, how many are there? So 1, 2, 3, 4, 5, 6. But if these are 6, you will do what? 7. No? Come on, yes or no? See, if you want to skip 1 element, did you put what? 1 or 2? You put 2. See here. Either you want to skip 7 elements, 6 elements, you'll put 7. So what is the length of the array? 8. So I wanted to make it dynamic. Right? I wanted to make it dynamic. So what is the length of the array? 8. So I did 8 minus 1, 7. Now you change the list of the length of the array, still it will work. So let me clear it. So if I can say, hold on, where is my array? Here. I want to get 9 and 10, right? So now the length of the array is what? You can see that it has changed. You want 1 and 10, so still it will work fine. Can you guys see that? Of this, have you been part of this class since the beginning, Avadesh? No. So first of all, we are not doing pandas here. We are doing Numpy, and to install Numpy in Colab. That's why I don't use Google Colab. We're not collaborating with anybody here, right? So generally we don't use Colab for this reason, because there you need to install all these basic packages, like this. So that's why I ask my student to install Anaconda, and Anaconda will take everything. But I think you can do pip install Numpy. So please try pip install Numpy. We are not doing pandas. And then you can say, import Numpy as, it should work, guys. That's what I recall. In Google Colab, it will work. If it is not working, let me know. There might be a different, maybe, exclamation pip install. Okay. But sometimes it is really tricky there. Okay. So people can use anything they want, but I am not going to judge on you guys on this. Okay. Cool. So should be good, right? Let me take the same array. And I think I will put another heading here, array arithmetic, array arithmetic. Okay, cool. So I'm going to use a function to get you an array, and I'll talk about this function later. But guys, please just start with this one. I know we'll start thinking, what is this arange function? Okay, I'll talk about it later. Again, I'm telling, so don't start getting excited there. Okay, so let's say this is print x. So what this np dot arange, it gives you an array of, so you can talk about this. It gives you an array of 4 elements. You can see starting from 0 till the 3, right? But what is it? What is the syntax? I'm telling you again. I'll come back to this. Okay. Okay. So now let me talk about different uh, different arithmetic operators and equivalent functions. So in Python, in Numpy, we have a concept of U functions, right? Right? Is it okay, Izada? Let me give you one definition of U function. So U functions, let me put heading, U functions. So if I talk about U functions in Numpy array, it is known as universal functions. Okay. So guys, we have U functions. One of the important thing there. So a lot of universal functions are there, and there are universal functions. Please write which work on. Please write which work on a single input and binary universal functions. So function within the function, are you getting or not? Basically, so binary, so we have a single universal function works on a single input, and binary universal function which works on a binary means what? 2, which works on 2 inputs. I'll show you guys, don't worry. Cool. So these are the universal functions, and what you have seen like np.sum, np.subtract, np.multiply, divide, all are your universal functions. Is it okay, guys? So that I have just given a name today. Okay, I've just given a name today. So let me show you. Okay, so I'm going to give you a very good table. So I had given one screenshot earlier. Now I'm going to give you another screenshot, which is this, right? So you have already seen it. So np.add operator is plus, np.subtract operator is minus, np.negative, it's just minus, it's same, but I'll show you how it works. np.multiply asterisk, np.divide, the forward slash, floor division, double forward slash, power is exponentiation. So exponentiation is like double asterisk, modulus is remainder, is your ampersand or percentage, right? Clear, guys? And then we have also given example on the right description. This is going to be a very, very helpful list on the top of the what I have talked about. Is it clear, guys, for everybody? Can you just take a look at, you have already seen in the list, right?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now, what I'm going to do, I'm going to take one by one and show you these things. Okay. So we have a very good operator here. List of operator. Let's explore that. So I have explained inverse function quickly. This is your array. Okay. Now everybody please pay attention. So what I can do first, let's, so I'll keep coding here. Everybody will code with me. So first let's print our, our array, which is 0, 1, 2, 3. I've just given some name X. Now what I'm going to do, I want to add to this guy plus, let's say 5. Okay. So it's more like maths, right? And then I want to do this X plus 5. So it's like arithmetic operator. What do you will think? What do you expect here? The moment I say 5, it will add 5 to each and every element, right? So X plus 5 means what? It is 5, 6, 7, 8. Means what? You have added 5 every place there. But if you take a list, let me show you my list, then you will understand the difference here, my dear friend. If I say my list, and I'll take the same number 0, 1, 2, 3. So it's a list. In case you are wondering, is it a list or not? So you can do that. It's a list. Now guys, tell me one thing. If I do the same thing, if I do my list plus 5, what will happen? First of all, it is data type issue. Okay. So my list, it's saying can only concatenate list to list, not some integer. So first of all, you should understand this is what is this data type, guys? Come on, this is an integer data type, and this is list. Can you concatenate two lists? First of all, I'm not even trying to concatenate. I was trying to add 5 to each and every element in the list, which did not happen. But if you give a list to a list, it will just concatenate the list, means it will just combine the list. It doesn't add. You can try and see. Okay, guys, are you getting or not? You can do 5 as well within the code. Still, it will not work. Why? Because this is just a data type. It's a variable. It's an object. It's not a list. Guys, you need to understand when I say this. What is it? If I do type of 5, it is in string type. If I do type of 5, it is an integer data type. But is it a list data type? No. So you cannot concatenate list with list. I think, okay. So you cannot concatenate list to list. But the beauty of NumPy arrays, right? N-dimensional arrays. If you do x plus 5, it will work. Okay. So just keep that in mind. Okay. Let me go on the top again. I'll copy this and come below so that the discussion is continued. Now, if I do print, now please pay attention, guys. I want to subtract -5. Can I do that? I think so. X minus 5. So eventually what it will do, it will subtract 5 from each and every place. 0 minus 5, minus 5, 1 minus 5, minus 4, like that. Can you guys see that? I can also multiply with into 2, right? I can do that. And I can say multiply with 2. So I'll do more like a vectorized operation. So every element will get multiplied. Just focus, focus. Similarly, I can think of division. Division by what? Some number. Let's do by 2. So what do you guys think? What will happen? See here. Division has happened. Float numbers are coming there. Can you guys see that? You can also do float division. What is float division, guys? Come on. It will take integer, greatest integer, GIF. Now let's, what else? We will just put everything here. We want to do negate, minus X you want to do. So what does it mean? It means that you want to just replace every number with minus X. You will just do minus X. See? So 0, 1, 2, 3 has become 0, minus 1, minus 2, minus 3. It's more like negating it. Okay. Let me keep adding to the list. What else I can show you here? Exponentiation by 2. So like squaring it, I can do it. So it's like squaring each and every element. 0 whole square is 0, 1, 4, 9. Can you guys see that? What else? Remainder. Let's do remainder. So you can do this, focus. Okay. So that's what we have done to these arrays, right? This array list. This is what I created. This is your list, right? This is an array. This function gives you an array. Okay. Let me write here. So I am aware that I am doing with the array, not with the list. Okay. Now, Abdesh is asking, sir, what in the last? So percent means what? Look at this. Percent means what? Modulus. So modulus is remainder. So what happens in remainder? It's a basic maths you have done in school days. Okay, clear, right? Now, guys, similarly, you can also use the, universal function. So now let's focus. So this is what we have done with the help of operators. So what are these, guys? Please pay attention. These are all on the back of what? Arithmetic operators, right? Did you notice? So whatever we have done on this array is what? Arithmetic operators. Now you can also use the universal function to get the same job done. So I'll give you an example. So np.add. So you can take that function, universal function. You can take my array x, and I want to add 2 to each and every element there. Can you see that? So what's happening, guys? Let's add 5 so that we can compare the output, right? So can you compare this output, my dear friend? Is it coming same? Compare this with this, right? Same. But here you are using what? Universal function. Binary universal function takes 2 input. Now, similarly, guys, right? You can do any number of things. I don't want to get into each and every detail, but I want you guys to go through all these functions at your end, right? Please do that. I'm going to put at the part of the notes so the Jupyter notebook has 2 ways to get help. Place the cursor inside the parentheses of the function right? Somewhere here, and you can press Shift Tab. Okay. Then there are a lot of ways to do it. So I follow this page a lot, so you can read in your own time. Okay. I hope it helps. Cool. So let's move on, guys. Now you might be wondering, is it that's all? Like we can't do much about it? We can do much about it. It's not the only thing that we can do here. So we can do n number of things in terms of operations, right? So let me give you a question. I have two lists, one dimensional two list. So I'll go to my, Jamboard. I need to write. So I have two array, guys. So I have array one, and please follow it exactly. AR1. Everybody will follow the same thing. So you need to create one array, which is 4 at 12. You need to create array 2, which is 1 to 7. So these two arrays need to initialize, take it as a question. And we need outputs from you. So output number 1 I need from you is this. So it is focus. So I need 5 here, 10 here, and 19. Okay. Output 2 I want is this, which is -3, -6, -5. Output 3 I want. What is that? 4, 16, 84. Output 4. So let me complete this. It is, you can use calculator in case you are not sure about the calculation, 1.71. And the last output I need from you is a altogether different output. So what is that? It is 464, and then it is 35831,808. Big number it is. So neatly done. So these are the array which is correct: 4, 8, 12, 1 to 7. And so I get 5, 10, 19. Okay, find 4, -3, -6, -5 means subtraction. I'll also comment it, guys. So you have figured it out, right? It is addition. It is what? Subtraction. What is this? Multiplication. What? Yeah. And this is division, right? And the last one, what is it? Last one is what? Exponentiation, right? 464, 358, 3. Very good, guys. It is simple. Last one is exponentiation, means you will exponentiate 4 with 1, 8 with 2, and 12 with the power 17. So to explain it, those who are not getting, so what is the last bit we are doing, guys? Please pay attention. So what we are supposed to do, we have to take 4 and do power of 1. So that's the first element. Second will be what? 8 to the power of what? 2. And 12 to the power 7. That's what we are doing there. So that's what you have done. So 4 to the power 1 is 4, 8 to the power is 64, and 12 to the power 7 is, it's a big number. So that's why. Okay, cool. So guys, we are good here, right? We are good there in terms of this baby maths, right? Cool. So time to time, I'll be talking about other functions as well, right? So you can think of exponentiation, exponential, log, all those things, we can do that. Okay. Now, guys, this is arithmetic. I think sky is the limit. It's not that this is what we can do. We can do anything. But for the time being, I would suggest let's focus on the next topic in the line. And that is what? Basic stats. Okay. So you can also do, sine, cos, a lot of things. So I think I'll also do a bit of math function. So let me just give you that idea, or else it will be. So I thought I'll skip, but let me give you quickly. So you can also do math functions. Okay. That's also part of universal function itself. So if you take the same array, right, you can also find square root. So let me do an APC array, quick array, guys, 1D, and I want to find 4, 16, 64. So this is my array, APC array, come on. I want to find square root of it. Okay, so I can find square root of it. So I can say print square root. Guys, please pay attention. Square root of array is, and I can go and say, I'll use the function np dot. You can write s, and you can see there's a function called np dot square root, and just wrap the array within it, guys. Can you see that? So it is what? What is the square root of 4, 2, 16, 4, and 64, 8. Then you might be interested. No, I see output is coming as float there, right? Okay. So sometimes it feels like, guys, ki no, it's not working and all. So what you can always do, you can get into it and see that do we an option to handle the data type. So you can go there in the np.square root, right? And data type is there. So you can go there and say, cool, I can say d type equal to int. Guys, focus. No loop matching the specified in a custom form. Okay. So it's not allowing here. Okay. Let's see. So you need to just explore it a bit. So I think np.square root, what is the syntax? Arguments, key arguments. Why it's not letting me do that? Square root of what? X. D type is what? None, but I can say D type, right? Some D type. It should work. Any example they have taken? Okay, so I think ideally what I did was right. You don't need to get into this. So this is, I'll give it a try. If it doesn't work, that's fine. So there's some error happening, type error. So no int is not picked up. So data type is not letting it happen. Okay, anyway, need to see. It should happen. It's okay, fine. But guys, what I was trying to say that this way you can find a square root of any function, right? Why it is not giving me integer, I understand, right? Because the square root is going to be a not an integer all the time, right? You can also have a number, some let's say 60, and you can still find this square root is 7.745, right? So that is something, the reason that by default it is getting into float, because not necessary every number square it will be an integer. Are you getting my point? But I believe if the data type is there, it should let us also select a different data type. But we can handle this data type later. We can change the data type, we can make it, we can do typecasting, all those things. Cool. But yeah, that's one thing I showed you quickly, guys. Yeah, we can do that. But I think it is, what is the data type here? I think it should be already int data type, right? Integer 32. So that's not a problem. Input is not the problem, Sanjeet here. But yeah, let's not dwell on this small petty things. Okay. Now I can also show you log. So if you are interested in log of these numbers, you can see. So you can print, guys, please pay attention. Let's keep moving. These are some small things we can take a look later. So what is log A? Log of array APC is. You can also find log. How will you find log? You can say np.log. So you can take log 10, right? Let's do log APC. Cool. So you can find log of the array as well. Now you can also find sine, cos, everything you can do, right? So let me show you some trigonometric functions. So print sine of array APC is. So you're trying to find what is the sine of each and every element there. So you can say np.sine, and since the number is in radian, so it will work, right? So these are the sine outputs. Similarly, you can do cos. So which is your cosine, right, guys? Remember basic trigonometry, you can find. You can also find, right? You can also find inverse sine, which is arc sine, arc cos, right? So you can also find inverse sine, inverse cos. So let me show you. So what is inverse sine? If I have to show you, I'll come to your question, Avdesh. Give me some time. You want to find inverse trigonometric, inverse sine of arrays. What you will do? We will do arc sine. You can also do hyperbolic, by the way. So since inverse sine is not working because it is out of your, one, right? Inverse sine has a limitation. You cannot put anything within that. There is a domain you have to keep in mind. Okay, cool. Does it make sense? But this is the syntax. Why it is not working? Because here the numbers are big. It is outside, -1 and 1. So you need to change the array to get this answer. Okay. So I'll just take this down. Cool. Now, what is the question? Yeah. So log here is by default. Log is what? You can go and see, right? So what is the difference between np.log? Look into syntax. What is this log? So this is natural log, right? It is what? Natural log means with the base, right? With the base e. Can you see that? Now, if you say log 10, so obviously no, it will be base 10. Correct? Return the base 10. Cool. Any other question which I might have missed? Guys, are you still there focusing on this? Now, guys, I'll talk about basic statistics. Okay, come on, come on. Let's go on fast. Basic statistics. Okay, so you can find a lot of things here. So let me take an array. So just to make things go fast. So this is my array, which is 2, 4, 6, 8, 10, right? So you know that you can find some of all the elements in here. So I have, written some syntax already for you guys, some of the lines of code. So please let's go through it. So everybody, please focus. I have written a lot of things there. So in case you are not willing to write, because yeah, I need to save some time here, but you can see these are very simple. You want to find some of these elements in this array, you will do sum. If you want to find what is the maximum number in this array, you will do max. Minimum is min, right? If you want to find, I think I have repeated it maybe twice, so ignore that. You can also find average, you can find variance, you can find standard deviation. Okay, so that's what exactly I have done there. Okay, cool. So right, in terms of overall group, how it is placed there. So these are basic statistics. Okay, so guys, take a couple of minutes there, go through these 5 lines of code or 6 lines of code. But is it clear for everybody? Guys, give me a go ahead on this. You can also find median. I know you might be thinking about, can I get median of this? Yeah, you can do median. Just let me add copy paste. You can find median. Guys, give me a go ahead on this, a quick feedback. So you can find median and you can just do what? Median. Okay, it will give you median. Oh, no attribute as median. I got it. So you can't do this in this way. So median is like you have to use universal function there, okay? And you have to say a there. That way you can find median. Guys, did you notice what I did differently here? It will be np dot median. Okay, guys, cool. You can also find variance and other things like this. So you can also find variance and standard deviation in that way as well. So you can say, guys, just look how I'm doing. Np dot variance of a. See, it is still working fine. You can also do standard deviation in this fashion. Just telling you everything, guys, okay? Not leaving anything behind. So you can do standard deviation and you can do what? You can do STD and you can say STD. It will work. See, standard deviation is what? 2.82, 2.82, variance is 8, variance is 8. Clear?
Let's have a quick quiz question, guys. And the question is, which Python library is commonly used for data visualizations? And your options are matplotlib, seaborn, plotly, or all of the following. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
I think for mode, guys, you need to do what? You need to actually use some stat function, right? You have to import another library. Directly, I don't remember if we have any function like that. I will move on to the next big topic, which is array manipulation. See where list is useful from business perspective. So see, data types like list and all, right? Think more like a problem where you are trying to run a repetitive task using a control flow structure which is looping and try to store the result in an empty list. So think like you want to identify all those data points which are having outliers in your business data, and you want to store that right in a list as a separate output of the code. So that where you will use list, you will initialize an empty list, and every for loop is going to store the result in that list. So let me show you. So that's a very typical example. I think when I started NumPy or Numpy, I started with that you cannot multiply list 1 with list 2, Anupam. And if you have gone through my notebook, you must have seen this example that if you do just list 1 into 2 to get 2, 4, 8, 10, which is multiplication of 1 into 2, 2 into 4, 3 into 8, and 4 into 10. So what we have done, can you see that? What is this? This is a list, my dear friend. Can you see that, Anupam? So here we are starting with an empty list, calling it result, running the for loop, taking one element from one list and the other list, multiplying it and storing in this result, and end of it, we are printing this result to get the output. This is a practical example I have told you, right? You need to store some of your, so this is what I explained, but you need to understand the idea behind it. What I'm trying to say here, you need to get all the outlier, data, right? Wherever your business have outlier, right? So outlier can be anything, right? So let's say wherever you are losing a lot in terms of dollar, in number of business, in number of products, some of the products you are not doing great business, and you are losing like anything. You're losing a lot of money in terms of your sales, right? So the sales are nothing, costs are a lot. So you have a net profit as negative, and you want to store all those products as a part of a list of the product, where I will be highlighting that, okay, these are the worst selling product. How will you find that? You might want to take a look, right? And you might to take a look, and on all the product, get only those ones which are concerning you, right? That's a business, business requirement or business perspective. Now, what you are saying that we can use array as well. Yes, we can use array as well, because array is less memory intensive. But this is not the question we are discussing, right? You're trying to understand where list is useful from business. You can do it with the list, you can do with the array. Now the question comes, you want to go with the array, you want to run, array on top of your data, right? Because you want to, be memory efficient, memory, performance and memory. These are two things you are concerned. You will go with array, but let's not change the question. Okay, guys. So let me move on to the new topic, which is array manipulation. But before I do that, I want to also give you, as I promised, that I'm going to give you two, I'll give you two Numpy functions, which is linspace, right? And np.array. Don't write arrange. I used to write arrange, it's arrange. Okay. So what is the difference between these two? Any idea? NP arrange, I have already shown you. What is NP linspace? What is the basic difference between these two? And these are the ones, pro tip, guys. Typical interview question. Someone can ask you this question. We use list, we use arrays as and when required. It's not only the, memory is going to be the key driver for deciding it. We use both of it. Okay, depends on what we are dealing with. Let's say we don't have a lot of data. Why are we talking on memory then, right? So not memory is going to be the only deciding factor in all the scenarios. So list is getting used, array is also getting used. Okay, depends where and where. So linspace gives equally spaced element. Okay, arrange is just used as a range in Numpy, and we use range in Python object. Okay, linspace gives linear space between element. Okay, linspace gives the series with equal differences between two integers as per given command, but in range it is a simple series with one. Okay, so let me give you an idea about. So first let me write why do we need these two guys. So why do we need? So when it comes to, please write, when it comes to creating a sequence of values, linspace and arrange are two commonly used, Numpy functions. Okay, guys, to be very correct here, we don't write Numpy like this. The right way of writing Numpy is this. So these are the two functions people use to create sequence of numbers. Are you clear, guys? First thing first, you should know that. Okay, that's the first bullet point from my side. So whenever you're trying to create sequence of numbers, you might be able to use, or you might want to use, linspace and arrange. But what is the difference between these two guys? So let me tell you that the subtle difference between the two function is linspace allows you to specify the number of steps. You can tell how many steps, I want. So I can freeze on the number of steps. Arrange, on contrary, specify the size of the step. So you will not understand. It's okay. So first, let me give you these two bullet points. So I've already written for you guys to save time. So linspace allows you to specify the number of steps. Arrange allows you to specify the size of the steps. Okay, and let me give you the syntax as well. So first I'll start with linspace. Okay, np dot linspace, linear space. Okay, So now guys, what is the syntax? Start, stop, and number. What is the number? Number of values to generate. So let me take a quick example, then we will understand. So if I take np.linspace, okay, and what is that? I want to start at 0, so my sequence will start from 0. It should end at 20, and I want 11 evenly spaced values. Let's focus on this, guys. Come on, please pay attention. Evenly spaced means what? Can you see? First it is starting at 0, then the next one it has taken 2. So what is the delta between these two guys? 2, again 2, 2, 2, 2, 2, 2. So you are able to do the step is like, clearly the step is 2, but how, what you are controlling? Are you controlling the step, or are you controlling the number of values you are generating? Number of steps or number of steps or step size? We are calculating number of steps. I'll show you. Now I want to get 12 numbers. If you focus here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me do baby thing. Otherwise you will not be able to get. Let me show you this, guys. I think let's take a small number. So guys, can you see that? Yeah. Focus. Everybody, please focus on a small number, a small array. So between 0 and 10, so start is 0, end is 10, and I want 5 number of data there. 5 number means how many length? What is the length of this array? Come on, tell me. Then you will understand what I'm doing there. What is the length of this array? It is going to be 5. Let me show you, 5. So what is this? This is 5. Now I want 6. I can get 6. Can you see that? Now we see 6 element there. Guys, follow. So that's the number of steps. Think in raw form, number of element. And again, it is equally spaced. Focus, it is equally spaced. 0, 2, 4, 6, 8, 10. Now you want to say 10. So look at that. It will by default decide that what should I place there, that it give me 10 numbers, but equally spaced. This is also equally spaced, by the way. You do the math, it is going to be equally spaced. Beautiful, right? Isn't it? So what is the observation, guys? It depends on what is the size you're giving. Sorry, what is the number of element you're giving? And by that, it will create that equal space up to it. But you have to just tell what is the start, what is the stop, how many number of values you want to generate. Okay. So let me also write exactly that. Number of values to be generated, or number of values. So you can also go into it in the documentation. Returns evenly spaced samples, right? Evenly spaced numbers. Every time it will be equal spaced. So that's how we use this. Now let me write one more thing here, which we have observed. So please let me put it as a bold thing. So using this method linspace automatically determines how far apart to space the values. It will decide. You cannot say that I want to give 2, 2, 2, 2. No, you can't decide that I want 2, 2 step. No, you can't decide the step size. For that, you have to use what? Arrange. Okay. Is it okay, guys? Come on. I think I explained it nicely. You should be able to get it in one go. So you want to control the size of the step, that I want 2, 2 space. Then you have to use this guy. Okay. So you can use arrange. So what is the syntax of arrange, guys? It's also same. The only thing you have to focus here, that start, stop, and step size. Now I can take the same example, same series. I'll start at 0 at 10, and I want to say do arrange, and I say give me step of 2. So step of 2. Now it will decide where to stop. You cannot say you have to stop at 10. It will give you value between these two values, right? Focus, focus. Read about the documentation. Return evenly spaced value within a given interval. You cannot say I want to include the 10 as well. Can't get everything, right? You can't get heads and tails both, right? So returns evenly spaced given interval, right? So let me take this and put it in the screenshot. Okay. Now you will say, no, I want to give step 1. So see, it will give you everything, but it doesn't. If you say step 0, see, you can't do that because it divides in the back, under the hood. So you can say 3 steps, it will stop at 9. You say 5 steps, I'll take 5 steps. I think it will just print 2 numbers, I guess, 0, 5. Now someone say, how will I use it? Very helpful. So now let's take a quick question. Print all the even numbers between 0 and 101. See, this is a question. all the even numbers between 0 and 1. How will you do that? And hint is, obviously you're supposed to use this, huh? Otherwise why I'm teaching it. Use NP arrange. That's the hint. NP.arrange, you want to start, you want to 100 and you want to do 2. See, bingo. You don't want to include 0. Let's do this. Oh, sorry, I have to start from 2. My bad. Okay. Is it clear? You can do that, brother. You can say 0 to 100. You will understand why you can't do that. When you do 0 to 100, right? 100 is as part of the index, right? Is excluded. You want to include 100, you have to give one more there. Is it clear, Sanjeet? So you remember, sometime it will use different thing differently. That's how the Python is defined. So that you can only learn from your observation. 100, if you write this limit is excluded. It's between the interval. It doesn't take this boundary point. Okay. So this is about np.linspace and np.arrange. And the last topic, second last topic, array manipulation. In array manipulation, let's first understand two big guys. One is resize and reshape. Another interview question, guys. Resize and reshape. Pro tip, interview question. So what is the difference between resize and reshape? Come on, guys. So first, let's understand resize, reshape. Okay. So first, you need to understand what does reshape do. Okay. What does resize do? So let me first start with resize. Okay. So what it does, it returns a new array. Please, guys, pay attention. A new array with the specified shape. So first, let me talk about these two guys. Okay. You might have to happen, right? It can happen that if the new array is larger than the original array, it can be possible. Suppose you given the new array requirement is which is larger than the original array. So what it does, then the new array is gonna filled with what? Repeated copies of the original array. So this is my 2 bullet points. So let me take an array, guys. Okay. So I want to take array equal to, I want to take 2-dimensional array, np.array. Guys, please pay attention. List within the list 1, 2, list within the list 3, 4. What is this array, guys? Print a, what is the shape of this array? 2-dimensional array, 2 by 2, 1, 2, 3, 4. You're not interested looking at here, so that's also fine with me. I can do this. Sometimes I don't like, everything printed side by side, but it's good, right, guys? Everybody's cool. Now, what I want, so this array, so let's visualize this array a bit. So take it as a, so I have also put an image there. So this is your array 1, 2, 3, 4. Can you see that? 1, 2, 3, 4. This is your 2 by 2 array. I want to resize to this, and you can already see I've also put a syntax there, right? So what you can do, you can say np.resize, and what is the syntax? You have to understand the syntax. You will say what is the original one, right? So what is the original array and what is the shape of it, right? So what you can do, you can say my original array is what? A, and what is the shape you want to get into it? You want to get what shape? What is this shape, guys? Come on. It is 3 by 2. Can you guys see that? It is 3 by 2, 3 rows, 2 columns. Am I able to print that, guys? So did you notice that it starts with 1, 2, 3, 4, then it stopped at 1, 2. Let's say I'm interested in more. Let's say I want to go 5. What will happen? See now. So it has done what? 1, 2, 3, 4, 1, 2, 3, 4, sequence it's filling, and wherever it stopped. You want to go into other sides, so you can do what? So let me first answer this, and I'll experiment later on with the later images. Now I want you guys to do this. From the same array, you give it to me this. So what is the output I'm interested in? This one. Can you see that? So this is your original 1, 2, 3, 4. I want 1, 2, 3, 4, 1, 2. Can you see that? That's how it's going. Can you follow this path, guys? Hello? Can you follow this path? 1, 2, 3, 4, 1, 2, guys? So I want this. How will you do it? This is your question. Come on. So how will you do it, guys? It's very easy. You say np.resize. You will take the original one. It's all about how do you put the shape. So what is the shape you will do it? You need what? How many rows there? 2. How many columns? 3. Is it good, guys? Come on. You might be interested in something like this. Come on, guys. Last question. You are interested in this. How will you handle it? Come on. Now I want 1, 2, 3, 4, 1, 2, 3, 4. Can you see that? How will you do it, guys? Think. 1, 2, 3, 4. It should be in one line. Then comes the other line. How will you do it? NP dot resize. They're all small things. Now you want how many rows there? 2 rows, 4 columns. See, easy P. Right? Is it clear, guys? So this is about resize. Okay. Like that, you can have reshape as well. Okay. So let me quickly get into the new topic, reshape. You can explore it in your own time, guys. Let me move on. Sorry. So what is reshape function does is used to give a new shape to an array without changing its data. That's the important thing, guys. That's the only thing you have to focus. So resize is something you can do anything. Every size is possible. Reshape is something which you are telling here, right? So that is another bullet point you should write. So please write important thing. The new shape should be compatible hona chahiye, should be compatible with the original shape. I'll talk about in detail what do I mean by that. So let's discuss it rather than theoretically understand it. So guys, to explain it beautifully, so let me take a simple array. I'll take b equal to np dot array, and I want to take 2 dimensions. So I'll take 8, 9, 10, and then 12, 13, 14. Please guys, everybody follow the same array with me. If you don't want to get confused there. So can you guys see that this is my array 8, 9, 10, 12, 13, 14. And if I talk about what is the shape of this guy, b dot shape, what is it? 2, 3. Everybody is comfortable there, guys? Come on. Tempted to do this. So what he's doing, can we get so we have array what? 2, 2. Can I get a smaller array? So let's say I want 1, 3. 1, 2. Yes, it's possible. See, it is possible, mister. Okay, now let me go back there. So now I want to resize this, right? I want to, sorry, reshape it. My bad. So guys, I want to reshape something like this, more like a sequential array, one dimensional array. So I'm throwing the image in the chat, in the note. So I want this 8, 12, 9, 13, 10, 14 means what? I want 2D to 1D. I'll talk about it later. Okay, this is a little tricky part. What about if I say, I need to increase the size a bit, guys. Okay, so I think this is okay. 8, 9, 4, 12, 13, 14. I want to change because I have a different image from the user. So 2, 3, 4. I'm changing the array, guys. Please change it with me. Sorry, I'll come to this later. This guy 5, 6, 7, because my images are not on this line, because I have not created this image. So I need to go with the creator. So guys, what I need this array. So please pay attention. This is the array I need. 2, 3, 4, 5, 6, 7. So if you focus, the shape of this array is 2, 3. What is the shape of this array, guys? Please pay attention. It is 3, 2. So what should be the syntax, guys? np dot reshape. Take the old array and then shape it like what? What do you guys think? 3, 2. Do you think it will work? Yeah, it should work. And it is a compatible array because see, total elements is what? 6. So 2 ja 3 is 6. And what is the shape of this guy? 3 ja 2 is 6. So it will work. But the moment you see 3, 3, what will happen? It will say cannot reshape array of size 6 into shape 9, right? It cannot do that. What do you guys think? If I'm interested in this one, can you give it to me, guys? It's the same one. Now this is also compatible, 6 elements. So we can do something about it. Let's see. np dot reshape. Old array is B, and I want what? I want 1 row, 6 columns. See, guys, it's working. 2, 3, 4, 5, 6, 7. Now I'm going to ask a very tricky one. Guys, please pay attention. And you have to actually give it a thought here. Can I get this one? I want 2, 3, 4, 5, 6, 7. So see, it was 2, 3, 4, 5, 6, 7. Now it is what? 2, 3, 4. Sorry, what is the original one? Original is 2, 3, 4, 5, 6, 7. So let me show you again, else we will not be able to compare. 2, 3, 4, 5, 6, 7. I want 2, 3 in first row, then 4, 5 in second row, and 6, 7 in third row. What do you guys think? How will you do it? Let's see. NP dot reshape. I think we have already done that, right? Yeah, this is here now. Sorry, my bad. My bad. Okay, I think then we are good here. It's okay. So that's all about reshape. You explore more, you go into 3D and as and explore much more, right, guys? I think for now we are good there. So this is all about array manipulation. Okay, guys. So I'm going to talk about some of the very famous manipulation functions, right? So concatenate means, adding, right? Bringing two string together, or, two arrays together and return the result. So that's what we mean by concatenation, right? So here, if you see the example, guys, so you have two arrays here. Let me highlight it quickly, guys, focus. So you have two arrays there, and let me increase the size of it. So numpy concatenate means what, right? So these are the top, top function there. So let's take one by one. Concatenate means what? Concatenate two arrays together and return the result. I'll show you when I'll do the hands-on. Then we have this, vertical stack and horizontal stack. So if you think about stack, I can go in my Jamboard and let me clear this frame for you guys so that you can understand when I say stack means what. So what is the meaning of stack? So stack means, in simple English for arrays, it is joining arrays, and then you give with the given access. Okay. So I'll explain. So let's say if I have array 1, 2, 3. So this is my one array. Please pay attention, guys. Then we have another array, let's say 12, 14, and 16. So let's say this is A and this is B. Please pay attention. I want to stack these two arrays. How can I do that? Now, if you focus, you can stack in different ways. So first, if you stack by first dimension, so please focus. If you do by axis 0, which is your first dimension or row, how will you stack? It is simple. It is 1, 2, 3, 12, 14, 16. Guys, come on. Right? This is about axis 0. Axis 0 is around about the row, right? You can also think about axis 1. Axis 1 is what? Column. So how will it look like? It will be 1, 2, 3. You know that. And this will be what? 12, 14, 16. You guys are able to follow? That is by second dimension. And for that, you can use function like np.stack, right? You will take the arrays, so A comma B, and then you will go outside and say axis 0. That's the syntax. np.stack. I'm not talking about horizontal or vertical stack. It is just simple stack function. And you will do axis 1. I'll show you when I'll go there. Okay. So far, so good. Are you able to see that and visualize it? So this is your stack function. What is it? I have just explained stack. Concatenation I've already explained. I'll show you. Now I'll go on the other one, right? Now everybody please pay attention. I'll go to the horizontal stack. So let me write. It is known as H stack. H stack, which means what? It stands for what? Horizontal stack. Or let's call stacks horizontally. H stands for horizontal. So again, I'll take, two arrays. So I'll take 1, 2, 3, 4, 5, 6. Now focus, I have taken a two-dimensional array here. Can you guys see that? That's my array 1. I can say this is, this is B. And how does B look like? It is 10, let's say 12, 14, 16, 18, 20. Guys, please pay attention. Now, if I want to do a horizontal stack, please pay attention. What stack? It's stack. Horizontal stack. What do you guys think? Horizontal means line like this, line after line. It's horizontal. So it's always something you have to visualize it, right? I'll show you with the example of books. Okay. So let's say you have a book. So you have a book here. I'll try to be just as dudes. I don't know if it looks like a book. Let me see if I can find a better image to show you that. Guys, give me one. I think I put some image in my notes. Yeah, I got it. I don't know if you like it or not, but it is a very good image. So when you do this graphic design, right? So you also use stacking as a container there, right? So in the data, how does that container look like? I'll show you. Yes, this is a good example coming with the NumPy. So let me clear this frame for you guys. Can you see this image, guys? Come on. So I think this image I have taken from the web itself. Can you guys see that? I think this is something is going to be very helpful here. Everybody, please pay attention. Can you guys see this image? Focus. Everybody has to focus. I need your full focus there. Now, guys, you can see we have three arrays to be very sure here. Array 1, array 2, array 3. Now, if I stack something, take it like this, like a box, one below the other, right? So what is this direction? This is vertical or horizontal? This is vertical. So if you stack something on the top of something, right, that's exactly in the output you can see, right? np.v stack. So that's a vertical stack. Guys, are you there with me? So far, so good. Look at the right side. I'll change the color. Look at this guy. So what is this direction, guys? What is this direction? This is what you call it as what? Horizontal direction, right? So if you just just do this, you can also do with the clap. So if you do clap like this, so you do a normal clap, right? Everybody does a normal clap. That's a horizontal clap. You can also have a vertical clap. People clap like this, right? So what I'm trying to say, horizontal or vertical clap. I don't know if you're able to follow or not, but I'll show you. So there's a concept of horizontal clap and vertical clap, right? So people clap in different way, right? So the emoji, right? The emojis which we are always sharing with each other, that's a vertical clap, isn't it, guys? Come on. Almost. I know there is an angle. I can say you are saying we are going to say it's an angle and all, but ideally it's what clap? Let me show you here. So there's a very good image I found from the web. Come on, man. Yeah. So what is this clap? This is a vertical clap. You put your hands in the air and you clap. That's a vertical clap. But a lot of time people also do horizontal clap. Generally kids do that. Very good. So you want to see an horizontal clap image? I'll show you quickly. These are all images coming from the web. I'll delete it later, but just for the sake of understanding, you do that. Why I'm creating this concept here? Can you see that? This is what clap? This is what vertical clap. So in case of our, this is, people do in hover, right? So you do horizontal in air is like what vertical. So it's opposite concept. So if you combine these two arrays like this, hold on. If you combine these two arrays like this is like combining across horizontal. Can you guys see that? Although your hands are in the air, but the clapping is happening like which direction? It's a horizontal direction, right? So by raise of hand is vertical, but clapping is horizontal. The raise of hand is horizontal, but the clapping is happening what? Vertical. Are you getting, guys? So like that, you have to visualize it. So when you are stacking one box after the other, you can also think of two carton boxes. Let me explain my thoughts more. So let's say this is my one box, box one, Amazon box, right? And now I have another box, which is your Flipkart box, box two. Now you just bring these two boxes together, just like this. So what is this? This is your horizontal stack. But if you go there and you say, no, I'll take this box and put it on the top of Amazon box. So what is this stacking? Guys, come on, you know that now, vertical stack. So let me take this image so that I'll take this and put it here. So this is about stacking. So let me go in my notes. You can do that right, left, you can do that. I'll show you all with the help of code. So shall we do concatenate stacking together? So, let me start with this guy. So let me create these two. What is that? 1, 2, 3, and 12, 14, 16. So I'll create my first array, one dimensional array, guys, focus 1, 2, 3. And the second array will be what? np.array 12, 14, 16. Guys, come on. And you can also print these two arrays. Okay. So first you need to understand about concatenation, right? Concatenation. Please, concatenation. Please be clear about the spelling. Okay. So now I'll show you concatenation quickly. So what is that concept? So how can you concatenate? You can say numpy. So numpy is np dot concatenate. This is your syntax. You can take two arrays and you can start doing this. So you can say A comma B. And only integer scalar array can be converted to a scalar index. Did I do something wrong there in terms of syntax? Yeah, I think so. Okay. So you need to put in the parentheses, guys. Okay. So did you notice that it has by default concatenated, in sequence 1, 2, 3, 12, 14, 16, just like list concatenation. You have seen it, right? Now you can get into the syntax, right? Documentation. What is it? You can say access 0, 1. So by default, it is what? Guys, by default, it is what? See, I'll do access 0. By default, it is access 0, right? Which you can also check for yourself. By default, access 0. Okay, guys? Now you want to do differently. So just copy paste and change the access now. So this is by access 1. Now, if I do that, I'm getting an error, guys. Can somebody explain what is the error? Axis 1 is out of bound for array of dimension 1, right? Doesn't make sense, right? Yes, doesn't make sense. You need to get into 2D arrays, but you can do that. You have this functionality. Okay. So when I'll do the 2D array, you will see that it is going to happen. Okay. But I think, guys, did I miss something on the syntax? No, right? There's no issue in terms of syntax. Ideally, it should have worked, right? Guys, did I miss something on the syntax? Why it's not working? 1, 2, 3, 12, 14, 16. It's in the same dimension. What is it? Let me check the dimension, guys. Hold on. So A dot ndim, it is 1. B dot ndim, it is 1. Okay. Ideally, it should work, right? I can read that. Am I missing something? A very simple thing, guys. Okay, let's say it is, APC. Let me store it. It is still not running. Let me try again. NP dot concatenate. I'm also trying to do that. It should work. Why it's not working? A comma B. So that is my 2 arrays. I know 2 dimension it should work. Earlier it was working in older version. No, it's not working, guys. Wow, this is so sad. For 2 dimension it will work. So let me take 2 dimension arrays then. Yeah, let's do it, guys. So let's make it 2 dimension. So I'll do 4 comma 5 comma 6, guys. Please pay attention. This is coming 2D now. Comma hold on, guys. 18, 20, everybody, right? It is 2D working fine. So by default access 0. So 1, 2, 3, 4, 5, 6, 12, 14, 16, row over row, right? Makes sense. Yeah. So I can see, guys, there is generally it is, sometimes gets that, gives that issue. Okay. Okay, cool. So that's fine, guys. For 2D, it is working. I'm okay with it. Let's not break our heads on simple things. That's fine. We can use stack as well. And that is exactly I'm going to do. So guys, now please pay attention. So I'll take the same 2 arrays and I'll just look at on the other function. I'll come to your question. Give me some time. I'll come to your question. So guys, I'll do what? I'll do stacking. So I'll use the syntax, normal stacking syntax. So I'll say, let's say np.stack. So no concatenation. I'll use np.stack. I'll take array a comma b and I'll do access equal to 0. See what is the output? It is similar to what I've got here. 1, 2, 3, 4, 5, 6, 12, 14, 16, 18, 20, 22. I'm there, guys. Come on, take a look. You want me to give you these 2 arrays? You can take it, but I think it's okay. It's in the chat. You can read, you can create. Okay. So if you focus on this, guys, let's call this APC and let's print it. And if you do APC dim, what is it? It is 3-dimensional array. Did you notice something has happened there? That's a difference there, guys. Here it is still a 2-dimension. If you do concatenate like this, it is 2-dimension. Here it has become 3-dimension, guys. Guys, this is your np.concatenate. So it still is 2-dimension. When I do np.stack, guys, I'm asking a question. What is the dimension there? It is 3-dimension. So you need to understand stacking is always different from concatenation. That's exactly, you should know that. Okay. It looks like it is stacking, but you need to understand stacking between the rows means what? So if you can focus on that image, which I've started teaching with you guys, you need to understand. Let me show you that image. Stacking means what? About axis 0 means what? One behind the other, right? So exactly like that it has happened. So if I can go back, and show you another by axis 1, and you will make out the difference. What will happen? So now what is it done? It has taken 1 to 3, 1 to 3. So what is my original one? 1 to 3. So that's my row. 4, 5, 6, another row. Now let me show you these two arrays. This is a little tricky, guys. You need to be patient there. So now, guys, 1, 2, 3, 4, 5, 6. What is that done? It has taken axis 1. So axis 1 is your column, right? So if you try to understand what it has done by axis 1 means what? It has taken, now it is still what? If you focus here, guys, it is still 2D, but 1, 2, 3, it has taken, then 4, 5, 6, so one behind the other of the, 1, 2, 3, 4, 5, 6, and then 12, 14, 16, and then 18, 20, 22. So if you want to visualize it, guys, you need to understand one thing. I'm just trying to show you how does it look like. Give me a moment there. That's why I was looking for that image so that I can show you there. Let me go back to my Jamboard. I think I had put this image right. 1, 2, 3. Can you see that? When there is only one dimension, please pay attention, guys. When there's one dimension, when you're doing axis 1, so it takes a transpose. Can you see that? It's becoming 1, 2, 3, and then comes the next one about the column. Can you see that? About the columns. Observe this. Everybody, please observe this. When I do axis 0, how does it look like? 1, 2, 3, say cross the rows, and then comes the 12, 14, 16. Let's go back here. Let's see that whether it works or not. So 1, 2, 3, 12, 14, 16. So when I do about axis 0, 1, 2, 3, and then it takes the second row, 4, 5, 6, and stack it. Guys, come on. So it takes the first index from the row of the first array and stacks with the second one. Guys, please pay attention. So if I can also annotate there, because it's a little tricky. This is your original array. Guys, please pay attention. So it is taking the first one, 1, 2, 3, and taking the second one from the second one, right? 4, 5, 6, and stacking in 1. Can you guys see that? Hello? Everybody. This is what your about axis 0, guys. Give me a go ahead if you have understood it. You need to be very careful there, guys. Now what it's doing, it is taking what? 4, 5, 6, sorry, 12, 14, 16 from the first one, which is the second row, 18, 20, 22, and then stacking like this. Clear? Should be. That's about axis 0, means about rows. Can you see that? Rows. Okay. And I think there was certain question on why it is not concatenating about axis 1, because there's only one axis, right? It's one dimension. There's no axis 1. I think I completely missed it there. In axis 1, we need 2D, right? So that's why it was not working. Why it was not concatenating on axis 1. It will work for 2D. So eventually I also mentioned that, but I was just trying to see that will it do something. I was just exploring that angle. Now, guys, let's talk about this one. Guys, please pay attention. Now I am stacking about what? So 1, 2, 3, 4, 5, 6. No, guys, I think stacking is not happening like the way we should do it. Guys, I need to, let me do it. So let me take a step back, else it will be confusing for everyone. So guys, stacking, let's create the simple 1D because it will be too tricky for everybody here. And let me create a simple array here, a equal to, and I'll do np dot arrange. Guys, I'm taking a step back. I want to do 1D first, okay? I want, simple array A. Guys, please pay attention. Second array as B, start from, let's say 10 and between 15. Start from 10 and I need this. Stop at 20 and I want this. Okay, guys, and I want 18. Perfect, guys, please pay attention, everybody. Guys, I need to take a step back to, get it simplified. It's getting confused. At least I'm getting confused. So what is ndim? It's one dimension. So we know that. So let's hold on. Now, guys, what I was trying to do? I was trying to do np.stack about what? Axis 0. So ideally, what I have taught there, you can visualize here. It's just row below the row. Guys, can you see that? 0, 1, 2, 3 coming below, above the 10, 12, 14, 16, like stacking, like, about the rows. I was trying to directly explain 2D and that was not working. Okay, let's do same thing, but I'll do about column. So means axis 1. Now here again, axis 1 doesn't make a lot of sense, right? So let's say, let's try it out. Okay, because it will work, I know, because that's what I've taught on the Jamboard. So that's a difference here. Axis 1 is still, if you say axis 1 is not there, but what it does, it takes a transpose and make it axis 1. You must have been taught, row vector and column vector, right? So more like that. So even if you have a row vector, you can take a transpose, and that's exactly it's doing, guys. Can you visualize on your own? So what it has done, it has taken 0, 1, 2, 3 and moved into a column and then stacked it. Is it okay, guys? Come on. So stacking happens about the columns. That's a bit different from the concatenate. Every function has different behaviors. You need to be very clear about it. And that you can explore with time. Don't worry much on that. Okay. Now what I'll do, I'm going to use these two, and now I'll go into 2-dimension. Okay. So you will be able to understand. So let's go into 2-dimension. So one is this, right? One array is this. Now I'll just pick it up, this one. Now since I have replaced A and B, so it will work fine. Now axis 0 means what, guys? Please pay attention. 1, 2, 3, 4, 5, 6, above the 12, 14, 16, 18, 20, 22. Simple, no rocket science there, guys. Come on. That's the way of stacking has happened. But one thing you might tend to miss here, that it always adds one dimension, guys, there. That's the observation I want you guys to have it. I started with one dimension. Can you guys see that? Earlier it is what? It was one dimension, guys. Come on, everybody, please pay attention. Guys, look at the square braces. Guys, what is this? 1D. This is what? 1D. This is what? 1D. Right? Output of this, output is these two is what, guys? Come on. What is this? When I'm stacking it, what is this? Can you see that? 2 square braces. So to add that, guys, come on, please pay attention. I need you to do that. Right? What is this now? The moment you do the stacking, it is becoming what? 2-dimension, guys. Come on. Right? So 1-dimension increment has happened, guys. Can you believe it, guys? Or not, right? So likewise, when I started with 2D, so this is your 2D array, guys. So what is this now? Can you see there are 3 square braces, guys? Come on. Means what? When you are doing a row stack about the rows, you're getting 1 dimension more. Now let's talk about next topic, which we have already done. Now let's try to visualize this one, guys. Okay, visualize this one. So what I'll do, I'll create the same 3 by 3 array. Okay, so let me create AP. So array maybe 3 equal to, you can also start doing it, looking at the image. The first list is what? 1, 2, 3, 4. It's a sequential one. So I think I can create, like, why I'm doing this, I can create using some function, right? So what is that I can use there? Come on, tell me. I can use np dot arrange. What is the syntax? I can also reshape, right? So I can say, give it everything between what? 1 to 3, 12, 1 to 13. So let's see how does it look like. 1 till 12, right? And now I have to reshape it, guys. Come on. So I'll say dot reshape use array. Sorry, I can also do this, right? I want what? 3 by 4. Okay, guys, I've got it faster than you. I don't know yours is working or not, but mine is working fine. Okay, can you guys do this? So this is my array, guys. Okay, now I'll make array 4 as a baby array, np dot array, or let's name it exactly the way it has been named, right? It is what? A. It is what? A, guys, so that now you can relate to this image all the time. I think that will be a good idea, guys. No, what is the B? B is what? np dot array. And what is B? B is 1, 2, 3, 4. So let's hard code this. And we can also have C. And what is it? 1, 3, 5. I'm taking some time, but that will be helpful. So working fine. And let me print B and C. What is Abdul with the spelling of arrange? I think that is correct now. The spelling of arrange is correct. That's why it's working. Yeah. Okay, good. Now, guys, I want to do this. First, I want to do what? Horizontal stack. Let's do that. So how will I do it? How will I do it? np dot horizontal stack, guys. Come on. And then I can do what? Write A comma B. Okay, dimension issue is there now. So no, A comma C, not B. Guys, horizontal stack means what? Number of rows should be same, else it will not work. Number of rows should be same. So I put B and that's why it failed. Now what is all the input must have? It should work. Guys, what's going wrong there? Okay, so I want all the columns. or I have to do column stack. Okay, there are two ways to do that. Okay, so it's saying that you can't directly write this. What you have to write? You have to write all the column and maybe do this. No, I think it should work. I don't know. NP dot horizontal stack a dot. All the input array must have same number of dimension, but the array at index 0 has 2 dimension and the array index has 1. Okay, so that's correct. This is what 2-dimension array. This is 1-dimension array, but should work. Okay, guys, let me go into the syntax. I'm missing it, I guess. Did I rename it wrong? Okay, B is P, C is C. Stacking is like stacking against me. Sometime we get into this, right? It should have worked. I don't know why it's not working, because I've taken 1 dimension and that's creating a lot of issues. So ideally, okay, let's try this. So it is dimension wise. That's how I think 1 dimension has to be handled separately, guys. That's what I understand now. Okay, so np dot h stack. Let me give it another shot. Syntax is correct. The only thing is that, see, you need to understand C is what? 3 rows, right? 3 rows element, right? 3 comma 1. And that's where the suggestion is that if I do C, then I have to do colon and then we have to write none. Yeah, bingo. So that is an issue when you are looking at 1 dimension, right? Guys, can you see that? So that is something we need to be careful. That's why I was struggling with. So whenever it is 2 dimension, it's not a problem. Its life is very easy. So guys need to understand what is the meaning of it. First, you understand what is the meaning of this, right? Let me just show you differently. So what I've done, if you just print C, look at this. What is it? 135. 135. It's all dimension wise differently, right? So what is that done? It has converted into more like a 2D array, guys. Can you see that? It's a 2D array. So we need to get into 2D. But we started with 1D, so we were supposed to get into 2D so that we can do the stacking, proper stacking. And that's where the error was coming, right? Let me reprint that error so that you can see. I realized that that is the error. So if I do A comma C, what is the error? Read the error. All the input arrays must have same number of dimension. Did we have same number of dimension in this example? I'm taking difficult example in the beginning, and I did definitely missed it in the beginning. Same number of dimension. Then I realized, no, it's not same dimension. So what we did here, guys, by this step, what you have done, you have converted. I should write here 1D to 2D. In simple English, if I say, everybody is comfortable. That's why I printed for you guys. Okay, cool, guys. And also keep this error with you so that you don't forget it. But if it had been a differently, so let me take another one. Let me take a 2D array. We have a 2D array, guys. Okay, so let me take a 2D array and I want 2, 3, focus, 5. Please pay attention. 8, 10, and 99. I got this. Okay. Can you see that it's a 2D array, guys? Please pay attention. It's a 2D array. Let me show you with the dim in case somebody struggles with the braces here, right? It's a 2D array, guys. Now, if I take this 2D array and I do a horizontal stack, please pay attention. A comma 2D array. What do you guys think? A comma array underscore is 2D. So what is our dimension there, guys? Please help me out there. What is the shape of this guy? What is the shape of this guy? There is some error. Let's resolve it. So array 2D, it is, no, this is not what I printed, right? Where it is here. Let me take it. We need to be careful with the array dimension. Otherwise, it will throw the same error. Hold on, guys. So I need how many rows? I need 1 more. So, okay. So let me put a comma. Guys, can you see that there was 1 row missing? There was 1 row missing. And that's why this error was happening. Now, guys, see, it is working fine. Clear? Don't worry. Don't get overwhelmed by the errors. It's okay. It's fine. Errors will come unless until you crack it. Look at me, how I'm cracking it. I'm going through the error, resolving it. Okay. So why did it work? Because what is the dimension here? Guys, please pay attention. What is the dimension of A? 2D. What is the dimension of array 2D? Anyway, it's 2D, so it's 2D, right? That's why it worked fine. There's no issue. But when you are taking one dimension, in this case, you need to convert into 2D. Can you see that? This is 2D now. You can store it and you can see it for yourself. So look at the image. Stacking will only happen across the rows, right? Rows has to be the same. You can stack multiple columns, that's fine, but the rows has to be the same, right? Similarly, for vertical stacking, what should be the same? Column should be the same. It is a little tricky, guys. Give it some time. Go through it. I'll go slowly. There's no hurry from my side. Take your time. I'm taking my time. So I have two arrays. Just focus. I'll show you 2D first. So you have one array 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 11, 12, right? So if you focus here, so this is one of the array. It is what array? 2D array. Rule number one, to stack, rule number one, you need another 2D array. That is something you have to keep in mind. Can you see that I've created another 2D array? How do I know it is 2D array? You will see two square braces at the end. Focus like this. Is it clear? Now, what do you mean by horizontal stacking? Horizontal stacking means what? You will stack horizontally. So let's say this is your array A, and you will stack this with what? Array 2D. Clear? Like this. This is the visualization part. Okay. Now let's go in the code. So what I've done, this is two-dimensional, this is two-dimensional, and then I've stacked it. Isn't it? If I focus, if I take your focus here, please pay attention. This is my what array? Please pay attention. The circle array. What is this array, my dear friend? The right side of it. What is it? Array 2D. Is it clear? So how you are stacking it, my dear friend? You are stacking it horizontally. Can you see that? You are just putting a box, Amazon box, touching the Flipkart box, not on the top of each other. So this is known as what? It's stack. So that is about two dimension. But what is the issue we are trying to resolve? I'll show you. So I know I cannot escape from this, right? So I started with this example, which I have taken as the image. So what is the issue happened there? That this is one dimension. What is C? Focus on C. Let me show you. What is the dimension of C? Let's see the dimension for C. It is 1D. So that's why this was not working for us, right? The error was very clear. So this is one dimension. So what we actually did, we said, okay, since it is one dimension, what I'll do, I'll go it and I'll convert it into what? Two dimension. Can you see that? So here, if you focus, guys, this is what? Two dimension. How it is two dimension? I'll show you. So how it is two dimension? Can you see there are two square braces, guys? Come on, everybody. So for that, what I've done, I have written this line of code. And you can reshape also, that's fine. You can reshape now. You can do in n different manner. Okay. But I just took the line of code what they have given. Now, so this is all about horizontal stacking. Let's do vertical stacking. Let me put the headings. This is horizontal stacking. Now I'll go and do vertical stacking. So guys, I'll take the same one. You see, right? Vertical stacking is very easy because it is about the axis 1, axis 0, right? So there's no tension now. Whether it is 1D or 2D, it doesn't matter, right? Because you can stack it. So what you can do, you can just write one line of code, np.v stack, and you can say a comma b, and it will work like charm. So see here, let's understand it. So first, let me show you, this is your C, right? C is what? Ndim, one dimension. When you write this column, what happens? See, it means what? It means everything in the rows, nothing in the. So here, as of now, if you see, right, what is this? Everything in the rows, right? Nothing in the. So there's only one row, and all are in the column, right? This is column. So how many rows there? Only one row. How many columns there? 1, 3, 5. Think like a vector, matrix. One row, 3 columns. I want everything in the rows. So that's why I have done column, and nothing in the, not multiple thing in the columns. So that the moment if you do it, so what it does, it takes one element, right, and create one element as an array, right? Are you guys getting or not? So that's your 1D array, 1D array, 1D array. So what has happened, every element is becoming an array using this syntax. So I can write 1D array. So yeah, it's a good learning. I think something you can keep in mind. Okay. But you can do this in different ways as well, right? Cool. So how you can do that? Try it at your end. We can discuss it later. So guys, this is all about, this is all about Numpy. There's one small topic, but as I promised, I also wanted to give you the introduction to Pandas because I want to start the next topic already. So there's just a split one, which is left behind, and broadcasting. So these are two things which we can cover up, but I want to start Pandas introduction. So it's going to be very, very good introduction. Okay. So I'll not go into too much detail of Pandas here. I will give you a quick introduction. Okay. So, and I'll give you with an example. So generally, when you do exploratory data analysis, right? I think everybody must have heard this word, which we call it as what? So I was talking about EDA. EDA. What is the full form EDA? EDA is known as exploratory data analysis. Okay. So any data scientist or data analysis, so data analyst or data scientist, their life is all about EDAs. Trust me. If I can give an example, and to those guys who are pretty new here with me, guys, suppose you're doing a ML based project. ML is what? Machine learning based project, means you are using machine learning. Like, what do you guys think? How much is the distribution of EDA? I believe EDA takes 30% of your time, followed by data preparation, data pre-processing. That will take another 40%, and 30% is what? ML. So your model tuning and all those things. You will not be doing model tuning, feature engineering, running different algorithms to understand, benchmark your results. You will just do 30%. What is this 30%? EDA. You will start your data. And the moment you start with the data, you want to know your data. So what is your data? Right? So EDA we do to know our data. So just like when we started this session, right? You wanted to know who am I, right? Once we are aware of the data, we go into the next phase, which is what? Data preparation. Right? We call data pre-processing or data preparation for your model. So you need data in a certain way so that you can input to the model, right? EDA is all about knowing your data. Data pre-processing means getting the data, cleaning the data, right? All those things are going to be also part of your Pandas. So to be very honest, right, EDA plus data processing, right? To do all those things, most of the time, people use only one library. And what is that? Pandas, right? Pandas. So Pandas is going to be your the library for most of your life when you're doing data science or data analytics. Trust me. Data science is all about model tuning, right? This is all about data analytics. Okay. So those who are only interested in data analytics, they can see. So when you do EDA, you are doing pre-processing. Pre-processing means a lot of things. I'll go there. Okay. Don't worry. So this is your DA jobs. You don't do any ML thing there. And when you do this, so let me use another one. Add me a pen, maybe this color, yeah, or maybe this color. And if you are looking at this, that becomes what? Data science, DS. Okay, guys, clear? Is it clear or not? So that's how your job is going to be defined. I'm interested in telling you that how you are going to do your job. So DA is all about EDA plus pre-processing. So now let's talk about what is EDA and how the hell you will use Pandas, right? So let's break it. So when I talk about EDA, EDA is all about getting your data, understanding what is in the top 5 rows. For that, you do, your data frame dot head, you're coming from Pandas. You can also look at bottom 5 rows, trying to know your data, right? So you can do df.tell, bottom 5 rows. You want to understand how many columns are there, right? So it's all about your info. So all the columns, what is the column structure, whether it is a string object or whether it is a numeric, whether it is having nulls or not, any missing values. That's what info will give you. If you're looking at to describe some basic stats about your data, right? So you will do describe, so you can understand what is the data looks like, right? So this is all about getting to know your data, explore your data. That's what we call exploratory data analysis. Okay, guys, make sense or not? This is just the beginning, right? It's not the end of it, right? There are a lot of things you can do. Now you might be interested that once we have these information ready with me, right, you can do an n number of things. So this is more like exploratory analysis, right? So EDA is all about taking the data, slicing and dicing in different ways, sorting it, grouping it, right? You can also say, okay, I have a superstore data and I'll give you this data. That's what we use all the time. So it's known as superstore data. So this data talks about the revenue of different product category and subcategory, product category and product subcategory. Focus. Now I might be interested about that. Okay, now I need, and this is across the dates. So there are, I think, starting from 2016 till 2020, 4 years of data you have in this sample file. It's a very famous, world famous data. Across the period, across the date, I want to just focus that what are my top 3 product categories in terms of sales. Can I ask this question? Yeah, right. So which are the top 3 product categories I am selling, right? So what you will do, you will think about grouping the data, right? And then, so how do you answer this question, my dear friend? You will try to group the data at this level and then sort it by high to low, sort it by sales, high to low, and get the top 3. Isn't it, guys? Come on. Hello? Similarly, you can also find what are my bottom categories, like, top lines and bottom lines in terms of supply chain or any businesses, right? Top line is what? The product category which are selling like bomb. Bottom lines are what? Where you are not selling anything. The loss is happening, not profit. So everything you will be doing with the help of Pandas, right? Are you getting or not? Then you might be wondering that what kind of pre-processing I might be interested in, right? So this is like knowing the data. This is all EDA. Pre-processing is different thing. Let's talk about it a bit. So when I say pre-processing means what, guys? What are the steps you think pre-processing will happen? Curating the data, I think, yeah, these things are important. So guys, data pre-processing is everything, to be very honest. What you have seen in EDA, if I be very honest, more or less a lot of things that we are doing is part of pre-processing. But exactly if I talk about pre-processing the data, it's about first load the data. Definitely will load the data, number one step. And then you will understand, you have already understood the data. So now you want to go into the removing the columns which are not helpful to you. Column drop. So dropping the column which are not helpful to you. You can think like, so guys, always understand, removing the columns, missing value treatment, right? Anomaly detection, outlier detection, anomaly outlier is same, and treating it, that's also there, right? Then you might need data in a different way, right? So you might need to do some kind of joins, right? So joins is like you have a transactional data, you have a sales data, remember that I've already talked about, and you want to join this with item master, or you also want to join with location master so that you can use these attributes in your machine learning model, right? You will do here. This is pre-processing, isn't it? One hot encoding of categorical variable, because machine learning doesn't take categorical variable, it cannot quantify it. You need to do one hot encoding. Last but not the least, you have to do a train and test split. That is also part of pre-processing. So this is the quick introduction. And to do all those things, you can use Pandas. That's what I'm trying to say. So can you see that till the time you are calling, right? You're calling your machine learning model, which is your 70% job, is all about Pandas. Sky is the limit there. Okay. And now Panda has recently released a new version, right? And that has become more powerful. Pandas has though a lot of challenges with it. So when the data becomes huge, right? So you're looking at 10, 20 GB of data more than your RAM, then Pandas become really tough library to work with, right? So what is my suggestion here is, guys, first let's understand Pandas, but there are a lot of libraries, right? You can use. So there are a lot of libraries in Python itself. You must have heard about Parquet file. I don't know if you have heard about not. So when the data is used, we go into parallel computing, parallel processing, and Parquet file is one of the way to do that. Then people use Dask, DASK, not dash, DAS. So DAS data frame is also very, very helpful to handle big data. People do, PySpark. So PySpark is altogether a different thing. It's Python only, but written in a different, so it's based on the Apache. So Apache is something to handle the big data. So you have but that is something I would say go step by step. So first we should go and be good about it. I would say about the uh, data science in Python, and then these are your more like a ad hoc learning which you can do anytime. You can do on your own. So when I was doing a project on forecasting, I had to learn Parquet files. I did it on my and DAS. So these are two things I learned on my own. Depends on the project, on the data. If the data is really huge, you need these things at your help, at your table, right, on your hands. Pandas is going to be a really interesting topic and apparently very easy. So the first thing I would like to say here is that Pandas is an easy topic. Numpy might have a little, three-dimensional array and all, but generally in Pandas, we just deal with the two-dimensional data, not in normal process, right? It is always going to be two-dimensional, means rows and columns, no layer behind the layer. So that's the beauty here, that if you're looking at pandas and panda, they are cute. I'll start with a very good image, and this is Python pandas, right, in the heading. Okay, and Numpy is interesting, Jiten. Yes, it is interesting. And this is the real panda saying hi to everybody. Okay. I still remember that I have to talk about a bit on, inheritance and polymorphism, right? So it has not gone, into the code, but before we close and wrap up our batch. And then we already have something to be in connection, and that's what professional Slack platform is for. Now, Pandas is one of the key libraries for your data manipulation. I think the library, I would say, not the key libraries. It is one of the very important libraries for doing all the Python important data analysis. Even you are a data scientist, right? You are supposed to do Pandas all the time. I know Pandas data frame are the mostly used by data analytics and data scientists, but it has a little challenge, and the challenge is of the memory. It has nothing to do with Pandas. And let's say your data is really huge. I'm talking about a file which is low, let's say 6 GB, 4 GB of file. Then Pandas, they struggle as a data manipulation library. And there are the other file formats which I've already discussed in the last session, like Dask is one of the other libraries which you can use for these kind of parallel processing, PPs. Parallel processing is called PPs. Parquet file is such data frame structure which also enables you to do that. But looking at the cloud in the picture, so I'm talking about not that the real cloud, I'm talking about the computing cloud like Azure or GCP or AWS. You have a lot of memory in your hands, right? I'm talking about some 200 GB of RAM, and you have really good computational power. So Pandas still does a great job. So now you're not going to do big problems or big projects on your local machine having 4 GB of RAM. I think even for my system, it is not 4 GB. My system is having 16 GB RAM. So more or less it handles basics to intermediate level of data. But the moment get data really huge, right, it gets into a trouble. But there are other ways around it, okay? So Panda is a package in Python, originally generated from panel data, right? So it's one of the important tool for the data analysts and data scientists. Powerful ML and visualization tools work on the back of Pandas, right? So you should know that every machine learning project that itself starts with Pandas, right? So be it taking the raw data and creating a quick summary of the file, looking for the missing values and how you can treat those missing values. Are you finding any anomalies, and how do you want to handle it? You want to join several different files to reach a master file or a master transaction file, right? So that you can build machine learning on the top of it. You can also use Pandas to do training and testing, right? So when I say training testing, not Pandas will do training testing. You will use Pandas to create training and testing data sets, right? Nowadays, a lot of machine learning algorithm libraries, they already have these training and testing inbuilt functions, but Pandas also helps you to do that. Okay. So I believe if I can say that, which is I have highlighted in the bold, that Pandas is the backbone of most data projects, it's not wrong. And a quick definition for Pandas coming from Wikipedia, guys. So here it is. So Panda is derived from the term panel data. Can see that PN and DA, Panda. And panel data is mostly you will find in not in your data science project or data analytics project a lot, unless until you are dealing in finance and economics domain. So it is an econometric terms for data set which include observations over multiple time periods for the same individual, right? So more like share market data can be a panel data because you're looking at the same Yes Bank share every week, every quarter, every month, every quarter. Okay. So Pandas is your backbone of everything. Okay. So now to do Pandas first step, right? So a lot of time people think that what to do with Pandas, right? Why do we need Pandas? I know nobody has asked this question. Let me ask this question to everybody. So what is the first thing you would like to do when you have a Pandas in your toolkit? Right? These are your weapons, right? So why do you need Pandas? So see, visualization I have talked about, analysis I have talked about, extracting the data is also one of the big things Pandas can do it. So guys, how do you extract data from Pandas? If I have to talk about, right? So, you can extract data from, right, a lot of places like SQL table. You are looking at a SQL database, right? In that database, you have multiple tables. It can be item master, it can be lock master, it can be your sales data. That's have been discussing for a long time, right? Every table will have an address, right? IP address and all, and the connectors. Using that, you can actually load this item table into your data frame, like df underscore item. Similarly, you can do for location, you can do df underscore lock, and you can say df underscore sales. You understand, guys? So this step, what you are seeing here, is it like, are you analyzing something here? No. The first step is like what you're doing here. You are extracting the data from SQL table. You can do a lot of extraction from the web page. So you have a web page address of any file. You can directly get the data from the web page as well. Does it make sense, guys? So definitely, generally we don't follow Pandas for ETL thing. ETL is extract, transform, load. But sometime I think it's important to know that you have this power as well, right? You can also do ETL activities, which is generally done by SQL. Okay, cool.
Let's have a quick quiz question, guys. And the question is, which of the following is a type of plot commonly used to display distribution of a dataset? And your options are scatter plot, line plot, histogram, or bar plot. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now Pandas first steps. So Pandas first steps is about installing it, right? So if you guys have installed Pandas with me, so I feel when I say install Pandas, definitely you have installed it using Anaconda. So Pandas should be there in your systems. Okay, so you don't need to actually do it, but in case you want to install, you're using something else, so you can install and you need to import it. Import is anyway important. Everybody has to import. Even I have to import. So how can you do it if you're using of Anaconda and it's not shown in your import? So you can do conda install pandas using conda terminal, using Jupyter terminal. You can use pip install pandas. Okay, so that's something you should be noting down. Sometimes people also ask, how do we do it in Google Colab? So I'm giving you for Google Colab as well. It is exclamation pip install pandas. So let's import pandas. I think it is in my system, and I think it should be in all of your system. See, So now Pandas is loaded. Okay. So before I get into the detail of Pandas, let's talk about core components of Pandas. So there are two components of Pandas, and one is known as series, other is known as data frames. Okay. So guys, series is what? It is 1D. Data frame can be, right? Data frame can be 2D, right? Data frame can also be 1D, but series is the backbone of your data frame. So if I can define a series is essentially a column, you see one column, that's your series. But a data frame is a multi-dimensional table made of collection of series. So series is basically one dimension, always one dimension, one column. Think like one dimension, one column. But your data frame is a multi-dimension table. So just to give you that definition, now let me give you a very good image to explain my concept on it. So if you look at that, you have two series on the screen, guys. So I'll try to annotate here quickly. So you guys have two series. What are those series? Series 1 is apples and series 2 is oranges, right? Can you see that? So it's 1D. Can you see that? It's 1D, one dimensional data, one column, one dimension, right? More like think like matrix, row vector, column vector. Remember that basic maths? So series is 1D, apples, oranges. And can you see there is a plus sign here? This plus sign is doing what? They're combining these two 1D data into multi-D, right? So you're just adding or attaching orange to the apples, and that's what you see a data frame has been born. So most of the data frame and series operations, a lot of functions are in similarity, right? So I'll just get it clear and I'll write here data frames. If you want to write exactly how the data frames have been defined in terms of spelling, it is D capital F capital. Data frames and series are quite similar in operations, in many operations. I won't say every operation, but most of the series functions you will find in data frame as well. Jiten, you're right. It looks like joins in SQL. You're right. The only thing that to join here, you have to use index. Okay. So guys, if I talk about pd.series, my biggest point here is if you do pd.series, right, look at there. So pd.series, if you pay attention, which my dear friends, my student never they do that, and everybody will be making that mistake that you will write series with small s. You have to write series with capital S. That's the syntax. If you don't do that, you're gone. You will be finding a lot of your syntax error, and you will be breaking your heads that what's happening there. And then you will realize and you understand, oh my God, it is just S capital, you have missed it. So just a reminder to everybody here that you have to use pd.series. Whenever you're doing series, make sure that your S is capital. Please take care of it, right, somewhere. So what are the parameters in that, right? What are the arguments? Data. Definitely you need a data to create a series. Then index you can define, right? Then data type. Okay. Then there are other things, but for now I think this should be enough. Okay. I'll talk about other things as well as we move on. So guys, data type can be string, it can be numpy data type, right? Name, you can give name to the series. So if you remember here, see here, you can give name to the series. My series name is orange or apple, right? So that kind of naming convention you're giving it. Okay. Now let's create a data frame using n-dimensional array. Okay. Hold on. So now let me just get into coding mode altogether. So I'll create a data frame by using array. That's what we have studied, right, guys? So for that, you remember, if you're doing this, ideally I would suggest down the line you always import everything. Import nps, numpy as np, import os to see for your working directory. Now if you have your numpy activated, you have imported it. So what you can create one array which I am creating by using random function, np.random. Ran n, and I'll say 5, right? And I'll print apc, print type of apc. So you can see that it has created a, right, a length of 5 elements in the array. We have this array, right? That's clear. And you can also look at the type of the array. It is numpy n dimension array, right? And it is 1D. If you want to see what is the dimension of this guy, so you can do apc.ndim and you will see it is 1 dimension, right? Now to create a series, series pandas series PDS, right? I can say pandas series, or let's call PDS. It is very easy. PDS equal to what? You will do PD dot series. What is the syntax? As I've just mentioned, you have to do PD dot series and you have to give APC. Please pay attention. And then if you don't do anything, look at that. What it will do, if I print it, guys, don't give anything, just put the series data there. It will print you that series. And you can see that, what is it? It is pandas.core.series.s capital series. So did you notice, guys, what I've done? I have taken on, APC, which is your n-dimensional array. I am converted the same into the series. Then you might want to see that what is this data? It doesn't look cool, right? I know it is flow data. Can I also give some index to it? So that where you can just copy and paste the same code which I've done, and you can say index. Now you have 5 data points. You have to give 5 indices. So we'll say it is A. Let's call it like B, C, A, B, C, D, E. Now I've given the index for the series as well. You have created a series. You have given the index. Now you want to access the index. What you can do? You can say, I want to see what are the indices of this series. Can you see that? So index is A, B, C, D, E, right? Clear? But generally, I think in our practical, typical data science project, indices generally we drop, to be honest, because we do a lot of transformation, and sometimes indices don't make sense, right? Because it will keep losing, right? If you keep joining the data from one to other, right? Indices generally doesn't help a lot. Indices generally don't help a lot, but it's good to have. There are some examples or some cases, but where indices can be helpful, but not everywhere. Okay, now I'll show you what are the functions in the pandas series. So can you see that? You can do this directory of pd.series. So what are the different methods, classes, right, available to you? So all those, if you focus here, double underscore left right is your classes. And if you come down, excuse me, if you come down, what is it? ABS, add, prefix, append, right? Append is something, it seems to be useful. Let's see, count is very useful. Data type is useful. Duplicates, filter, min, max, is NA, rename, drop column. A lot of things are there, right? So you might be wondering, do I need to know everything in this series? Big answer is big no. No, you're not supposed to remember everything. As you have already seen me doing, right? It's a vast thing for each of the libraries, right? To remember everything, do everything, you should know everything. Nobody knows everything, but we should know the ones which we need to use all the day. Okay. So you need to understand when somebody says index, right? Index is part of the series. And since series has a lot of objects, index is also one of the objects. It's telling index is what data type? It's an object. By default, it is always been object. And since you can see in pandas, right, there are a lot of objects which are creating, right, which we have not created. The pandas library has this already. Okay. And there you can put any data. So it's more like a object which can take any data. And to prove my point, right, so the class of this is like, it's an object. Generally in pandas, you will see a lot of things are objects. Okay, mostly everything is an object. There you can put any data type. That's a different thing. Okay. So now if you want to understand this very well, let me do PDS and I'll change this to in string to number. I'll show you. What do you guys think? See, now the indices are what? Number. So now again, if you see what is this PDS, can you see that? Here the data type is integer 64, but it is an object, right? Index is an object. Now the moment you change the data type to string or some alphanumeric number, it will be treated as object. That's how the data type they have defined. And here, when you're putting a real number, right, integer, it will be integer. If you put decimals, it will take it as float, if I am correct. So let's take 2.0 and you will understand that, does it work? Yes, can you see that? So it's an object, but not every time it is going to be an object. It can store any different data types, and basically using that, you can define what is the data type for that index object. Index is an object which stores different things. So now I'll move on to what? I have created data from n-dimensional array. Let's create data from dictionary. From dictionary. Remember dictionary data type or you forgot? So again, I'll say, let's say Python score. So I'll create a dictionary first, remember, using curly braces. And you can say, so I'll tell my Python score out of 100. Let's say I'm an instructor, I'm really good. So maybe I would have scored something more than 90 out of 100. 95, I'll pick for mine. Let's say who? Monica, since you have asked the last question. I gave you 96. And let's take Abdul here. And let's say Abdul is our topper here. Okay, just 3 data points. Okay, so this is a dictionary key value pair. So now if you print score, keep coding with me, my dear friends. What is type of score? Just to show the data type. Dictionary, this is your data. So what you can do, you can convert this dictionary, convert it into what? Pandas series. You can say name score equal to pd.series, and you can put score in it. And then you can print score, sorry, name score. See, something I missed. Yeah. Guys, can you see that? So definitely it is a data type integer 64 because the numbers are integers. So what is happening here? Did you notice anybody? Did you notice anyone can answer this? Did you notice that Akash, Monica, and Abdul already coming in the indices? Right? And since it's string, it is what? Data type object. So what it has done, what is your observation? Observation is, my dear friend, please write, what is your observation? Keep talking to me. Your observation for this is what? That by default, please write, by default, dictionary keys are used as indexes. As index, sorry, not indices, index. There is only one index. Guys, did you observe everybody? Did you observe that? Now you are saying that no, I want to give my own index. So you can also do the same thing. Name score, let's call my own index. So what I'll do pd.series. Now I want to show you something else. pd.series, I'll say score. And I know that in the syntax, I have this score is score, then I have index, and I want to give my own name. So I'll say Akash, that's fine. Then I'll say, what was that? Monica, right? Monica. Then you say Sakshi. Now you want to name your own series index. So you can do that. But do you notice one thing I have intentionally done there? Anybody can notice that? Come on. I have not put Abdul's name. I have put Sakshi's name. Very good, Sridhar. Good observation. So I have put in place of Abdul name, I have put a different name in the index. What do you guys think? What will happen? Because still that dictionary is core. So now definitely there will be an issue when I'm saying right third place as Sakshi, not Abdul. Let's take a look at this. So when you click on it, you can see that it has still taken the Sakshi as the index, but it could not find any value for this key Sakshi in the original dictionary. So then what is it done? It has put what? NaN. Hello? It has put what? NaN. And what is the meaning of NaN, guys? Please write it down. NaN, not a number, which in simple English means data is missing. That's very, very important in Pandas. Very good, Sakshi. That's right. Not a number and data is missing. Okay. Now you can also use series to do some of the search, right? So you can, let's try to find all the students who scored more than 95%. Right? I can do that. That's a question, guys. For the same, right? Let's try to find all the students. I'll not number the question, else I'll get crazy. Yeah. Who scored more than 95%? If you look at this example, who scored more than 95? Come on. You know that it is Monica and Abdul, right? Just follow this example, everybody. Monica and Abdul, but there are just 3 students. You can just print, you can check for it. Imagine this batch has 1,000 people. How will I do that? So their series says, okay, I'm there to help you, right? So first use this into Pandas series. Now it's a Pandas series. Now what you can do, you can say name. Look at the syntax, guys. You can go and find all the greater than 95. Can you see that? False, true, true. You can just search this series. It's a simple one-dimensional data, right? Akash is false. It's a Boolean return. Output is a Boolean return here. So now you can identify or return Boolean flag showing students whether they scored more than 95 or not, right? Whether they scored more than 95 or not, right? So those who have scored more than 95, you said Abdul and Monica, they have said true. Now this is very, very interesting syntax I'm writing, guys. So you can take that series. It's more like your, Boolean flag. You can put it within it, right? That's what you can do under the square braces. And you can say more than 95, and it will print the result of these 2 guys, which we are expecting, right? Monica and Abdul. Very good. So this is what you can say, right? This is what you can say it as what? Like filter the series as per the criteria. It can be only one criteria. It can be multiple criteria, right, guys? You can also find basic statistics, descriptive one. So it's very easy to do that. How can you do that? You can find some basic statistics of like name score dot min. You can find average score in the batch. Come on. You can also do name dot score. And guys, don't forget, we need to do print. So guys, syntax is name score dot min. And those who are not able to understand how are you getting it, so it's very easy, guys. You can always go, you can take the Pandas series, you can put .m, and you will see all the different functions available to you. Max, min, median, min, mode, all those are start with m. So in case you are not able to recall what is that syntax, just do tab, okay? Just do tab. Don't forget it. Now you can also find average you have done. You can find median. I think median works. Let's see. I saw that. So you can find median, right? You can find print name score dot. You can find min, right? You can find minimum. I think I was the one who scored minimum. Print name score dot max. You can find maximum, right? So these are some of the basic stats you can find. Correct, guys? So you know, right? What is the average marks? 96.667. What is the median? You know that if you arrange 95, 96, 99, Monica is getting the median score. Minimum is mine 95, maximum is Abdul 99. Everybody is clear with simple example like this. Come on. Easy P, right? This is easy, right? Okay, I think so, because now quickly let's take a look on the series object attributes. So put that in, guys. Series object attributes. You will be using hardly any series, but when I say that, it doesn't mean that I am promoting you guys to don't do anything. Don't take me wrong there. So can you see that, guys? I have given you some, some of the syntaxes. You have already have seen few of them, but let's take a look. You can do series index of the series. Shape, it returns a tuple of shape of the data. I'll show you all. A data type you already know. Size of the data tells you how much memory it has used. It returns true if the object is empty. It returns true if it has NNN values which are missing data. All else will return false. It returns the number of bytes which are being used to store the data. NDIM returns the number of dimension in the data. Now what I'll do, I'll take the another favorite series on mine. I'll say APC equal to, now I'll combine syntaxes, okay? So I'll directly write pd.series and I'll just define a random array there. Directly one line of code. You are smart now, random, and then it will give me what? 10 data elements in the array, and I can print APC for a quick check. Yes, so I've got 10 elements float data type. Now you can do what is your index. So you can do apc.index. So you can see your index is this. So you might be thinking, what is this index here? I don't understand. Come on. Index, since it's in range, it is sequential. So you are looking at range index. Start from 0, stop at 10. You have seen this, right? 10 means you will stop 1 before, so it will be showing 9, and step is 1. That's a by default, sequential index you will be seeing as an output. Now you can also see a different index. So I can show you if I so name score dot index, right? See, now since the indexes were index was the names Akash, Monica, Abdul, then you will see index as it is, right? Depends on what is the your series is. What is the shape of the data? So if you see apc dot shape, right, you can find it quickly. So it is 10, right? It's one dimension, so it is only 10. There's no other columns, so it is 10. Now what about dimension of the data? What do you guys think? Only one dimension, right? Then you can think of bytes. How many bytes are there? Right, 80 bytes it is storing. So 1 byte is 8 bits, so it is 80 into 8, 640 bits. What is the size? Size is your, right, it's similar to what you have seen in Numpy, right? Size is also going to be 10. Do you see that any of the lines is empty there? So it will be all false. But let's say if any of the line is empty, then you will see that, okay, data is having, some empty object, right? If you do has NANs, there's nothing missing in the data, I will say, okay, nothing missing in the data. Okay. And you can also find what is apc.data type. So data type is float. You already know that. What is apc.values? So it will show all the values of the data. So it's the same number what we're seeing here, right? Now, empty and NANs is something must be tricky. So let's check that. Checking emptiness and presence of NANs. Okay. Now what I'll do, I'll create another series and intentionally I'll put my data equal to, and you can also start with a list. Can you see that I'm using a list there, guys? And there I'll place a blank data. Let me show you here. Okay. So can you see that, guys? This data, and those who are interested, okay, can I set the data and all? You can do that. So you can say int 32. Oh, it's not taking. Okay, float and right, because of the missing value, you cannot do that. So by default, it will take it as float. Okay, sorry, I can't do that as integer. So by default, if it's a missing value, it can be 0.001 also. So it will take float. Right, guys, come on, focus. Do you see that there is a data is missing there, guys? Come on. So I have shown you 5 elements. One is the missing element. Now let's do a dot empty. So what that empty does, let's talk about it. Wow, such a nice documentation there. It will check, is it empty? Answer will be false. Why? Because it is still having not a number, but you have allocated a position there, right, to this object. Okay, this object is not empty. Let me show you the something. So if I create a, and if I say data equal to look at here and print b, it's an empty list, right? Now if I do b dot empty, what do you guys think? True. It is having NaN is not missing, and it's also having some data is there, right? Are you getting or not? When we say empty means empty, nothing has to be there. It is having some values, right? NaN doesn't mean that it is a missing values, right? If series object is empty, not see, then if you are checking only for NaNs, then why do you need this has NaN? It's a redundant, right? Now it will show true because it can see that there is a NaN, guys. Now let me take an exercise. So I'll do question here, right? And there are a lot of questions which I'm going to do, but for that I need to create the data of quick data, and I'll do it. So let's say Python test score happened. Python test score has come. Let's name this series and give it to a dictionary there. Okay. So it will be, let's say data equal to a dictionary. So I'll go into braces, curly braces. Akash had scored, 90. I want to give you some, my student, and she has scored 99. Very good. And let's say we have Shirley as well. Generally, I pick name from the last comments, and she has done fairly 88. Don't take it seriously, these numbers. And then there is a person called Ram, and he has got very low mark, 75 out of 100. And this is your data. So I know you are supposed to do this. Print Python test score. Guys, question number 1, how much did Ram score? I'm interested in how much did Ram score. That's first question. Second question, guys, print the names of all the students who scored more than 90. That's question number 2. Question number 3. We realize that Ram score is having some mistake. So update Ram score from 75 to 82, and which is due to some error in calculation. कुछ भी हुआ रहेगा, right? Some error in calculation. So how will you update that as well in the series? Okay, guys, you're coding with me. Question number 4, print the average, min, max, and median marks of the class. So let's start with that. So Python, let's print it. Okay, so these are the students with the marks. I'm interested only in Ram. How will I find Ram? It's very simple. You can just slices with the name. It's a series. You should just know the name of the student. right? So it is 75. Very good. Print all the students who have got more than, you have already seen a similar exercise. You have to just say greater than 95, sorry, 90. So those are Aditya and Sakshi. And you can see in the data, Akash has got 90, so he will not be shown. 88, surely Ram will not be shown. Update Ram's code 75 to 82. How will I do it? It's very simple, guys. You can say Python access RAM. You go to RAM and update from 75 to 82, and you can print Python. See, guys, can I see RAM has gotten now 82, right? Here it's very simple. Initialize this variable RAM with the number 82. Sorry, not initialize, update it. Now print the average and all. I think this is like cakewalk for you. So this is your mean, average. How will you find? Maximum will be what? This one 99. And you can also find median. Okay, it will be 90 marks. Very good. Clear, easy P. So what you have just done, this is your statistics of, statistics, central measures of tendency, right? And you can always search any name there. So you can say, okay, do I see Anand in that Python? So this is another big, powerful function, right? Yes, without bracket also works for you. It should be, right? You can search that Anand is there or not. No, Anand, there's no student operation, not baby, my bad. Basic mathematical operation. I meant to say you can do baby stuffs, right? So you can apply basic mathematical operations to series. For example, you can take the same Python, right? This is your this, and you can convert it into what? Right? You can divide it by 10. So every position in the data will be divided by 10. You can see simple division you have done. You can multiply this into 2, so it will be 22 times, right, guys? Can you see that? So since you're not storing, the old number has not changed. Can you see that? Exponentiation you can do, so you can also do 2. So what it will do, it will become square of that. Then something is called is null. There's another function called is a we have not seen, but you will see very soon. Is unique. So there are a lot of things, but is null is something I'm going to talk about it. This is similar to what you have, identical, I would say, not similar. To see the missing data, there's no missing data, it will show all false. Same thing you can do. This is exactly the same. So is NA is null to see the missing data. Okay, everybody's cool there. Come on. So guys, I think this is a good position on series. But as I mentioned again and again, Pandas data frame is something you're going to deal on a daily basis. But I did not, generally people don't teach this. I've spent 1 hour on it. So you can see the difference. Series is something I should teach. But it doesn't mean that we'll waste all our time on series. And that's where I'm starting the new topic, creating data frame. Let's talk about data frame, which is going to be your bread and butter from scratch. So guys, we can create a data frame from scratch, and you have already seen data frame you can create from scratch as well, just like you have done in dictionary, you have done with arrays, you can do a lot of things like that. So let me give you my first. Okay, so there are many ways to create data frames, but ideally we will not create any data frames. We will load it from some files, right? So you can create in many ways data frame from scratch, but whenever you are supposed to create, use dictionary. Dictionary is a powerful method there. Okay, now let's create a data frame of the fruit stand. So that's where I'm taking this example. Let me put in another line so that it is pretty much standing out there. Okay, so if I do that, let's say we have a fruit stand and that sells apples and oranges. You remember that series? And we want to have a column for each fruit and a row for each customer. So what I'm saying that we have a fruit table, fruit stand, and there I have put, apples and oranges. And I want to also have a column for, each of the fruits. I also have a a row for each customer purchase. So let's put into a dictionary. Okay. So now what I'm saying, this is my data. So let's create a dictionary value pair, key value pair, and let's say that it is apples, right? And in this, these are these are four customers who have bought 3 apples. Customer 2 has bought 2 apples. Customer 3 has bought 0 apple, no apple. Customer 4 has bought 1 apple, right? That's what I'm saying there. Let's talk about oranges. First customer, no orange. 3 oranges, 4 oranges, 2 orange. And don't miss this comma. Okay. Let's say one more fruit here. Sorry. Not only apples and oranges. Let's say bananas as well. And let's say it is 1, 2, 3, 2. Okay, guys, let me run this. It's a valid data. And let me show you print data. So you will see the magical things. Can you see that apples 3201, oranges 0342, and bananas 1232. So you can clearly see that there are 4 customer and 3 fruits category. Okay. Now, if you look at the type of this data which I've created, it is what? It is dictionary. Now, I want to create a data frame from here, and I'll say pd dot data frame of this data, right? And I'll print it. This is my purchases history for the day, for the last day. Can you see that? Now you have index in the left, then you have a column called apples, column called oranges, column called bananas. Is it okay, guys? Everybody's comfortable with this? Then you might be interested in saying, no, sir, can I do one thing? I want to also give the name of the customer. So let's give the name of the customer. Let's call it index. Let's put the name in the index. And I can say the first customer is Akash. Second customer is Sakshi. Third customer is Shalini, right? And the fourth customer is, let's say, Mohit. Okay, guys, see here. Did you notice that your names are coming in the index, guys? Come on. And you can also check that whether it is an index or not, right? You can always check that. So that's your data frame coming out of dictionary, right? So I can say here, tada, from dictionary. You can also do it from the list. Okay. I'll just stop here. I'm just telling you how to create data. You can also do it from list, right? That's another way of doing. Now you can also use, list of dictionary. That's another way of doing, right? Not only list, because one list has only one information, right? So you need to create list of the dictionary, and you can say list equal to, let's not use this, list is a function. So let's say list, let's call my list. Okay. And then you can say list of dictionaries means what? You can say, let's say A1, B2, C99. That's one dictionary within the list. Then I have another. Then I have another. Did you notice that I have just maintaining, I'll change the number 1020 and make it 90, make it 89, make it 12, and make it 11. But if you observe this clearly, this list, my list, and I'll also print it. See, it is a list of dictionaries, as you can see there, but I maintain the key there. Can you see that? I have only changing the values in each of the dictionaries there, right? And now if you create a data frame out of this, I don't want to store something here. I'll just say my list, and I can use the same index, which I have highlighted there. So what are they? A, comma, B, comma, C. And you will see the magic.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
See, Can you see that index is what? ABC, or you can say no, I can say as int1, I can say int2, because I put the same index and same column name. Sorry, my bad. You can see that, right? That's why I was trying to change it. What you can do, guys, you can also use list or list of list, no, nested list as the data values. Oh, okay. So I've already, I have already put something there. So I'll show you just to save time. So you can see that I've created nested list, more like a 2D array there, right? Can you see that? And then you can print, you can say it is class list, and you can use it into data frame. See here, guys, come on. Everybody, please pay attention. Now you might be interested to know, I want to give some column names, right? That you can also do. So no, I want to give some columns names. You can say columns, there is a syntax, and you can say A, you can say B, C. Pay attention. I'll take a pause here, guys. So here you can also explicitly apply the names of the columns of your choice. I've created the data frame from dictionary, just like I was doing for series. I've created the data frame from list. So for the first time, I've used nested list, right? And similarly, you can do from NumPy 2-dimensional array and all those things you can do. But now, guys, the most important thing is what? Creating, hold on, creating a pandas data frame. This is the most important thing we will learn today. From files, different files. Okay. Shalin is telling, okay, I should go a little bit slow. Okay, I'm going too fast. I think they are very straightforward. Okay, let me go a bit slow. Okay, I'll go a bit slow. Okay. So now, guys, we have created different ways to get the data. The most important way to get the data is from files, and that's where we'll do reading data from CSV. In that as well, the most important way to read data is from CSV. Now, the moment I say what is CSV, guys? Come on, right? CSV, comma separated values. So, guys, what is a CSV? CSV is comma separated values, and I'll show you in the data itself. That's a format, and generally it is known as flat file concept. So it is going to be a single line, right? And each of the lines, so suppose your record is, let's say, row number 1, it will be your row 1 separated by comma, and all the columns in row 1, let's say there are 20 columns. When I'll show you data, you'll understand more. But let's say you have 20 columns in the data, so each column information will be separated by comma. And since each information, what we call it as value, that's why the file structure name is comma separated values. So the values are separated by comma. Simple, it's a file format. Then you have different file format like Excel, text, DAT file. There are a lot of file formats. Okay, but 99% of your files will be either CSV or Excel, trust me. Okay, or it will directly come from the SQL table. That's different thing. That's whole together a different game. But most of your files will be this. So what is a CSV? CSV is a comma separated value. Comma is a delimiter there, guys. It's a delimited text. Means you can also use a different delimiter like tab or colon or forward slash, different type of delimiter. And when you are trying to use delimiter, is something to separate the value from each other. Each line of the file is a data record. That's what I just mentioned, right? So one row is your one line in the file. Each record consists of one or more columns. I just explained that, and it is going to be a tabular data. Okay, so now, guys, let me show you the data. Okay, and I'm going to share you with a very important data which we are going to use in our pandas a lot. And there are 3 files which you need to have when you are discussing 3 or 4 files which we are going to discuss in this Pandas or later visualization as well. Okay. So keep all these files in the same directory, guys. I have shared all these files with you. Monica is asking, can we access text file? Answer is yes, you can do that. Okay, now what I'll do, I will show you this data, IMDb data. And if you look at my screenshot to understand it better, so I'm giving you a glimpse of IMDb data. Now this is having all the records. So guys, please pay attention. If you see, these are your column headers: rank, title, genre, description, director, actors, everything. Metascore till these are your column headers. Yeah. Number one is your one record and it ends somewhere here, guys. Can you see that? Metascore is 76. So if you look at every column information, one comma, Guardians of Galaxy, comma, till here, comma, right? Can you see all those commas? So commas are used to separate these values within each header. That's what I was trying to explain. Comma separated values. Now somebody can say, no, I want to do a delimiter with a different way, in a different way, right? So then you will say, okay, in Excel, there's a field called text to column, right? And when you do delimiters, let me show you one view from Excel as well. You can actually, you can actually have different option there. And that's coming as another screenshot. See here, so you have different delimiters there, comma, semicolon, tab, space, and now you want to have other delimiter like 2//. Yeah, you want to put some underscore, double underscore, you can also do that, right? To represent your data. In SQL tables, data are always going to store by these delimiters, any of these. And to get the data correctly displayed in your Pandas table, you need to be very sure about what is the delimiter they are using. It's an information from the business. Okay, now let's see what is my working directory. So if you see working directory, I am sitting in 11th February, day 11. I think IIT Madras started on day 11. Okay, that's fine. That's the folder name. Now I want to see my all those files which I have put. Everybody should be able to do this. You can do os.list directory. It will list all the what does this function does? List all the files in the current working directory. So you can clearly see that I have IMDb there. Can you guys see that? Now guys, if you have put your files in the right working directory, you have to do this. And those who are getting this error, right, this OS error means definitely they have not done what? If you're getting this error, OS is not defined, you have to import first before you use it, right, Monica? So everybody should do import OS and then you can be. Guys, everybody is okay with the data. It should be in your folder, working folder. If it is there, let's do the first epic step. What you will do? You will say, let's get the data and please follow exactly the directory name. Sorry, exactly the data frame name. That is IMDb underscore movies. Don't do anything stupid there. Then you have to use pd.read. I'll go slow here. You have to name IMDb underscore movies. I'm also putting in the chat IMDb underscore movies. Everybody should store the data in the current working directory. That's very important for us to move on. So guys, what is about this data before I get into this data? So let's talk about IMDb data. So this data is having 1,000 most popular movies on IMDb in last 10 years. Okay. That is something very important. So it has 1,000 most popular movies in IMDb. IMDb, everybody must be knowing in last 10 years, how much, right? In last year's top 100 movies in terms of genre, title, description, directors, actors, what is the year movie got released, what is the run time, how many minutes movie runs, 2 hours, 30 minutes, like that. Votes, revenue, and Metascore, right? That's what I've gotten from the website. Okay, cool. It's not a data of mine. Now let's read the data. How will you read it? You will name the data frame as IMDb underscore movies. Exactly follow. Then you do pd.read. Just write read and do tab. Then you will see read from clipboard, CSV, Excel, Feather, FWF, GVQ, SDF, HTML, JSON. There are different ways to read the file. SAS files, SPSS file, SQL you can read, SQL query, SQL table, stata, everything. But trust me, you will only be needing most of the time, which is 98% CSV Excel. Let's focus on this in the basic. Okay. So what is the data format I have? CSV. I'll do CSV. Now, once I have this data with me, what I'll do, I'll need to give the file name. So you can do bracket under a double quote, and then you write IM. See, it is able to fetch because we are in the working directory. That's the powerful thing here. And then you can print IMDb movies and bingo. Wow. See, I think first, quickly, let me give you the data view. So to get the data view, what we will do, we'll just say, IMDb movies dot head. And let's say I say, if you just do head, it will, show you the first top or the top 5 rows. That's what head does. Okay, guys, you might have heard about it. Don't miss this parenthesis after that. Okay. So similarly, you have tails as well. So you can write dot tail. So if I can give you the quick notes, excuse me, dot head output the first 5 rows of your data frame by default, but you can also pass some numbers, right? 10 rows or 20 rows or 100 rows up to your choice, and you can put there within the parentheses. To get the last 5 rows, you have to do dot tail. Okay. So generally, when the data has a lot of column, what I prefer actually, let's say there are not a lot of columns, but let's say we have 20 columns or 30 columns, it cannot be able to see in one screen. And for that, what is suggested, let me show you. So first you do dot head, and you can look at third 3 top rows and do a transpose. Can you see that? Now this is very beautiful approach. So doesn't matter you have 60 columns or 100 columns, transpose will just put every column in the rows and the data will be in the columns. Can you see that, guys? Just to observe it carefully, you do that dot head, you have 3 data points, right? 3 rows, and if you do dot transpose, T capital, okay, transposing the data frame, okay, and can you see that? Now let's talk about a data bit. So first data point is rank 1, Guardians of the Galaxy. I think one of the top-notch movie ranked by the people. Genre is action, adventure, sci-fi. Description, you can read about descriptions of so many characters. That's why it is putting dot dot dot. Director is James Gunn. Actors Chris Pratt, Vin Diesel, and Bradley Cooper. These are some top actors. It was released in 2014. Runtime is 121 minutes, which means just 2 hours, 1 minute, I would say, right? Rating, IMDb rating, you must have seen a lot of rating. People go and give and to the movies on the IMDb website. Rating is 8.1. Votes, some 757K votes are there. And how much is the revenue there? $333 million. Wow, that's quite good. Metascore is 76. So Metascore is more like a weighted score that is coming from a pool of critics and everybody, right? So Meta, as high as the Metascore, that is going to decide the movie rank. Can you see that, guys? So basis the Metascore, you decide the, I think, rank of the movie. I can be wrong, but that's how that's what I remember. So there are some 10, 12 columns. We will see what are those columns, right? Similarly, somebody interested in doing top last 5 rows, you can do that. Good. Now let's put the heading getting info about the data. Okay. Getting info about the data. So first step, when you get your data, you always do this. Okay. I need to go about I need to get information about the data. So there is a function which we call it as what? Dot info, whatever the data frame. So df dot info, right? And I think this should be your first command. I always say that this should be the very first command should be the very first command you run after loading your data. Okay, does it make sense, guys? That's what I prefer to do. I need to understand what's this data. So what I'll do imdb movies.info. The moment you see that, right, the result of this function, can you see? Let's talk about it in little detail. So I'll go in Jamboard. It's important, that's why I'm going there. Okay, let me paste it here. Cool. Now everybody, can you see that it has given a very good snapshot of the data? Everybody please pay attention. Okay, very important. Can you see that how many records? 1000 entries starting from 0 to 999. Data frame, it's a data frame. Data columns, how many columns are there? Can you see for yourself? 12 columns. Now what is doing? It is taking one column one by one and talking about, this is going to be a very, very important thing. It talks about what? None null count. What is the meaning of none null count? Means how many rows are not null. Very, very important. Not null means not empty, right? There's no blank in the rows. So there are 1000 rows. Out of 1000 rows, all these guys are okay. 1000. Can you see that? 1000 title, genre is okay, description is given. All these guys are fully populated. So can I say that at least for these many columns, 100% data is available? Can I say that? Right, but these two column votes, sorry, revenue and meta score is missing for these records. So 872 is populated. So 1000 minus 872, how much is that? It is 128 records which are null. Possible, right? People are not reporting their $1 million collection, right? Might not have done good or not interested. Meta score is also how much? 1000 minus 936. How much is that? I think 64 records are null. We'll show you. Then it's talking about what? Data type. Can you see that? Data type. So data type is int, means integer. Rank, title, genre is object. All are object. Year is integer, makes sense. Runtime is integer, 20 minutes, 120 minutes. Rating can be 4.3, 5.8, 8.7. So float. Votes is integers. You have seen. Revenue can be also decimal places. So float. Meta score is also float. Then it's talking about different types of data types. It's more like a summary. So float, integer, object, right? And then memory usage. So this file is taking 94 KB in the memory. Now let's talk about shape of the data. Now it's a 2D data. So see, rows by columns, more like a matrix there. So there are 100,000 records, excuse me, so 1000 rows and 12 columns. Then we can also do basic stats, which are your 5 number summary, mean, max, count, standard deviation, first quantile, second quantile, right? All those things are there. First quartile, second quartile, third quartile. So this gives you, generates basic statistics or generate descriptive statistics. Descriptive statistics. Now, guys, describe, you have to do this parenthesis. Don't miss it. You want to read about this? Okay, you can go into documentation. Can you see that? So it generate the descriptive statistics, and what are the statistics you can see. But the good way to learn about it, just print it. Now, if you see that it has taken only the columns which are numeric, because it can't do anything of the categorical one, right? At least by default. I'll show you other way around. So rank, you can see, right, what is the mean, standard deviation. Doesn't make sense looking at rank, but year, you can definitely makes a lot of sense when you look at the average. So most of the movies were released in the period of 2012 or 13 or 11, right? That's what average is telling. A lot of movies were released in 2012 time. Runtime, average runtime of the movies makes sense. A lot of meaningful information you can draw. So average is what? 113 means 7 minutes lesser than the 2 hours of time frame. The Hollywood movies, right? It will not go for 360 minutes, or 360 minutes too bad, too big. Like I meant 180 minutes, 3 hours and so. Then you can also see that max is 191, which makes it at what? More than 3 hours. Must be some, James Cameron movie, right? Minimum is what? 66 minutes. I don't know what is this movie is, but you can find it out. Rating, max rating is what? I think somewhere 9. Yes, IMDb rating 9. Average rating is what? Top 1000 movies. Average rating is 6.7. Then you can look at the votes, millions, and meta scores. So average revenue done by movies is 82 million. Max is what? Max is 936 million. Almost $1 billion they might have got, and meta score is 100. Now let's identify those missing values, right? So put the heading missing values, identification, and treatment. So I'm taking a data to understand what are the data which is having missing value. So if you do IMDb movies and you find is null, right, you can do that. Then it will give you all the data with a Boolean return. You know that, right? So what it does, it returns a Boolean flag for every data point in each column and in each rows, which basically I mean each cell. So it shows whether there is a missing value or not. Wherever it is true, it's a missing values, but it's a very dirty way of showing the count or counting the number of missing values. And that's where I'll tell you my ninja technique to do it. What you can do, you can take all the Boolean flags, right? And you can do a sum of it. Just add a sum of it, and then the whole story will change. Look at this. Then what it does, it takes all the Boolean flags wherever it is 1. 1 means missing, right? 0 means what? Not missing. 1 means missing, 0 means not missing. Let me show you the flag. It's a Boolean flag. What is it? Somewhere must have written. Returns a Boolean same size object indicating if the values are NA. NA means missing, right? So if it is missing, it will show 1. If it is 1, if you sum it up, it will exactly, right? It will exactly tell you the number of records which are missing, right? Look at this. That's what we have also calculated here now. 128 and 64, right? And then you can also find percentage, right? Percentage by doing what? So 128 records are missing out of what? How many number of records? Guys, what is the length of this? Can you see that? And then what you do, what I do all the time, I'll multiply with 100. See, 12.8% revenue column revenue records are missing, 6.48% missing for the meta score. So that's how you calculate percentage of missing records in the data. Look at this, guys. Come on. That's what I do all the time in my data analysis. So they will ask, now looking at this 12.8%, right? There are different ways to, do the missing treatment, how to work with the missing data. Then people say that, okay, either you can get rid of rows or columns with nulls. That's one of the ways of doing it. Or what you can do with imputation, right? These are the two ways. Now, this is definitely not the course where we are doing EDA, but anyway, I'll give you some flavor of it. So most commonly, people do what? They'll say drop it. Drop the rows which are missing. Means 12.8 rows you want to show. You want to say that drop it. Doesn't make sense. Okay. Then people will say, okay, let's do one thing. You are not interested in dropping. Remember that location master, right? You remember that location master where we're saying let's drop the location which we don't have zip code. I took the very first example when we started this journey together, first class or second class, I remember. So there I gave you the location master, and some of the location master lat long was not there. So we decided, okay, can we drop it? And then I told you it's a big blunder. Not every time you drop it. So then people do what? Then people say impute it. Imputation means what? replacing the nulls with non-null values. Now there are different ways about it. I also share a very good material on it in the channel, in the Slack platform, so that you can go through it. Somebody should remind me in the next week, but I'll do share it. But we can't go into too much detail of it. But still, I'll tell you how to go about it. So what you can do, you can impute it. Generally, people say I'll impute it with the mean. But tell me, replacing revenue with the mean doesn't make sense, right? Or meta score with the mean doesn't make sense. So what we will do, we will say, okay, fine. We will say, okay, fine. For now, right, we have no option to replace it. So we have to drop. There in location master, we could not drop it. So we did something. Here we can drop because there's another option. No other option seems to be valid here, right? If we can go and reach out to this director, come on, dude, tell me how much money did you make? Then it makes sense, right? So that kind of replacement you have to do. Or you can also do like smart replacement. Like let's say if that director has made some movies, you can put the average of that director collection, right? But still Metascore, how will you justify? So here we are going to drop it. So how do you drop it? So right, we are going to, so I have discussed both the approaches. Now what is we have decided as a decision point? So what is the decision point, guys? Decision point we are taking that will drop it. Right, that's what I've decided. Okay, so remove it. How will you remove it? So there is a function called drop NA. So let's say IMDb movies and say non-null, only non-null values it will have. Or I'll say not null, then it makes sense. So what I'll do, I'll take IMDb movies and I'll say dot drop, see, drop NA, I'll say read about it, what it says. It says that on what axis, what you want to drop, remove the missing values. So drop NA removes the missing values. This operation will delete, right? By default, it will take what axis? Generally, what axis does it take by default? Axis 0 means rows. So operation will, let me write, operation will remove rows with at least a single null value in any of the columns. So what I'm saying here, guys, you have 12 columns. Even the data for this record, look at that. So even in the data, there are multiple columns. Even one column is null, empty, it will remove that record. Are you getting, guys? It will remove that record. So let me do this step. Follow through, guys, follow through. And now what I'll do, I'll again check that now what's happening there. So can I say is null dot sum? Again, I'll do it. What happened? Oh, sorry. Is NA dot sum? What is happening? Ah, okay, I got it. Parenthesis, parenthesis. Do you observe? There's no null now. Gone. Gone, right? Let's look at the info. I can check quickly. Now, only 838 entries. This data frame has 838 entries, right? All are non-null. Can you guys believe it? Hello? Right? Now, sometimes people do what? Sometimes people say that, no, I don't want to do it and store it in a new data frame. It's not memory efficient. Suddenly, sir, you are doing two data frame creation, right? IMDb movies, IMDb not null. So what you can do, you can say, I don't want to create a new data frame, but I still want to remove it. So what you can do, that's where a very common and world famous syntax comes in drop NA, and that in place. Might have heard somewhere in place true. What does it mean? It will affect the current data frame only, right? And it will store that thing. If you don't do this, then what will it will show you that you have dropped it, but again you will print it, it will start showing. So you want to permanently drop from the original data frame, you have to do in place true, in place equal to true. Now if I do this again, this is the old data frame, remember that is null dot sum. It's not only you can drop the rows, you can also drop the columns. And for that, what you have to do, you can also drop columns, the full columns with null values, only with the null values, not like dropping column. As like I want to drop a column, you can do it separately with a different syntax by setting axis equal to 1. I think most of the guys know this, but I just wanted to tell you.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
It affected the original data frame now. See, earlier when you did IMDb movies, let me go on the top. Earlier when you did IMDb movies, what happened? See, IMDb movies is null.sum. Did you see 128.64? But now when I'm doing the same syntax, do you see any 128.64? No, right? Right? So it will affect the original data frame. Data frame again. So you will see now if so what I've done, I'm not saying that I'll do all those things. So you will again go back to 128.64. Now somebody is telling, I want to fill, Monica is telling, I want to fill this with something, right? You go there, select drop NA, and you are saying that I want to fill all the NA values with something, right? So for that, you don't need to drop NA, you have to do what? Fill NA. Can you see that? And if you look at the syntax, you can put some value. So you want to fill NA with what? Some big number, 9999 in place equal to true. I'll show you. Done. Now you will see that because of this 99999, the data average will be a different average when you look at revenue and meta score. Can you see that average is really big, right? Or you can also print and see for yourself. I don't know, somewhere must have done it. So this is your 99999, guys. Can you see that? Okay, let me show you first null values, then you will be only able to understand. So let me show you here. See, can you see this is a missing data 995? Guys, everybody please pay attention. 995, row number 995, missing, right? Let's come to row number 995. What is it you are looking at? 9999. You want to change it to some number which you can recognize for yourself. You can also say that this is APC. That's also fine. Look at that. Can you see APC has come? My choice. Okay. I think that is good question, Monica. Suppose you want to fill any some default number there. You can do that. Okay. Now someone not in this data, but still, if you want to do imputation, you are interested in doing imputation, then what? So you can do imputation. Either you are doing to do imputation with mean or median of that column. So what I'm saying, let's look at the missing values in the column revenue, right? And then find mean of this column. So what I'll do, I'll say revenue, my column, and I'll take IMDb movies. I'll take revenue. So you have to just do revenue. That way you can slice the column. You can also print, right? This is your revenue column. Can you see that? Now it has some missing values, guys. Can you see that? So what you have learned in this syntax, using square brackets to select a column, or you can also select multiple columns, okay, in a data frame. I'll show you. So this is one column. I can also select some other columns. So it will be what? Let's say I want to select meta score, right? Then sometimes people say, what are the columns? I don't remember. So then I'll teach you quickly this different syntax, which will just tell you all the columns name. And for that, you have to do dot columns. Can you see that? What it does, guys, please don't worry. These things you will learn over the time, shows all the columns in the data frame. And it's very, very important you do this sometime. Now I'm only interested in meta score. I'll go and copy this. See how I'm doing it. right? And now I'll print it, see. Okay. Definitely I made a mistake there. Revenue millions using square bracket to select the columns. Okay. I think it did not fetch it. Do I need to do this? No, I am missing something there else. This works. This is a series. Meta. There must be some error. Let me take rank. Then I'll know that did I miss any syntax there. I think so. Let me give it a thought. I think I need more square brackets. That's what I'm going to test now. Yes, it works. Okay, guys, can you see that? So for one column, you have to use one square bracket. For more than one column, you are supposed to use, you can use double square bracket. Can you guys see that? Since when you're doing one square bracket, it's a series. When you're doing two square brackets, and now you need more than one column, you need to find a data frame subset. And for data frame, you are going to use 2 dimension, right? One square bracket, like take it like 1 dimension, two square bracket like 2 dimension, right? So there are different ways to it, but this is going to be very helpful. Okay. So now we can also, so I was interested in Metascore, right? So now let me show you that, right? Metascore. Now what I was telling that I'm interested in, replacing the revenue of the, millions, right? Millions revenue with the mean. And for that, I'll calculate focus rev min, and I can do rev dot mean. Okay. And that will give me one number. And can you see that? It is okay. For both of them, it has given because I have taken both the columns, but I'm not interested. So what I'll do, I'll just, comment it. But I'll be keeping in the notebook so that you can always play around. I need to run this, right? Only one number. Everybody is able to get 82.95. Now what I'm gonna do, I'll take rev, which is my data frame, right? I'll fill NA, and you can say in place equal to true, right? So what you're doing, you are replacing null values, please pay attention, in revenue column with the mean of it. And again, if you go and find that, is there any null now? You see no. How to get the mean value? Can you see that? This is the syntax that gets you the mean value. Mean, I've just thought about it. Get the mean value. I think 1 hour back. So then somebody say, what is this rev you are taking? So guys, type of rev. It's not a pandas data frame, it's a series. Right? But since it's a series, you already know about it. Okay. It is more than one column, pandas data frame. Now, guys, I'll talk about sometime. I mentioned, right, that describe function. If I do describe function, focus, I get what? Or let me do this. If I do imdo.movies.info first, right? Now, do you notice now what happened now? Because you took a series from the data frame, which is your revenue million, and you have filled with the mean of it. You don't see any null values there, guys. Did you notice? And a lot of people say, what you have done, sir? You have taken a revenue, but this revenue is what? This is a series from the data frame. It is still connected by heart. And you are doing anything on this rev. You are replacing rev with what? Can you see that? Replacing rev with the mean of the revenue. So now look at the final data, which is our original IMDb movies. It is having a revenue filled with the mean values, no null values. Now I told you that if you do describe, I move on to the statistics part. I mentioned, right, that it will only show you the statistics like count, mean, standard deviation, everything. only for the numeric columns, right? Like whether it is float or integers or anything. But if you are interested in, right, in some categorical variable like genre, you can also do that. So you can select this column by single slicer and you can say describe. It will also describe. Now what it describes when you do a categorical variable here, it describes the count of rows. So there are 1,000 rows for this genre. How many are unique there? 207 unique count of categories. Top category is what? It is action, adventure, sci-fi, and I think it's correct, right? Out of 1,000 movies, which one is the top watched genre? It is action, adventure, sci-fi. And how many times these movies have been released out of 1,000 movies? 50. So there are 50 movies which are in this genre, right? There are 50 movies which are in this genre, right? Out of 207 unique genres, right? Look at this beautiful information it gives. So let me give you the notes here. So describes can be used on a categorical variable, you know that. And what does this tells us? I'll show you. It tells it about there are 207 unique values. The top value is action adventure sci-fi, which shows 50 times. That's exactly I've just mentioned. Then somebody will say, can you just prove it? So that's what I've written. Value underscore counts is another function which helps you to do that. And if I do IMDb movies and I take genre and I do this value underscore counts, and what does this function do? What does this function do? It shows you the frequency of all categories in a categorical variable. Okay. Okay, so let me show you. There are a lot of it. But can you see that? How many unique are there? 207. So that's why you have 207 genre, combination of different, right? Action with adventure, action with drama or something like that. And then you have action, adventure, sci-fi coming as the topmost frequency. Can you guys see that? It's more like a categorical histogram. Think like that. Come on. Now I'll talk about data frame slicing, selecting, extracting. If you want to do an extraction, the first approach is people do by column, right? So how will you do by column? So it's very easy to extract using, you have already seen it, to extract a column using single square brackets. Okay, single square bracket. So how can you do it? It's very simple. You can do, you have seen it, IMDb movies, and you can say genre. You have seen me doing it, and let me show you. But the moment you do one square bracket implies what? Implies series. Remember that, guys? You can say APC, name it, and you can print type of it, and then you can see for yourself. Pandas code.series.series. Now, if you want to extract the same column as a data frame, use what? Double square brackets. You don't need to write, just focus. To do that, what you have to do, my dear friend, you have to use double square brackets. And let me show you again. I'll say APCD. You will see that. So use double square bracket. I'm doing nothing. I'm just putting a double square bracket. See, what is it? It's a data frame. Okay, now you want to include different columns, right? So what you can do, you want to just include the important columns of your interest. So let's say I will do IMDb movies underscore sub. It's a subset data frame. And I just want to do only few of the columns. So how will you do it? You will take genre, right? Then you want what? Rating is important. So I'll take rating. That's to clean your data. And then revenue millions has a lot of space. So I'll doing very smart here. I'll say, give me the column names. And I know that revenue millions has spaces and all issue. So I will be not doing any mistake. I'll just copy this. I'll place it here. Can you see that, guys? And you will say only these columns I am interested in. Okay, maybe I am interested in Metascore as well. Let's do that. See, only four columns I have picked up. So what is this step is doing? To subset your data frame and to exclude unnecessary columns which you don't need. So why you want to carry throughout the operations? It makes your operation computationally heavy. Is it clear, guys? Then in this also you can do all those things. What is the head? What is this? Every statistics you can play around. See, all those things you can do. You can find what is the shape of this subset of the data frame. You can say that it will be only, wow, how many columns? 4 columns, but all the records. So this is what you have done, column slicing. You can also do by row. So by row, you must have heard about 2 options. And what are those options, guys? Anybody had heard about it? By lock and iLock. Remember that? Lock locates by name. I means index. iLock locates by index, numerical index. So let me show you some magic here. Okay. So let's say I'm interested. Let me solve more like a question, this one, right? I'm interested. So let's say Mr. APC is interested in searching his favorite movie, and my favorite movie, all-time favorite, is The Dark Knight, in this IMDb database. Hello, that's the question, guys. I'm interested in searching IMDb database. The Dark Knight movie exists. Is it one of the movies in the rating or not? Right? That's the question. Now, how will search? So first of all, right? I need to search by lock because I want to search by name. Okay. Definitely, movie name is in the title. Can you guys see that? So I'll go there. I know that IMDb movies title is going to be the movie name, right? Everybody knows this basic. That's why you should know the data. These are the names of the movies, right? Guardians of the Galaxy, Suicide Squad, Step Up, dance movie. It's a dance movie. So I want to search my movie in this title column. So how will I do? I'll do IMDb movies dot lock, right? And I want to search each and every row. So I'll go there. I'll say IMDb movies and I say title, right? So what it will do, you need to understand, first I need to find the position of that movie, right? So if somebody is saying that I want to search, then you will understand. Not like this. Let me go to the syntax. I might be confused. So how we are searching? Group of rows or columns by labels or a Boolean array. Index. Okay, so by index we can search. So if I do this lock, okay, yeah, makes sense. I think that is something I missed. You cannot put the data itself. So Suicide Squad at what position? At 4? See, guys. So if you know that lock position number 4, right? You can do this. Guys, can you see that? Are you able to get it? Suicide Squad movie. But do we know that whether the Dark Knight exists in the top 5 or top 100? We don't know that, right? So that's where need to think smartly. So in the IMDb movies, I know it should be somewhere in the title, but I'm not sure whether it is at what location. I don't know that location. Okay. So what I'll do, I'll use a syntax called string, right? Dot contains, see, dot contains. And I know that it can be dark, written in capital, small, and everything. So first I'll search for the code word, that my search string dark. And case I'm not sure whether it is capital or first letter capital and all, proper and all. So I'll say keep it false. Doesn't matter what is the case there. If I do that, I'll know that this is a Boolean return. Somewhere if it is existing, it will be true, right? Can you see that index? Excuse me, then it will be true. Now let's say this is your search criteria. Let's call it as search criteria. Okay, and print it. And now you might be interested in what is this string contains, from where it has come. Don't worry. You have to learn these functions from your experiments. You cannot remember and cram it like all the time you do it. So that's where you have to use this string contents. It has a lot of string function. If I can show you. So IMDb, let's say title. And if you do dot string dot, do C, it has case, cat, center, contains. You can do A, nothing, B, nothing, D, nothing, E. If you are searching a string, keep that in mind. If you think it is not, you are not able to remember it, just Google it. Okay, a string dot contains, it will show. Now guys, using this source criteria, what I'll do, I'll go IMDb movies. I'll put my source criteria, that Boolean flag. And if this movie exists in here, right? So this source criteria exactly, you can put this. It is similar to write this line of code. Let me show you. So you can write IMDb and you can just paste this one. Both are same, but coding in this way, it will take some time for you guys. Okay. One line of code. I don't think you should do it right away. Okay. So how did you search? You're searching with lock. Now you have to be very sure. If you do this, let's run. What has happened? It has taken all the dark movies it has shown. Even if you do this or you do this dot lock, hold on, right? It will show the same result, right? Either you do dot log or you just do it, it will show everything. It is more like doing a filter on the data on the rows. Guys, can you see that? Now it has taken all the dark song, darkness. See, even darkness is not the exact word we have put, but it contains dark, it will show dark. Amazing, right? Now you can see that my favorite movie stands in the position 54, rank number 54. So you can, once you know the index, you could have done this like this also, right? Dot ilock, and you can say index 54. Is it clear, guys? Everybody, is it clear? Let's say you know the exact name of the movie, you can also search. So how can you search? IMDb movies. You can go into IMDb movies again and put that criteria, title, and equal to within that. See, here it is. So what you are doing this is like filtering your data, filtering your rows or data, filtering your data, not columns, filtering your data as per the criteria. So in one line, I have also taught you how you can filter your data by using lock, using i.lock1. Okay, makes sense. Now you can also actually take different columns. So you can make a movie sub data frame using ilock, and that's where you will be using slicing, which you have seen in list as well. It is very similar. Dot ilock. This is what you will do it for slicing. See. So what is the meaning of it? It will do what? It will take first index 1 till the index 3. You know that, right? If you put 4, 4 is excluded. Can you guys see that? So it is just going to show you first 1, 2, 3. Index number 1, 2, 3. That's how index 1 to 4 means. You know the slicing thing or not, right? If you do this, it will show everything starting from beginning till the 4. Means 4 is excluded, it will show only 3, right? And you can also play around with it. Hold on. You want to show first 2 columns, title and genre, right? No rank. You want to show first 3 columns, see, rank, title, genre. But what is the meaning of this? Just you are putting a column. Column means what? You have seen it, right? Column means all the rows. I think you know these slicing techniques. I don't want to spend a lot of time on it. It's a very simple way of doing it, right? So what is the observation, guys, here? Slicing with dot ilog is similar to what you have done in the list. Please keep that in mind. It is similar to what you have done in list. Right? Now somebody says that I'll by mistake you put lock. You will get an error because index slicing only works with ilog. That is something you should always keep in mind. Did you notice? The moment I is gone, you cannot slice. Christopher Nolan, I want to filter. What is the question? I want to filter all the movies directed by Christopher Nolan. Do you understand what I'm doing, guys? There, I want to filter all the movies directed by Christopher Nolan in IMDb movies database. Guys, give it a shot before I do it. How will I do it? So, guys, it is going to be another search criteria. So let's say filter Nolan, right? Chris. So I want to filter Chris. How will I filter it? You know the game, right? First, you'll do what? I'll go into IMDb movies. Yes, we can talk, Arun. And then you will say director. And then you will say equal to what? Put it Christopher Nolan. So you have to be very careful with the spelling. There should not be any spacing issue or anything like that. Else you will not be able to find, because this is case sensitive, space sensitive, everything. So if I do this, if I run it, definitely if you print it, it will be a Boolean return. Can you see that? True, false, true, false. So to filter Christopher Nolan movies, what I'll do, I'll go to the IMDb data, right? I'll say filter Chris, right? Can you say filter Chris? And because of this Boolean thing, it will only show the data for Mr. Christopher Nolan movies. How many movies he is able to get into top 1000 rank? These are 5 movies. Interstellar, amazing movies you must have seen. The Dark Knight, The Prestige, it is based on magic. Inception, Dream Within the Dream, Dark Knight Rises. These are the top 5 movies Christopher Nolan, directed it, and they are in the top 1000. Wow. The most. Now, if you look at this, if I ask you another question on the top of this question, but before I do that, are you able to follow it? Guys, come on. Everybody, do you follow this? Now, I'm not interested in a Christopher Nolan movies, which was, which were directed by him in the year or before 2010. So I want to filter all the movies that are this and released after 2010. Now you will do this question. So I'm just putting one more condition that I want the movies directed by Christopher Nolan and they were released after 2010, after the year 2010. How will I do it? So starting point will be the search criteria. You can say filter Krish 2010 or after 2010. You can name the search criteria in any way. Now how will you fill this one? Let me give it a. So this is your concept is using logical operators. Already you know it, so I will not be teaching what is logical operators. You know that and or everything. So how will you do it? Just to give you a start, you will take this series, which is true or false, because I'm interested in this director. So I'll say this director, and it is and. Can you see that? And released. So you'll do and. Can you see that? And you will do an and with the other Boolean returns, which is true and false. But now you will say year, and you will say it's not a string, it's a numeric integer. You will say 2000, not after 2010. So you have to do greater than 2010. So this is after 2010. And now I'll take this criteria and I'll go into IMDb movies. I'll say filter Krish after 2010. And you will say, wow, this is amazing, sir. See? And did I make a mistake there? Not this and will work. Sorry. So here, if you write this and, it has a different meaning. You have to do this and, then it will work. Okay. If you want to do like this and, you have to do this. And if you have to do or, you have to do this vertical danda. Can you see that? That's how you have to do conditional logical operators. So let me write. So and is what? Else it will be tough. You have to use this. Yes, this is very, very important thing I missed. And how do you use or? These are the ones we will do. It will be this pipe. I hope. Good. You'll get it. Okay.
Let's have a quick quiz question, guys. And the question is, which of the following functions can be used to calculate correlation between two variables in Pandas data frame? And your options are mean, sum, cor, or std. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
And these syntaxes or these approaches you can always keep in mind when you practice. Just like quickly I realized, right? I made a mistake. See, after 2010. Can you see that, guys? Wow. So now you have Christopher Nolan director. See, 2014, 2012 it's showing. Now you might be interested that what if I do or? What do you do or? Or means what? It will show all the movies of Christopher Nolan, or it will release any movie, any director in 2010. Let me show you. See, such a big list, by the way, 743. See, that's what the meaning of or. It will show all the movies of Nolan, and it will show all the movies which were released in 2010 and sorry, after 2010. So what is the output here? You will write, it is for the first above, in the above line, we have published, or we have shown all the movies of Christopher Nolan released after 2010. Okay, after the year 2010. That's what you got here, right? And now I'll make it bold, so that it stands out in the notes. Very, very important thing we are doing, guys. Now what you are showing here in the above, what you're showing, we have shown all the movies of Christopher Nolan, right, which got released after 2010. Does it make sense, guys? Very, very important. Yes, another question. Show all the movies from 2005 to 2010 having rating greater or equal, greater than or equal to 7.5, and these movies are directed by either Christopher Nolan or Ridley Scott. It's the same data, same notebook, right? I am just going to make a copy of it. And whenever you make a copy, you need to import the libraries again. So I'll just rename it to what? It will be, what is the date? 19th March. And it will be part 2. Right, guys? And whenever you do that, remember that what you do, import pandas as PD, import Numpy as NP, import OS, and run it. Now, guys, if I have to give you some hint here, so guys, what are the criteria that you have to keep in mind? So to give you some hint, criteria 1 is what? Year, movies released year. Criteria 2 is what? Director. Criteria 3 is what? Ratings. Okay. So guys, these are your criteria. Okay. Break it into different pieces, So remember that you have director is more like or condition. Year is like your, 2005 to 10. So it is going to be and condition. and rating needs to be and, because your rating needs to be equal more than or equal to 7.5, right? I think it should be easy. Rating should be greater than or equal to. So rating will be what? Greater than equal to 7.5, but it is an and, it's a must condition. Only condition which is your optional is director. Either you can pick Christopher Nolan or Ridley Scott. Okay. Just like here we had done, right? Or condition. This is or. Okay. So let me create the background for it. Okay. So in the meantime, you can build on the top of it. So guys, let me give you criteria one. Let's say filter one is what? Year filter. So IMDb movies, not this. Okay, I need to run this data set. I need to go back on the top. Where I'm running here it is, yeah. Yeah, now I'll do filter one. I'll just write filt one. Okay, filt underscore one. Now you will do IMDb movies, yeah. Then we'll do year. Please pay attention. When I say greater than, between 2005 to 2010 means greater than equal to 2005, and whenever you do and, you need to add parenthesis. That's the best practice. Okay, and you can just copy this bit. Everybody please pay attention. I gave you time to code, and you want between 2005 to 2010. So what you will do, you will see less than equal to 2010. Let me talk about filter 2. What is the filter 2? Rating, right? Rating greater than equal to 7.5. That's what I mentioned. Let me show you. Is it coming? Okay. Now filter 3. What is it? Either of these two directors. So director, I think we have already encoded now on the top. Use it now. Here it is. So take this part of the code. Be smart and paste it here. This is one of the directors. Now I'm saying any of these two directors. So I'll do pipe, right? And I'll say, what is this? Ridley. But we don't know is spelling of Ridley is correct or not. I can make mistake. So what I'll do, I'll try to find IMDb movies, director. First, I'll do a manual search that Ridley Scott is written exactly the way we think, and it seems we are right. Okay. So what we will do, this is okay, fine. So what we will do, guys, we'll say this is what Ridley Scott means, this one. And this is something you will comment. This is just to test whether it is working fine or not. Guys, if I print filter 3, it will also show a Boolean return. Guys, come on. 3 criteria, 3 filters, right? Now you want what in and. So overall filter is what? So final filter is what? You want a and relation between these two filters. Okay. Right? So guys, don't forget filter 2 is your rating filter. You want both these to be and. It's more like I need this and this. But director is what? Christopher Nolan or Ridley Scott. But that is also and now for you. You need either Christopher Nolan or Ridley Scott. So you will do this. Filter 3. Can you guys see that? Always print and see for yourself. Now this is your final Boolean output. Are you guys seeing it? Then you might say, sir, you are doing and. What about this guy? Christopher Nolan or Ridley Scott? Guys, it is already been taken here, right? Or. So what will happen if I do this? If I do IMDb movies and I'll say my final filter, you will see something is happening magically. Something happening magically. Look at this. Christopher Nolan, all movie between 2005 to 10. Can you see anything beyond 2010 or before 2005? What is the rating? All rating are more than 7.5. Everybody should get only 4 records. Are you guys there with me? Come on. It's a complicated search, but your life is just, this is what we call as, conditional slicing. Conditional slicing. You're putting some condition filter. Then you might be wondering, You might be thinking, can't I do in one line? You can do it with practice. How will I do it? Look at this. I'll tell you the other way. So I'll say IMDb, movie sub, and I'll say IMDb movies, right? And I'll say director. I think this is also going to be the same approach. Guys, the other way to do it, IMDb movies, you don't want to write a final filter, you could have saved some steps. So you can say filter 1. You can just write one after the other. Filter 2. Can you see that in the square braces? It will return the same result. Can you guys see that? You are applying one after the all the condition in sequence, and it is working fine. And you can write in any sequence, by the way. So you can start with, filter 2. You can say filter 1. Still your output will be same. Guys, hello. Now, guys, let me talk about a new function, which we call it as what? Applying functions. Applying functions. Sometimes it's important to create a flag, right? Let's say I want to create a flag on the basis of movie rating, on the basis of movie ratings, that let's say if your movie rating is less than equal to 5, movie is bad. Greater than 5 and less than 6.5, movie is average, right? So whenever you're trying to create some flag in the data, which will be needing to do all the time, you need something to create that flag fast, very fast, right? So you might have millions of records in the data frame. And if you think that you can run a for loop through millions of records and try to take each of the rows there and say whether the movie rating, on the basis of the rating, movie is bad, average, good, right? It is going to be very time consuming. So an efficient way to do the same thing is what? Apply function. Okay, that's what I put in the notes. So an efficient alternative is to use apply function to the data set. So let me take a question again, another question, guys, which I've written for you guys. Not question 3. Let's call question. Can you see this question, guys, on the screen? So what I'm saying that give me a movie rating flag. So I need you to generate this column, a new column in the data, highlighting bad when the rating is less than equal to 5, average when the rating is between 5 and 6.5, equal, taking equal to 6.5. When the rating is between 6.5 and 8, we say good, and anything more than 8 is fantabulous movie. Guys, are you able to follow it? So now there are multiple ways to do this, right? There are multiple ways to do this. But one of the simple ways to use apply function. So what we will do, we will create a function called, you can call this function as any function, rating flag of X. Okay. And then you write about it. If X is greater than 8.0, colon, return the movie name as what? Fantabulous. See, I'm creating a function, guys. You have already seen, right, how to create a function. I have taught about it. Else if the movie rating is greater than equal to, no, greater than 6.5, not equal to. It is what? Movie is good. Guys, can you see that? How I'm using, if else if, right? Then else if the movie is greater than 5, you return what? Else if X is greater than 5, you say movie is what? Average. So return average movie rating, else return bad. See, this function is working fine. Guys, are you clear with this simple function which I've created there? Now, what is apply do? So apply will take this function, apply to the whole data frame. Simple. But let's take this function and test it. Let's say I say rating is 9, fantabulous. Okay, rating is 3, bad. Rating is 6, average. Rating is 7, good. Can you say it's working? Now what I'll do, I'll create a new column in the IMDb movies data frame. I'll say movie rating flag. Okay, that's my new column. You can name it anything. And then what I'll do, I'll go into IMDb movies. I'll take column rating, right? And apply this function which I've created. Can you see that? Apply dot apply. And what is the function name? Function name is rating flag, right? You will write rating flag. Can you guys see that? It is as simple as that. Apply is one of the very cool feature in Pandas. Now what it will do in the back of it, what is gonna do, right? So it will take all the rating, right? Take one by one rating and plug in into this guy, right? So it will fetch one rating at a time and just pass it through this function, and basis that it will create a flag call whether it is fantabulous and stored in a new column. Now let me run it, and then I can show you this data once more time. Can you see that this movie rating is 8.1 fantabulous, this movie rating is 7 good, and this movie rating is also 7.3, it's good. Clear? Easy P. So what it has done, guys, if I can give you a one liner on this from the notes, please read about it. Apply method passes every value in the rating column, which I've just explained, through the rating flag function, then returns a new series. This series is then assigned to a new column called movie rating flag. Okay. So what I've done, I have taken this data frame, which is IMDb movies, and I have created a new flag. Can you guys see that? I have created this new flag. So you can put anything on the left side as a new column name, and this is your flag. On the right side, what I'm doing, I'm assigning this column with what? I'm assigning this new column, which would have been an empty column, with what? I'm assigning with what? Rating data taking. So I'm taking rating data from the column rating and applying this function. So just like how I have done, if I put here rating underscore flag, what is the first rating in the first row? What is it, guys? 8.1. So this function will do what? It will calculate what is the rating 8.1, right? And it will return some value there as per this function, guys. Come on. So what apply is doing, applying this rating underscore flag function on the column rating. So rating column is already existing. You're taking this column by this line of code, and then you're dot applying the function of your choice. This is your function. Now, what is the purpose of this function? It will take each and every rating value in the data, which is existing in the column rating, and then apply to this function, and then this function return a final output. So for example, I have taken this row number 0, first row 8.1. What is the rating of 8.1, guys? What is it? Come on, you tell me. Fantabulous. So what it does now, it will take this function, apply to the first row fantabulous, store it fantabulous here. Can you see that? Second, it will pick now 7.0, it will say good. 7.3, it will say good. Are you getting now? So ask about lambda function. So now let's talk about, right? Lambda function is not part of your basic Python or Pandas. It's advanced method. Not everybody generally understand it. So it's a very similar thing. I think if you remember, I had talked about lambda function earlier, right? So I have taught, right, guys, you lambda function when I was teaching functions. So what we can do, let me create another column. It's very simple here, nothing rocket science there. But syntax wise, you might feel a bit. So a little off. So movies rating flag, and I'll call it as what? Lambda, because you're using lambda function. So this is a new column which I'm creating. Same story, IMDb movies, I'll take ratings. Now, what Mohit is suggesting can be not use generalized function and directly apply using lambda function. So if you remember, right, in function, I talked about two types of function. So one is your, define function def, and then you can use lambda, which is your shorthand notation. So shorthand notation means generally don't write this long. It's more syntax free, right? Indentation free. So you can just write in one line. And to start, what you have to write lambda, okay? And then you have to give some variable of your interest. And let's say the first category is fantabulous, okay? And then you have to put a criteria if x is greater than 8. So you have to just keep writing if else it is good, okay? And then again, else good when, then condition if x is greater than, what was that, 6.5? Yes, 6.5. Else, no comma, nothing, no colon. Else it will be what? Average. If, again, average when? If x is greater than 5. That's what we put as the criteria, guys. Let me take a look. Yeah. And then what is it? Else it will be bad, the last line. What do you guys think? Will it work? Yes, it will work. Now, this is the same thing. Now I'll show you again 3 rows, top rows and transpose. Can you see that? It's the same answer. Fantabulous, good. Okay. It's nothing. It's just if else. Don't use else if. Else if I have never seen it. I don't think it's part of the syntax. It cannot use elif. When I say else if means elif. It cannot write like this. No way. Okay. So you have to write nested if else. It is nested if else in Lambda. Now, guys, today I'm going to talk about a very interesting topic. It is what? Pandas merge. So for that, I need to create a. So can you guys see there are 2 tables? One is, df underscore student. The other one is df underscore student underscore info. So the left table, and let me take my writing pad. Now, guys, if you see here, the first table is what? It is only having student ID, which is 1, 2, 3, 4, and name of the student, Akash, Varun, Kavita, and Nitish. Guys, can you see that? Then you have another table. So this is your table number 1, and this is your table number 2, and you have student ID 1, 2, 3, 4, 5, 6, 7. It's a big information, right? Age, sex. So it's more be like a historical master table, right? More like your item master. And this is your current student data. Now, what you have to do later on, you will see that I want you to join these 2 tables to fetch age and sex of the student. Basis, what is the primary key here? Primary key, what do you guys think? You guys have done SQL. Come on. What is the primary key going to be here? Student ID. So you might be thinking why you are not taking a big data there. First, let's understand the concept, right? You can handle this in the smaller data set. Anything you can do. Okay. So to create this data, guys, I'm using, so first one is df underscore student. Can you see that? Exactly the data which I had shown, I'm creating it. And here it is. Okay, so let's talk about the pd.merge. Can you see that? Let's understand the syntax first. So guys, if you focus on the pd.merge syntax, then you will be able to handle it very nicely. This is going to be very, very important. Not everything is in this important. Okay, but I wanted to talk about it. Okay, guys, so now let's talk about it. pd.merge. So here you can put any data frame. Then what is left and right, guys? So left and right your data frames. So you can put left as table 1, T1, right you can put table 2, or you can do vice versa. Okay. Okay. Now what? How? How means what? How means how? How means how do you want to join? Now there are a lot of ways of joining, right? So it can be left join, options in this. It can be right join. You have studied SQL. You should not be facing this any difficulty. Outer join, and you can join inner join. Right? Clear? By default, it is always what? You don't put how. By default, it is what? Join, inner join. Okay. This is the most important parameter there. Okay. And it's always string. Can you guys see that? It is string. You need to put into double quote or single quote. Then on, by default, it is none. So let's say you have a same column ID. The key, I'm talking about so you have 2 tables, table 1, table 2. If you have the same primary key header, it will by default join. But let's say you have a different primary key header name. So for example, if I go there in this, let's say I have a different primary key right? Here it is stu underscore id and there it is student id. These two headers are different. So then you cannot directly say on student underscore id. You have to do what? You have to tell. Then you join left on and you have a different column names. So you'll give that column table 1 column name and you'll give table 2 column name, your primary key. I think these are the important ones here. Let me show you with the example. And what I have just shown you, I am going to write. Okay, now you should be sorted there. Okay, perfect. Now guys, without any key column, you can also join. I'll show you. So first thing first, I'll show you is what? Without any key column, right? No primary key. How can you do that? Focus guys, pd.merge and use the first data frame df underscore student, comma df underscore student info. Now, since we know that, and Mohit will answer your question. Now we know that df underscore student, df underscore student info is having a common primary key header, right? Primary key has to be there, but name of the column is same. You can still join it. Can you see that? It has done the join. Now you know that there were 1, 2, 3, 4 student ID. So it has only fetched information for Akash, Kavita, Varun, Nitish, but it has not fetched anything for the column 5, 6, 7. Why? Because by default, it does what? Join. By default, it does what? Inner join. Don't forget that. Then I know some of the guys say, what is inner join? So let me also talk about this first. So those who are struggling with the SQL concept, please pay attention. I'm doing something for you. So guys, what is inner join, left join? Let's take a focus on this quickly. So guys, inner join means common to both the table 1 and 2. Left join, take everything from table 1. And if there is nothing present for table 1 rows in table 2, it will fill it with NaN. I'll show you. Means not a number, missing values, but still it will keep everything from left join, left table. Right join, similar, right table. So it will keep it intact every records from table number 2. If something is not present matching table 2 in table 1, it will just fill it with NaNs. And full outer join will be a full set of, produces all records, right? Whenever there is a match in either left or right data frame or everything. I'll show you one by one. Good. Now, what I did, the first join without any key column. So I'm not putting any column there. Okay. But you know that by default, it will does a inner join. And there is another way to do the same thing. You can say not pd.merge. You can start with your data frame itself and do dot merge. Can you see that? So I've started with df underscore dot merge. You can put another data frame within it, and you can also do this. It's as simple as that. So this is by default inner join as well. Are you guys seeing another way to do the same thing? Now the second thing will be specifying key columns argument on. See? So what I can do now, I always practice this pd.merge. So I don't do this data frame.merge. I start pd.merge. I'll say df student info, and then I'll say how. How will be what? Inner. So this is like telling everything exactly like, right? On what? On what is the column name? Stu underscore ID. See, it will also work. It will give you the same result. But here you have a control that how do you want to join and what is the column. And this is only going to work when you have common columns, common column headers name, right? In both the table, if you see in both the table, student underscore ID, stu underscore ID is the same column name. That's why it worked. Now, if I say something here that in this, I'll change this table a little bit. I'll say that now this column is this. Now, can I see that student underscore ID? I have made it. Now, if I want to run this, you will see an error, key error. And the error is what? Student ID is not matching. So what you will do to solve this? You will do what? Now, why this error happened? Because now there is no common column, right? So what you will do, will say, okay, forget about it. Since there are no columns, when you have different column headers name, I'll write it here. So you will use left on. No, don't change it. Don't change it. Why you want to change the data? Let's not do it. So what you can do, left on. So what is your left table? DF student. What is the left table ID? It is same, right? Stu ID. Stu ID. Hello? It's stu underscore ID. What is the right one? Come on. It is student underscore ID. Did you see, Sakshi? We have this option as well. Student underscore ID. Now, if I run this, you will see that it's working fine. Wow. Bingo, right? I have till now done inner join by default, right? Now, if I want to do something beyond it, means I want to do some other joins, so I need to tweak the data a bit. So what I'll do, guys, I'll take the same data, follow through, and I'll remove. Now, guys, what I'm going to do, I'm taking my name out of it. Okay. So now I'm starting student ID from 2, 3, 4, 5, 6, 7. You can clearly see that now Akash is not going to show up. So I was a student, now I have graduated myself, I have become, let's say, an engineer. So you will not see my ID. Now what will happen? Now the magic will happen. Now student ID 1 is missing in table 2, but it is present in table 1. Can you guys see that? Student ID 1 is missing in table 2, but present in table 1. So if I do a pd.merge, please pay attention, guys. If I do pd.merge df student this, and I'll just copy paste to save time. Let it be like this. How? And I'll want to do left join. Can you guys see that when I say left join student, student will Akash will be to there, but his detail will not be present in the database. So what will happen for table 2 information like age and sex? It will be NANs. Let me show you. Did you notice, guys? So my name is there because I'm joining from left, but other information like student ID, age, sex is not coming here, and that is expected. Okay. So what is left join does? All the records from the all the records from the left table. Similarly, if you want to do a right join, guys, please pay attention. Now, if you want to do a right join, now you have what? You have all the students starting from ID 2 to 7, guys. Can you see that? 2 to 7, but you don't have student 1. And you don't have, sorry, my bad. You have all the student ID from 2 to 7, but you have only information for 2, 3, 4. Right? You don't have any information for 5, 6, 7. What will happen? If I run and show you. So see, 2, 3, 4, you have informations. You can see Kavita, Varun, Nitish is coming. But 5, 6, 7, you are able to still keep the information from table 2. But what is not present in table 1, it will fill with NaN. Can you guys see that for yourself? Right? So all the records from the right data frame.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Okay, now the last bit and we are done. And what is it? All the records from the left and right, both the data frame, which is we call it as outer join. So I'll just say outer join and we are done. Now see, you have every information. You have Akash, Kavita, Varun from the left table. You have 4, 5, 6, 7 from the right table. Wherever which one is not available, you will just put NN, right? How to export DF to CSV or XLX? Let's do it. So you can take any of the data. You can say IMDb movies dot to right dot to CSV, and you can give some name IMDb movies exported dot CSV. So what is the syntax for that? Exporting is what? Two, and then you have a lot of options: CSV, Excel, all the other options. So export is starting with 2, and then you can do this. If I run it, exporting the data frame as CSV file, and you can also export as what? Some other file. And I'll show you from the screenshot that it worked. In my folder, can you see that? IMDb movies exported is a full file which has been generated. Now I was talking about concat. So please write the heading, guys. Pandas concat. Very, very important, huh? Pandas concat. So let's say you have, few more students who came in February. Oh, no, so March. This is March. And let's create the data frame of these new students. And you can do it by, by curly braces. And you can say stu underscore ID. So new student have come up. And let's say it is 1, 2, 3, 4. And name of the student is, no, I think we already has 4, right? So let's say 5, 6, 7, 8. That's right. And name of the student is what? 5, 6, 7. Just 3 students who have come. Name of the student is Ram, Monica. Just creating some fictitious data, okay? And Anand. Okay. See, some issue I have done. Comma. Yeah, these are the new student, guys. Can you see that for yourself? And df underscore student info is what? The old one, not this one. But that's fine. Let me pick the old one. Here it is. Excuse me, guys. Please run the code in sequence. You have 7 students. Now the database was not updated for the current batch. Now it has been updated. Now you have added 3 more student ID 5, 6, 7, right? Ram, Monica, Anand. Now this is one data frame, right? And the other one is what? If I can show you this. You already have the similar data structure. Can you see that? Column, there are 2 columns, student ID and name. So what will happen here if I do concat? So pd.concat is more like appending it one below the other. So if I do pd.concat, and if you see the syntax, guys, what it does, right? Axis by default, it will take axis, row by row, it will, combine it. Concatenate pandas objects along a particular axis. So now I want to concat what? Which one? So you have to give the 2 data frames. Please be mindful about the parenthesis and the square braces. And you want to concat DV student with what? DV student who joined in March, right, guys? Can you see that? And let's call it as, DF student updated. You have updated the data frame. So your database is updated now. And if I print it, look the magic. Now, can you see that you are able to append these 2 set of data frames, which is in similar structure? Now, one thing you might be observing that indexes are not looking nice, right? 0, 1, 2, 3, then again 0, 1, 2. So what you can do, you can always go and say index, ignore index equal to true. So now, while it is appending, it will not take the index of the original data frame, it will create its own index. So this is, you have appended around axis 0, but you could have done about the axis 1 as well. But you will notice that it doesn't make a lot of sense, right? So you are doing Akash, Kavita, Varun, you have taken 2, it's more like in Excel, you are putting first data frame in 2 columns, then the next data frame in the 2 columns. And just to maintain the standard shape of the data frame, you are filling the last row with the NaN for the second data frame. Can you see that? This is crap. We don't need it actually anywhere. Let's talk about aggregation. So pandas group by an aggregate function. It works on the principle of what? It works on the principle of SAC. What is SAC principle? So SAC is split, apply, combine. So I'll give an example. This is a very good figure. Thanks to our guys who are creating these nice images. Can you guys see that? Split, apply, combine. Principle is known as SAC. So suppose you have a data table, right? Can you see on the left, you have a data table, input table. You can definitely see that you have A happening how many times? 2 times. B happening how many times? 2 times. C happening how many times? 3 times. So if you focus on A, right? So what you will do first, you will split this data frame into 3 data frame at the background. See, so you have broken A and combine the data. So you will apply a combination. What is that apply function does? It's the same apply function, sum. So what it will do, it will sum these two guys. 1 plus 4 is 5, right? Hold on there. Now, next step. What you will do next step? You will take these two guys and split it. So again, you can see BB coming. What is the value there? 2 and 5. Sum. You will sum 7. Nobody will tell you this, but I'm doing it right away. When you do C, you will take this. Again, take the data frame, split it. See what are the values? 3 and 6. 3 and 6. Add. How much is that? 9. So split, apply. What is the last step in the aggregation? Combine. The moment you combine, you see a tiny summarized data frame which says A, B, C, and what is the sum value? 5, 7, 9. That's how does aggregation work. Somebody asks you this question in the interview, just explain with this baby example. No, it will do on the same thread. It's not parallel computing, okay? So don't think that what you are looking at here, Mohit, is some parallel processing happening. Don't get me wrong there. It is pandas, disaggregation, and then aggregation. Okay, so it is splitting it, then trying to group it by some apply function, and then give you back. Okay, clear? It's not doing any parallel code or thread things. Okay. When you have multiple keys, let's say your primary key is not only student ID, right? Your primary key is more than 2 columns or more than one column. So what you can do there, you can give left on, just telling you, sorry, I forgot. Left on, and then let's say you have 2 columns. You'll do what? Student underscore ID, and let's say you have another column, registration ID. So you will give 2 column in square braces. Can you see that, guys? As many as columns you can give as a part of primary key. Not necessarily primary key will be only 1 column, right? It can be concatenation of multiple columns. So you don't need to create a concatenated field. What you can do there, you can just put all the columns name in the sequence, right sequence on left, on the right. Okay, just keep that in mind. So now I'm going to move ahead with aggregation, guys. So for that, I'll use sample store data. Okay. So for that, I'll use df superstore. And since, guys, I had given you this data, can you see that? So this data is your superstore data. It's more like your store where you have Go and you have different it's more like a proper data where you have a store where you are selling your products, which have some categories, who is the manufacturer, how much you are selling in what region, what is the profit. It's a very good data. We're using this data for visualization as well. How much the discount, who is the customer, what is the category, subcategory, right? Subcategory here, what is the sales, what is the segment. You have a lot of things there, right? That's what superstore data is. It's a very good data for learning group by aggregation. Now I'll teach you the first aggregation, guys. Everybody is able to see this data in their system. So first aggregation is known as single aggregation. So what you have to do, you have to take this superstore data and you have to do group by. Now let's learn about, can you see that? So group by has a lot of things, sorting, what access, what group by what. So basically, whenever you do group by, right, you will do group by with something. So here I'll use category first. Right, I have category on the top, so I'll use this column, guys. I'll group by, and then I'll say which thing I want to group by. I want to group by sales. So I'll just put in square braces sales, and I'll use just to sum total sales in USD. Bingo. Look at this. This is a very simple example here. This is what single group by. But you can also do single is what? You are also only grouping by sales, right? So you're only grouping sales. But let's say, and guys, you need to understand this syntax. It's very easy. df underscore superstore dot group by, right? And then in parentheses, you put the name of the column, and then you just put the name of the columns which you want to sum, right? Simple. This is your single aggregation. But if I want to go from single to multiple aggregation, so I'll do this. So I'll just take this whole code block, and now I want to do group by what? Not only one series. So whenever you want to go from one series to data frame, you use two square braces. Don't forget that basic concept. Now I want to sum the sales as well as profit. What do you guys think? Remember that? So you can sum the sales, you can sum the profit in one line. That's what I'm calling it multiple aggregation. So whenever you are going from one dimension to more than one, right? It is two dimension data, right? Multiple columns are there. You will use square braces double. See? And you are not happy with this positioning, you can also do, I think it should work here. See? Reset index. Can you see now the data frame looks little neat? Can you see that? See, now you're resetting the index. Now it is coming as a column. So what is the sales in the furniture category? How much is the profit? What is the sales in office supplies? What is the profit? Right? Okay. Now multiple aggregation can be can be in a different way as well. Now let's say you want to find, this is like what? This is like finding total for two columns. That's why you're doing this. But it can be a possibility that I'm interested in finding, let me move on. And I'm interested in finding what? I'm interested in finding what is the sales, not only one line, that what is the total. I want what? I want total means sum. You can write sum. I also want, right, what is the minimum sale that happen in that category, right? Like statistics I'm doing, maximum. And also, I think this should be good. So I want min, I want median, sorry, I want minimum, I want average sales, and I want max, and then in the end, I want total sales. These are all, you can get it one line of code. Can you see that? So what you're doing for the one column, you are actually getting multiple aggregation levels. And then what you do, you can do reset underscore index. See, for the same category, you have minimum, mean, max, sum. But here it's very difficult to highlight that it is what your sales underscore min or sales underscore mean, sales underscore max, or sales underscore total. So first time you might be seeing I'm use a function called aggregation, right? Aggregation. Now I'll show you some more stuffs. Multi-aggregation, multiple named aggregation. So what is it? Named aggregation. You will understand when I do it. So now you, as I mentioned just right now, that I want to give name to it. I'm not happy with this, so I'll do aggregate. I'll just go into another line, and I want to say what is my average sales, right? Average sales. So I'll just write average sales equal to average sales of what? So I can say, and also just, this is the most widely used. Let me also write most widely used aggregation means 99% will be using this. So please learn it. So what you do, I'll just write again, df underscore superstore dot group by. Group by what? Group by what? Category. Okay. And then dot aggregate. Okay. And what is it? Average sales equal to, what is it? Average sales, you will take sales, right? So you will take sales and you want to do average. So what you will write? Mean. See here. Comma. Now what you want to do? Min sales. So you'll do what? Again, you will copy it. You will say sales min. Focus, guys. Then again, you will break it. You will say max underscore sales. So when you're writing max, min, right? Always use either no spacing or put underscore if you want to create that spacing. So again, sales. What I want to do? Min, average sales, maximum sales. And lastly, I wanted what? Total sales. So you're creating the column headers. Sales. Total means sum. And you know, right? I'll always do reset index so that my output looks neat and clean. Bingo. I'm putting this in the Slack. Because too much to type. This is what we call named aggregation. Can you hear me? Someone can quickly confirm. Yeah, okay. So now you can hear me. Now look at here. Look at here, guys. So you have this there, right? You can find sales. So you might be smart to think. Now I also want to find what? Right? I'm not interested in min. I'm interested in average sales and average profit. So you can start making change there. So you're interested in two measures in one go. So you just change it with profit. You do mean. You want to do total sales and total profit. See, I'm renaming it right away. Be careful. Sum will be total. Sum is total. Look at this. Same lines of code, but you can take two measures and still get different results. Did you notice that? So cool. So guys, you need to be careful that you give the right column name there, right column name. Then you might be interested. No, I'm not interested only by one category. I want to also have now group by I want to do with two categories. So I want to do first category. Then I want to give what? I want to put also subcategory. I'll show you. Same result, but I want for what? Category and subcategory. Where is subcategory? Here, right? Just copy this. Now you want to group by two level. Now only not one level. So see. And close the square braces. Can you see that? What did I miss? Average sales. Here. Bingo, right? Beautiful, guys. So now what it has done, it has taken a category and it has printed all the subcategory, average sales, average profit, total sales, total profit. Isn't it nice? And then you will observe, okay, when I was looking at overall profit, it looked furniture is positive, no loss, no loss, no loss. When I go into subcategory, I drill down further, I realize, oh my God, my bookcases are not selling at all. It's losses are there, right? Can you see that negative value there, guys? Anybody is able to observe? And then other negative is here, which is office supplies, right? Then one negative is here. What is that? Furniture, tables. So tables, bookcases, and office supplies are not happening good. These are the bottom lines for the business. Isn't it insightful, guys? Come on. Then you might be thinking, this is a tabular form. It would have been nice if somebody would have put it into a chart, right? A bar chart or something else where the profit, wherever the profit negative should be highlighted in the bar, right? That's where visualization will come into the picture. Okay, tabular is fine, but can I have a visualization for the same thing? And that's where the bar chart or the other charts will play a big role. Now, guys, I'll put multiple aggregation and multiple functions. That is also something widely used in reporting. So the same thing, what you can do, I'm interested in knowing the same thing which you have done, but in a different format altogether. In a different format altogether. So what they're trying to say that do the same thing, but in a different format, right? So what we will do, we'll say, this is another, it's more like another structure of the summary. And I'm only interested in category, right? I'm only interested in category, and I'll take two measures, sales. Measures means, numbers, numeric variables, profit, right? And then I'll take aggregate, and I'll take two functions. What are the two functions which I was doing? Mean, and what I was doing next? It was total, means sum, right? And when I print it, oh, something I missed it. What did I miss? Sales, profit, category. Okay, sorry, group by kaun likhega? Group by, right, guys? Can you see that? It's the same thing. It's the same thing, but a different structure. Sales means sum, profit means sum, right? Another way of reporting the data. But if you do reset underscore index, look at that. Ideally, it has done nothing, right? It's just that it has taken sales from the center. You can just run and you can see for yourself. So it has done actually nothing much, just brought it down, the spacing, which was actually helpful. Now I could have done the same thing for the category and subcategory, both. Let's see. So category, subcategory. Now I'll quickly talk about sorting a bit. So let's say this is my df underscore superstore aggregated data, right? So I can print, come on, right? I want to sort by highest profit. Can I do that? Sort values by what? By total profit. And you want to show first highest profits, you will do what? So you will do by equal to this, and you will see, I think it was, sometimes I forget the syntax, I'll go there. See, I'm very smart. Ascending need to be false. Okay. I don't want ascending, right? I want descending. See, guys, can you see that? Which one is the subcategory? Copiers. Copiers. Copiers is in technology that is selling the most. So this is what we are doing, sorting. Okay, sorting by total profit. So now, why do we need visualization? That is something anybody can ask you. So always start with this tagline. Might have heard this tagline. What is it? A picture is worth, or you can write, a picture is better than 1,000 words. It's a very famous line. You can Google it and get the right words for it. But it makes sense, right? And that's where we see, right? If I show you an image, and I think somebody just mentioned before the break. So thank you, sir, for sharing these cool images, right? It helps us to understand the concept better. Images are really helping us to get the concept easily, sir. Thank you. Look at that. I think already there. Okay. So picture is better than 1,000 words. So if someone, why do you need visualization? Visualization, without visualization, I think it's going to be really not a good idea to do that. Okay. So now there are a lot of visualization libraries, but our focus as per the syllabus is on Matplotlib. Okay. There are Altair is used for business visualization. So let's say you're working on some project. So generally client would prefer you to use, okay, somebody has done something with mine. So in my home, there are some kids, right? They keep writing on this. So this is for business plotting. So some of the companies or client will say use Altair only because we use Altair. Okay, but generally nobody uses that, trust me. ggplot2 is very good in R, so Python is also having ggplot now. But if you are well versed with code, language, R language, so you must have seen ggplot2, and plot2 is one of the biggest or famous libraries of visualization. I think for us, I think matplotlib is the starting one in basic Python, but I will also try to take, some of the visualizations coming from Seaborn. Very similar structure. Don't worry about it. And definitely, this is not part of the syllabus. Any of this, only the matplotlib is part of the syllabus. But plotly and other visualization you can learn on as you go further. So generally, plotly we use for interactive visualization, which is not actually expected. You can also do interactive visualization using some other libraries here, but Plotly is really good in interactive visualization, trust me. Okay. Seaborn is fast than Matplotlib. Does it make sense, guys? So these are the top libraries in visualization you see. And having said that, there are still a more number of visualization. But since let's say we are going to focus on Matplotlib, so Matplotlib is your, one of the popular Python library for data visualization. This notes will be shared with you, don't worry. And that is used to create 2D plots and graph. Okay. Now, how do we import this? So you have a PyPlot module in Matplotlib, just like MATLAB. So guys, let me give you the history, a bit of history here. So Matplotlib is actually inspired from MATLAB, trust me. And that's why in Matplotlib, there are two types of, two ways of plotting the graphs. One is MATLAB style. I should not type like this. I should write capital. MATLAB style of visualization, and one is object style of visualization. Object is something it is very familiar with us because Python is object-oriented programming, right? So MATLAB style is one people will start with MATLAB style because that's the starting point for the Matplotlib. Okay, then we have a lot of predefined function for plotting line plot or histogram or bar plot or different types of plot. Okay, let's not go too much into detail here because you might be thinking about API and all. So API is only needed if you are streaming the live data, like stock market data, and you are showing some trend chart of stock market like Yes Bank or SPI. So you need to flow the data in real time manner, right? And that's where if you want to show some plots using Matplotlib, there you have to give API keys. Okay, and that is also functional, so it's a good news. Because Matplotlib powers API-driven data charts as well. It is very easy to integrate it with Pandas and Numpy libraries, so that is good. Now, these are some basic functions in Matplotlib where you can start off with. So dot plot is for plotting an array of data onto a graph. Dot plot is very, very important function. Dot show is for showing the plotted graph as an output. Dot grid to show you grid behind the plot, right? So what is grid? This is grid. Then to set the title of the graph, you use dot set underscore title. Now, I think there are a lot of things I will be talking. I'm just seeing that what are the different types of plot. These are the different types of plot, which will be something we are focusing. And these are the important ones. Okay. Other things which I skipped, I'll directly take in my notes. So don't worry on that. Line plot, area plot, histogram, scatter plot, bar plot. Okay, so these are the plots. I think most of the time needed. Line is there, bar is scatter, histogram. I think one of the plots which I will all do as well is bubble chart. Okay, and box plot. Okay, scatter is going to be extended into bubble chart. Box plot is a separate plot altogether. Line plot, I think is there, histogram is there, bar, horizontal, vertical will be there. I think more or less this is, and pie chart, sorry, I missed the pie chart. So pie chart I also teach. And other that, if you're interested in knowing some other charts, just drop me a note on Slack. Sir, I am interested in violin plot, right? Violin plot. Violin plot you want to do, I can show you. But I think these are charts which you will use in business, any data analytics, and data manipulation. The spider chart, there are n number of charts. Let me show you first. Okay, then you will understand what I'm saying there. Okay, so let me show you all the charts. And sometime, so some of the guys might be interested in only doing visualization. So these are the three amazing websites you ever come across across the globe in terms of charting knowledge. Okay, so now let's start one by one. So this is a very good Python graph gallery. So good part is that all of these charts are coming through Python, and they're also giving all the options, matplotlib and seaborn. These are the two famous options. Sometimes they have also used plotly. Okay, now if you want to distribute, you want to show the distribution of the data, so that's where histograms comes as the first chart. Okay, when you want to show the distribution in the data, how the data is distributed, you will use histogram or box plot. These are the two popular charts from this box. Sometime when you are trying to do some of the, want to show some of the distribution of data more like for hypothesis testing, you want to go with the density plot. I'll also show you this. Is it clear, guys? Come on. Everybody is clear with these three charts: density, histogram, box plot. These are the three important charts, right? But what I'm giving you as a powerful resource to get better, and that is something is also a value add in the course. Okay, so I'll definitely talk about these plots. Now when you are trying to find relation between two variables, so then correlation, heat map, bubble chart, these are the ones you will use all the time. And when I say it, take it word by word. Since I come from top class consulting, niche consulting firm, right? It's one of the, so I work for Accenture Strategy and Consulting, right? So when I say take it word by word, take it for word by word, because I know what we are doing for last 10 years, right? And what is happening in current trends. Nobody's going to show me something 2D density. Nobody likes this. Everybody will either show me scatter plot or heat map, or show me bubble chart. Bubble chart is also very famous. So 1, 2, 3 charts you are going to see all the time when you want to find some relation there. You want to show some ranking, bar plot. Bar plot is one of the important charts there. I think bar plot does everything in ranking. Don't worry much on spider or some word cloud or lollipop. It looks very fancy, but nobody asks. Then if you want to show something like connection or the trees, right? So like category, subcategory, remember that? So how category is breaking into some category or then subcategory into something else, you will start with the pie chart. So what is the proportion of sales by each of the category? Pie chart. Whenever you want to show 100% breaking into different components, it is part of a whole. So you will show pie chart, or you will show tree map, or you will show donut. These are the famous ones. But when you're doing decision tree models and all, though, you will also see dendrogram there. Okay, the rest you can ignore. Is it clear? Evaluation, you want to show something happening month over month, or you want to show what is the sales trend, projections, forecast, you will use line chart or area chart. Simple. You want to show something geographically, regional, right? In India, where the COVID cases are high, in which states and all. So map chart comes, right? You want to show something, more like a supply chain shipment from source to destination, from city to, right? Starting city to destination city. What is the lane they're using? You'll do connection, right? So generally people use map or connection chart, which we are not covering. Then you can also show flow. That's fine. You can show network in the flow, right? So these are the famous charts which I have shown here. Now the second one is very important. If you want to explore this, look at this, is more like a categorization of it, right? This is another beautiful website, guys. So if you have one number, one column, what you can show. You have two numeric variables, what you can show. You have three numeric variables, what you can show, right? And categorical, order, non-order. So look at this. This is like giving a full encyclopedia of what you want to show, but what charts. Suppose categorical, you want to show bar, you can go and read about it. It doesn't tell you, right? And then you can go into Python gallery, right? And then it goes back to, right? You can see it goes back to here. It's the same one. So if you go back, it's the same thing. Both are connected. They are brothers. They are starting from explore. You want to show connected scatter plot. See common mistake, right? Amazing resource, right? See here. Now, don't tell me, guys, you were aware of these two websites. Don't tell me this, please. If anybody is aware, I mean, hats off to you. You're like so informed. Anybody ever seen these websites? Anybody? Be honest with me, huh, please. Because itself, for me itself, it took a lot of time. So that's also my job, right? When you're talking to me in this session, definitely I'll teach what I'm supposed to teach as part of the syllabus. But see, visualization, I cannot do 100%. When I say 100%, it doesn't mean that I'll not cover the syllabus. I'll go beyond the syllabus. But you understand, right? There are thousands of charts, different flavor, a lot of things to discuss. I can teach, 6 month visualization only. But that's where I'm telling you guys that these two websites can help you to grow fast in the charts. And I'll also share a book called Storytelling with Data. It's a very famous book. Some of the guys must have seen it earlier. Storytelling with the Data. Have you ever heard about this book? Definitely some of the guys must have heard about this book. Storytelling with the Data, written by Cole, Mr. Cole. It's one of the amazing book which I'm going to give you right away in the Slack. Please open that book and you will thank me 10,000 times later when you read this book. That's also my job, right? That's also my job to make you familiar with this some amazing resources, which is just 2 or 3 resources and you will get better. So that's getting uploaded in the Slack group. Please take care of it. And done.
Let's have a quick quiz question, guys. And the question is, which of the following NumPy functions can be used to reshape an array? And your options are transpose, flatten, resize, or reshape. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So let's see matplotlib. So Python matplotlib already I've introduced, so let's not get into too much detail of it, but definitely have to load some necessary libraries. So let's do it, guys. So what are those libraries? So one is import Numpy as NP, import Pandas as PD, import OS, and then import matplotlib, and you have to do pyplot alias plt. In case you don't have matplotlib, you have to install it using pip install. Now let me show you. You can also check your matplotlib version. So how can you do? You can do matplotlib, and for that you have to import matplotlib as well. Can you see that? Matplotlib dot double underscore version double underscore. Can you guys see that? So I'm using 3.3.4. In matplotlib, you have some themes you can set, and we call it as setting styles. And generally people use plot dot style and then dot use. And if you do question mark, it will show you all the options, all the documentation part here. But what are those, all the possible options? You can also see, and if I recall correctly, I think it was available list. So plot dot style dot available. Yeah, see guys, wow. So it has a lot of themes, the background, font, right? Everything will be part of theme. So you have classic, you have ggplot coming from R. Seaborn is also a theme here. Dark, some dark theme will be there. Seaborn dark, Seaborn paper, different themes. I'll show you. Tableau. So Tableau is a visualization software, right, guys? So Tableau theme you can use some font, color, everything will come here. Okay, but generally, what theme we use by default, I think not to go very smart here, not to go very very differently here. I'll use a basic theme which I call it as classic. It is already there in this. Can you see it? Classic. So this theme I will use, and you can always change the theme to something else. Now there is another concept of magic line. So you are looking at Jupyter notebook, right? So if you are plotting from an interactive Python Jupyter notebook, so there are two options with you guys. Let me put the first comments. %matplotlib notebook. If you do that, it will lead to interactive plots embedded within the notebook. I'll show you. And if you do %matplotlib inline, it will show you static images. Generally, this is preferred. Let me write preferred, because static is not something we use a lot. Interactive is not something we use a lot, but I'll show you when the time is right. So these are your magic lines, okay? Magic lines or magic command, okay? Please keep that in mind, magic command, okay? They're all like setting the ground for plotting. That's why I'm telling you, right? Visualization is not tough. It's just little overwhelming in terms of syntax. It's the most easy thing. So I'm going to talk about matplotlib object hierarchy. This is a very important image which I have already annotated for you guys. So maybe I can just place it here. Hold on. So already in part of my notes, let's guys focus here, everybody. So if you see here, and I can go to Jamboard to do what I'm supposed to do, and then it will be the same image. See guys, whenever you're looking at any image, right, you start with a box. See, can you see that? This is your figure. In this, you will have two components. What is it? X-axis. And you will have what, guys? Y-axis. Isn't it? Does it make sense? Whenever you draw any chart, you will do this now. So when we talk about matplotlib hierarchy, you have a figure, you have axes, right? So this is your axes, means more than one. Axis is one, axis is more than one. Then you are also having some components like what is the label for Excel? What is the label for Y? What is the label for X? Then you also have ticks, right? Remember? So you will have major ticks, you have minor ticks. So that's all part of the figure. And then you also have title of the figure. It is also part of the same object. It's all hierarchical. Outside is your figure. So outside is your figure. Then within that you have axis. Next level is what? Title. Then next is what? X level, Y level, title. These are the three things. And then you have major text and minor text. That's how the anatomy of your figure. Is it clear? And that's exactly I have shown here. See? So it works on hierarchy. Figure, X, Y axis, labels, tick options, other things. Okay, clear? That's how matplotlib has been designed in terms of objects. Now I'll talk about legends. A lot of time people ask, what do you mean by legends in the chart? Legends are very important. Legends is what? Look at this image. So legend, if you go to any place, right, you will see a city map. So now this is like your mountains. This is like your, interstate highway. This is state highway. This is local road, right? This black big dot is population over 200,000, between 50,000 to 100,000, like that. So legends are like your markers on the chart, and then you have certain information because of that legend. Now let's take our data. So let's say df underscore sales. Now if you are having this data, that CSV file, let's see we have it or not. I don't think I have it. Guys, I also need to. I gave you one sales sample data, guys. Remember that? Excel data. Put it in the right folder. And if you don't remember it, means you can ask me again. Sales sample.xlx. The only thing you have to be careful when you're reading an Excel file, you have to use Excel. Can you see that? And df underscore sales. Dot head 3. Perfect. Can you see this data is there? Hello? Now this data is coming from public data, so I'm not responsible for any quality of the data, but that's fine. So this data has account number, name of the customer, SKU is your item, quantity is how much quantity, unit price is unit price, then external price, date, right? That's okay. So what I'm interested in it. So let's talk about the data real quick. So sales is your external price. So data consists of sales transactions for the year 2014. I had created a summary of the data. Let's see the total number of sales for top 10 customer. That's our question. Top 10 customer. That's the question I am going to plot. But you have sales is your external price, and that's called correct, right? Unit price is your price, but you are selling at a higher price, right? And customer is name. Okay, customer is name. So no, sorry, sales price is going to be multiplied 86.69 into 39. Look at there. I'll do the math and you will understand. Right, 33.80.91. So unit price is price for one quantity and external price is total price or the sales price for 39 quantity. Is it okay, guys? Just quickly understand the data. See, we'll not spend more time on what is this data. There's no point. Now, what I'm trying to show, we want to show total number of sales for top 10 customer. So what we're trying to show, we want to show, let me write the question, want to show top 10 customers by sales and also show total quantity they bought, right? That's something I want to show here. I want to start with a problem statement here. But before I get excited, I want to show you some basic functionality, else it will be injustice for you guys. Before I solve this question, I need to get equipped with some of the amazing thing there, okay? So now I'll talk about this magic line first. So let's say if I show you this magic line, then you will understand what's happening. Done? Now, if I take, first thing first, people take figure, right? So in Matplotlib, you will lay out the canvas first, right? And for that, what you have to do, you have to give the figure size. So for that, what is the syntax? Syntax is very easy, right? It's very easy. It is plt dot subplots figure size equal to, generally we put 10 by 6. 10 by 6 is too much to visualize. 6 by 6 or 6 by 4, that's fine. 3 by 4. So you have an interactive canvas and you can see you have zoom in, so you can zoom in like this. Can you see that? Right, that's what interaction means. You can also zoom to any area. You can draw a rectangle, right? Like that. You can zoom, right? You can pan. This is your pan. So you can move it, the scale, everything. Okay. Go, left, right, all the steps, and then go to home. So this is for interactive charts within Jupyter Notebook. Okay. Now what I'll do actually, I'll say, I'll use the other magic line, in line. So this is another magic command. So if I use that command, and then you will understand why did I say that. So now guys, if I take again that canvas, plt dot subplots figure size equal to 6,6. Now you see there's no interaction happening, right? It's a static image, guys. So this is your first syntax, which can be very, very helpful to get any number of subplots there. Subplots, just to explain you guys quickly. So suppose you want 2-3 plots, putting in a proper layout. So this is your big canvas. In that you want to partition like this. You want 3 plots, right? Plot 1, plot 2, plot 3 of different size, width and height. So that you can control using subplots, right? So how many row is 1? How many columns is 3, just like matrix. 1 2 3, 1 row. And then you can decide what is the width of the plot, what is the height of the plot. That's what we are doing with size. It is in inches by default. But generally, do we need this all the time? No. But if you need, what is the syntax you have to use. Let's get into some plotting here, right? So first of all, before you create this plot, you have to be very careful with the question. What is the question? The question was get the top 10 customers and also the quantity. Okay, the first do top 10 customer by sales. Let's not overcomplicate things. Okay, so how will I do it? What is my DF sales? This is my data. So you need to do some aggregation. So you will do sales aggregation. How will you do it, guys? You are a champion of it now. You'll say dot group by what? External price, ext price. And then you want to do aggregate and you want to do total sales. That's the header equal to, you want to take ext price and group by what? No, top 10 customer, my bad. Customer is name. Please change it, guys. Customer is name. Group by total sales, external price and sum. Dot reset underscore index. And definitely I must have done any mistake. External price, okay, PRTIC. Now, is it there, guys? Come on. Can I see all the customer name with their total sales in it? That's a data frame. And I want only top 10 customer. Do I need to show everything? No. So I need to sort it. So I'll create another data frame. So now, guys, I'll talk about this sorting. Shall we do sorted? Sort values by what? By total sales. What? Ascending true or false? False. Kulas in white Tranto Barrows, right? These are your top sales customer. But I don't need everybody, right? I need top 10. And you will say, I just need name of the customer and total sales, right? I don't need this index. So you can drop this column. You have seen me doing it, or you can just focus on what you need. And then I have to draw a bar plot. So how will I do it? It's very easy. For bar plot, again, I'll go into plotting first. Okay. But before I get into plotting, since I'm starting my first plot there, let me give the heading. What is bar plot? I'll talk about it. So bar plot or bar chart, we call it, is second most popular chart, or I would say, popular chart. It shows a relationship between a numeric and categorical variable. Always keep that in mind. So in this example, numeric variable is total sales and categorical variable is what? Your customer name. Okay. And you should know that each of the customer name is going to be represented by bar, and each size of the bar will go and show the numerical value. So categorical name is the X label, and the size of the bar is your total sale, which is Y label. So these are your key points on bar plot. It is second most popular chart. The first one is line chart, but I started with bar plot. That's fine. Okay, let's say it is one of the most popular chart. A bar chart is one of the, not say one of the most popular charts. Now I'm going to plot. So before I go and plot, I'll just again take the canvas, and it's my choice. I can say figure size equal to, since there are going to be 10 customers, so I need little more, width, and height is fine if I do this. So I want to put 10 customer here, so that's why I'm taking, a little wide, but height is okay with us. Then keep adding to this. If you write something here, it will not work. Now, guys, to plot the bar, the syntax is plot dot bar. See, and you can go and read about the documentation. So height, width of the bar, thickness of the bar, right? Align, you want to align on center. Other things you can do using this. So for now, I need to have, in this data, there are two things. The first one is what? DF, hold on, guys, sorted top 10, and I want X level. So by default, the first data point is X level, and that is what? Name. So that's what I've given. So see, I'm selecting that column here, guys. Can you see that? Similarly, I'll select second column, which is Y axis, and that will be what? Your total sales. Do this. See, it's very easy. You can always play around with this. This is just the first plot. Now we can see the width of the chart is not that good. So you can go width and you can play around. By default, it is 0.5. See, now we like it. Okay, makes sense. See, the headers are not making sense. So you can make it, something else. It's all about the syntax. Okay, the bottom right. So that is something you can handle it later because it is overlapping, right? So then you have to use some other, syntax and everything. But that is something you will, you will do it, you will learn it over the period of time. So by default, width is not 0.5, 0.8, guys. Okay. Then I know you might be interested in colors. I don't like this color. You want some other colors, guys? You can say, I want red. Take red. You can do R. You can also write RED, right? You can also put hex code. So there is a very good website for picking hex code for the color. I all the time I use for my projects. It's a very beautiful website for all the hex colors for the code, hex code for the colors. So right, suppose you are interested in this color, all right, some other color, like you are interested in purple. I like purple. Go and take the hex code, copy it, and you go back there. You can say hex code I'll use now. See, bingo. You can write the name of the color. You can put the hex code. You can do any number of things. Shall we add some labels and all? Color we have handled, right? Okay, now I want to do something. So there is align. You can align center. It's by default, it is aligned to center. Now I want to add some labels. So plt.x label, can you guys see that? X label is your X axis, guys. What is there? Customer name. plt.y label. What is that? Total sales. That is your X label, Y label. What about title? Title. What is the title? It is total sales by customer. Can I say that? See, coming on the top. Then if you really want to understand everything, so font, location, padding, everything, you can do it, guys. Right? You can do n number of things with this. Okay. Okay. Now you can change the title. So plt.set titles. What was that syntax? Sorry, I completely forgot. We put some style, right? plt.style.use. You can see, right? And then you can see that, okay, I want to use ggplot2, not 2, right? See here. Or maybe you can say cborn. You got something happening there, right? Guys, do you see the moment you change the style, your whole chart is changing? This is the favorite one of mine, ggplot2. Why ggplot? Is it not in there? Let me take it. What are the styles available to us? Must be making some spelling mistake. It is what? I think this is also very good. 538. Sometime I use this one also. 538. Okay, let me show you. Look at this. Can you see? Already your title is getting bigger and bold. Right? Not necessary you go into font size and start playing it like a baby. Now, did you notice, guys, what I've done? I have changed the rotation. Now it is very easy, guys. Come on, can you see that? Now you can read which one are the customer here. And then you can do plt.show to show your plot. And you can reduce this 8 till 6. Or you can make it bigger also. Perfect. Now this is something I like it. This is good. Now, sometimes people say, no, this alignment is not that great. So you can also do horizontal alignment to right, and then the chart will become more better. And that was, can we export this file, right? Now, guys, I'm going to export this. So let me export this image so that you can use this in your presentation, in your slide. Figure, say figure, and you can give it some name. White PLT I have to do. And here is my image. So I'm just taking this image from my system, okay? See. No, it's not working fine. After show, no, before show. Okay. Yes, it should work now. And forget about this. Let me go there again. Can you see the image now? Perfect. It is cropping the name of the titles in the below, but we can take care of all those things later. The next heading is, let me talk about object oriented interface in Matplotlib. Okay, this is very, very important topic, guys. So this is also important because if I am a sincere trainer or instructor here, if I don't tell you in Matplotlib this, it's a total injustice. Because see, everybody start with this guy, and most of the things you can handle with these guys. PLT thing, that your pipe plot, object-oriented interface, it is more or less similar. It's just that it has more power, more features, more capabilities, right? So generally, everybody start with pipe plot, which is the traditional MATLAB style, traditional MATLAB style, and that style is going to help you to learn Matplotlib. That's the beginning. That's the starting. But once you are a little thorough, right, and you want to perform advanced customizations on your graphs, right, you need object-oriented plotting. And that's where I'll write object. I'm also writing, guys, object-oriented API comes into play. Okay. So guys, Matplotlib now consists of base classes called artist. So if you have seen the base classes called as artist, okay, and if you have seen the any of the famous images, which we also call it as anatomy of a figure. Let me show you. That's something we also call it as anatomy of a figure. It's a very famous plot. Everybody knows it in Matplotlib domain. So let me show you that. No, this size is not up to the mark. Yeah. So if I can show you this, then you will understand that Matplotlib is amazing. Okay. Can you guys see an image there? And that's what I'll call anatomy of a figure. So anatomy of a figure, it talks about the same canvas. So plt.figure is one of the classes. So all these classes are there, right? A lot of classes there within the artist. So legend is a class, grid is a class, line is a class, minor tick is a class, major tick level is a class. Can you see that? Y level, and that's where I've given AX, 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 everything. So don't worry, I'll explain. But all these the circles in this chart, right, which I'm showing here is a class, and all comes under the category of artist. Okay, so let me write that point as you will forget. So please write each circle annotated component in the above chart is a separate class that inherits from the base artist. And that's where you can also relate that it is your object-oriented programming, right? It is what? Object-oriented programming. Because inheritance is a concept in OOPS, right? So this, all these circle component there in the above chart, inheriting from the base class called artist. Okay. Request. Anyway, it will part of, it is going to be part of your notebook. So don't worry. It is sitting here and right? I share the notebook, the chart or images will be there. Okay. Now, guys, let me put the heading. Okay, guys, let's talk about figure and axis. Already you know that. So I can define figure and axis equal to X. And let me say plot dot subplots, right? Subplots. So if you observe this, guys, this is 538 template. That's why you see this. This is coming like this. You can set to something else and you will see some nice ones. But anyway, can you see that this is your figure? So this whole thing, let me write, this whole thing is your figure, and then you have axis X and axis Y. Is it clear? Isn't it, guys? Come on. This whole thing is your figure. This is your X axis and this is your Y axis. So the figure is right. So you have figure and axis. Okay. You can also go inside and you can say, I want to set it to some number of rows, and I see n column equal to 3. So what it will do, guys, if you focus, it has created 3 subplot within one big canvas, right? I can also make it number of rows equal to 2. So now you can see it is 2 by 3 matrix. So row 1, row 2, row 3, column 1, excuse me, column 2, column 3. So total 2 by 3 matrix, right? Guys, can you see that? You can also plot multiple charts in one chart. And to access that, you have to use, by using a loop or, indexing the operators. So you have n row and n columns, you can index it. I'll show you one chart down the line, but for now, this should be good, right? So I'm using the style 538, and that's where you're seeing everything like that. You might have a different style. Figure is what? Figure is the outer canvas. Remember that? If you attended the lecture and revised it, you would not have asked this question. What is figure? This red box is your figure. This whole thing is your figure. Axis is your x-axis and y-axis. So that's what you're running the two lines of two boxes or two objects you're creating, one within the other by using object-oriented programming. Is it clear, guys? Now, what I'm going to do, I'm going to create the same chart. See, this is the chart we created, right? I'm going to create the same chart by using this object-oriented plotting. So I hope you guys should be up for it, okay? So now let me just make it a clean slate. And now I'm also going to use Seaborn for the very first time, I guess, Seaborn as SNS. So this is another, it's not Matplotlib, but you can use this library, guys. Import Seaborn as SNS. Okay, so that is something you just keep it ready. I keep using Matplotlib and Seaborn time to time. Both are similar. So what I'm gonna do, I'm going to create the same thing, figure axis equal to plt dot subplots, and you have to write everything in one line of code. And I want to also define figure size, okay, which is fixed size equal to, and I want to say same 12 by 6. That's fine. So look at that. The canvas is ready, my dear friend. Can you guys see that? This is your canvas where you're going to plot it. Okay. Now to get into bar, what should I do? So I will use not plt now. I will be using ax. Okay. Did you use this? Please use this styling. Guys, everybody run this line of code. Then only we'll see grids and everything. Okay. Please follow through. So now if you focus here, guys, if you're looking for grid, use that plt.style.use. I think by default it is set to classic, so you have to make sure you use that. Now if I'm saying ax.bar, right, ax.bar, so you might be interesting that what are the functions in it. So you can do tab, it will show bar, bar horizontal, box plot. So box plot, bar horizontal and bar vertical already we have to use, right? Guys, you have to run all those syntax. Let's talk about bar, right? So now if I show you the documentation, guys, please pay attention. So documentation says x is your x-axis, height is your height. A lot of things you will find that it is similar to what you have seen in a PLT. Okay. So now, guys, I have this data, DF sales aggregate sort top 10. X-axis is my customer, which is by name. So I'll take name. I'll take another, which is my Y-axis. That will be the data frame top 10, and I'll take total sales, right? This will give me the bar plot. Very basic bar plot, right? You can see looks ugly, but you are able to get the bar plot, right? Now what I'll do, I'll get into the detail of it. I'll start setting the width. So first thing first, you set the width. Do it, guys. So width equal to what? 0.3 and keep running. Wow, this makes sense. Now what? Color? Color, you can say blue. I think it is blue. No, not that blue. Or let's say purple. Let's say, does it identify purple? I think it will. Yeah. Right. Similar to that color we have got. Are we there, guys? So width is there, purple there, but still a lot of things are not present in the chart. So what we do, we can also do this AX dot titles. You will see text, you will say title, you will see X level, right? X axis, Y axis. But there is a function called AX dot set, and there within that you can go and write, title equal to, you can give total sales dollar by top 10 customer names. Isn't it, guys? Can I say that? Okay, then I'll say comma. What is it? X level. So I'll say top 10 customer names. Guys, come on. Y level. I would say total sales. Look at, guys, look at there for this, and it is dollar. Hello. And I'll do this. Did I miss something? Yes, I missed a lot of things. Comma. I think it should be good. Right, guys? Come on. Are you able to see now? It's coming. X-axis, Y-axis, title. But still, I'm not happy with the customer names. And then I can use my PLT as set properties. I can do this. So you can use mix of object-oriented plotting. And now you can see that I can use in this plt.set property. This is called set properties, right? So you can set properties of any object, and you can go and get what? So you can write ax.get. That's your powerful options. Ax.get is going to give you everything, and all these classes are present in figure. Let me show you that your top notch. See here. So all these classes are present in here. Can you guys see that? Get this, get that, right? Get grid, get in loud, get tight layout. A lot of things you can do. Sky is the limit there. So that's why this figure has a lot of objects within it, classes and methods, and you can use it, guys. So keeping that in mind, I want to do what? I want to do something with X ticks. So I'll do X ticks, right? Labels, yes. And I'll say rotation, right? Equal to 30 degree. Look at this. Did I miss something, guys? And I have to also do plt.show. Don't miss that part. Perfect, guys. Come on. This is also important, right? If you don't do plt.show explicitly, it will show something weird, and then the chart will come. I'll show you. So I can still do that and see the chart is coming, but it will also show you these, returns, output returns. So guys, I'll take a pause here. Does it make sense? Are you able to follow through? We have done the similar chart, right? But using a whole together a new technique there, right? Did you guys get a hang of it? And it was also simple, right? So this ax.get, right? You can use this object with a lot of flexibilities. PLT has not that many options, trust me. Okay, you need to understand that. You will get it. So see, charting is something you will explore a lot of things. Can I do a lot of things there? So for example, can I do some edge color, right? So color is purple. Can I put some edge color there? You can also think of some different color. Let's say you want to give edge color as white. You can do it. Or maybe edge color as green. It's not working here. So it should work. Why it's not working? Green, it is not picking, or what? Color is what? Blue or dark blue? Guys, yeah, it is coming. It's not that we are not able to see it. That's it. So maybe let's do this as sky blue, and then you will see it. Yeah, can you guys see that? There is an edge color, right? So it was like so light that I was not able to make out. Okay, guys, did you see the edge color came? Can we do that? All different color bar. I think we can do that. Anybody's any idea how we can approach? So we have 10 customers. So I want to give all 10 customers as different color bar. That's your request, Abdul. You can create list of colors. Yes, that's correct. You can actually do that. I'll show you. It's not rocket science. So what you're supposed to do, you're supposed to create color map, and that's where you're supposed to give different colors there. Okay, so for that you have to create the color list, and that is something you have to actually go and do it in some different SNS, like Seaborn. You can do different bar colors in a different way, but in Matplotlib you have to actually define you know different colors to the different bars by giving the color list. You can also give or highlight any bar of your customer, right? You want to give, means what I'm trying to say, that you can also highlight certain customers. That's what I'm trying to say. So if you're interested in only showing a customer, you can also show that okay, I want to make this customer as highlighted customer for me, important customer for me. So you can give a different color altogether there. Okay, so let's give some colors now. So colors equal to, start giving the color. So let's say red, blue, green. I'll be losing the colors, right? Dark blue. Let me give it a shot. Purple. What else? How many colors I've covered? Red, blue, green, dark blue, purple, cyan, sky blue, gray, black, orange. Oh my God, so many colors are there, huh? Good. Now 10, is it 10? Do just. Now if I say colors equal to C, and let's call this as C. Okay, bingo guys, easy. So you can also decide which color you want to give to which customer, right? It's not a rocket science. Okay, so let me go back to that chart. So can you see that? These are your ticks. Okay, this is known as major X ticks. This is known as minor X ticks, right? So that's how you divide your graph, right? Let's say if it is 2, this is 3. So you will call this as, 2.2, 2.4, 2.6, 2.8, 3. So 2.2, 2.4, 2.6 is your minor X ticks. And between 2 and 3, the big ones are the major X ticks. Is it clear? I don't know. Means, what is exactly you want to know? Okay. So ticks means ticks, right? So Y tick is like similarly on the Y axis. Okay. Major, minor, clear? Okay, guys. So this is something I wanted to cover here on bar chart, but I think I need to move on to some other charts, right? I totally feel that, but just try to understand that charting is something you will explore, you will learn a lot. So don't worry much on that are you able to get all the charts in one go? I think nobody can get all the charts in one go. Okay, so give it some time and it will come to you. Okay, guys. Now if I talk about some of the line charts, right? So let me put the heading line charts, very important. So guys, where do we use line chart? So I think whenever you want to show how things change over a time, right? To show trend, to show the trend. Trend can be of anything. Trend can be of COVID cases. Trend can be of sales, profit, losses, forecast, everything, right? So to show the trend over a period, and it could be anything, right? It could be month over month. So in business, we always do this mom chart. So mom is what? Month over month. Don't ask what is mom. Week over week. Wow. It is known as wow chart. Okay. So all these charts are very important for us. Okay. Sometimes we want to compare all the data coming from different series, like sales trend chart against profit. We can do that, right? Like sales trend versus profit trend, right guys? Come on. So something like that. So you want to show everything at all, to compare all the data coming from different series, like at once, you will be using trend chart, or sorry, line chart. Okay. In supply chain or any businesses showing forecast data, you are supposed to show trend charts. So a lot of places where we use trend chart. So let's say df underscore store pd.read csv sample superstore data. Okay, df store dot head to dot transpose. So if I run this, you will understand this data. You have seen it. So this data is about superstore. Data is about products you are selling under what category, in what city, what state, how much is your profit, how many quantity you have sold, and how much of sales you've done. It's a very amazing data for any kind of data science work with it, data science activities with it, right? So now what I'm going to do, I'm going to do some date handling first. So first, to understand this data, superstore data, let's understand the data info. You know all those steps, guys. So guys, if you look at this data, right, you have order date and you have ship date. Can you see that there are two dates, but both the dates are highlighted as what? Object. It's not date, to be frank here, right? Then other columns are all more or like object, float, and integer. So more or less you have three data types: float, integer, object. And that's where we need to do some manipulation with the data. And I'll put the heading as date manipulation on superstore data. So I'm going to teach you a little bit of date handling, guys. So guys, first thing first, you have to understand that you have pandas date, functions, and that is called date time index. That is something you have to keep in mind. So this is your function. That is something you are supposed to keep in your mind. Okay, so using pandas dot date time index, we can do some of the date manipulations. So what we are trying to do here, that is something you need to understand. Okay, so first thing first, I have two tasks. So I need to create year and month as separate columns for order date. I'll just pick one date, guys. So guys, if you see the data, let me show you back. Data is what? Order date is what? It's a date, right? It's not a month, it's not a year. I need month here. So how will I do it? So I'll use df store data frame and I'll create a new column, order year. Guys, focus. And I'll call it pd data time index. Pd dot date time index. It will be the third one. And it will take df underscore store and you'll pick order date and you will do what? You'll just do year. Similarly, you will do what? Order month. Please pay attention. And you'll go there and you'll say month. See the magic. Now, if I show you the same data, you will see that now you have order year 2017 and month is what? 11. So if you go to this order date, 2017 8/11 means 8th November 2017, and that's what you have. Month as November and year is 2017. Are you able to follow through, guys? Come on. You will say this is very simple, sir. Let's look at tail. So what is the date there? Date is 16 October 2018. Year is 2018. Month is 10, right? Now you can also do what is the object types, data types. Just do info again. You will see that still your order date is object, but you have two more column coming as integer, guys. Can you see that?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Guys, now I need to create what? I need to create another field. I need to create another field. Now, guys, what I'm going to create, I'm going to create year month column. Okay. So year month column I am willing to create. So let's write create order year month columns looking like this, So example 2017 11, something like this. Are you getting, guys? So I'll be creating this order year month column. How will you create this, guys? Come on. If you are good, you know how to do it. So you'll take df store. You will take this. What was that column? Year? No, not year. Order year, right? What was that? Order year. Then you will do plus. You will concatenate with hyphen. Then again you will do plus df underscore store, and you will do what? Order month. Is it clear, guys, about everybody? So I'm using concatenation there, guys. Come on. If I run it, oh, some error has come. Let's see. Okay, so it's an issue of the data type, right? So what you have to do, you have to first create it into string. It is not a string, it's an integer, right? Integer 64, integer 64. So how do you create an integer? How do you change the data type? So you'll do what? As type here, string. So guys, you cannot concatenate integer with string. This is string, right? This is string. Let's see, will it work? Right? Did it work, guys? So what I've done, understand from me. What I've done, guys, earlier it was integer, right? Did you see order year and order month? By default, it has created an integer there. I have created, this is like typecasting. I have changed this integer to what? Integer to what? String, and then I have concatenated. Let me show you this data and you'll understand. Once more, guys, come on, focus. So I'm not doing any charting yet. Can you see you are getting that intended result 2017-11? So this as type is something I've just taught you. You can typecast it by using this. So just keep this in mind. Okay, learn when you code. Okay, now if I do this df underscore dot info, you will understand that the last one is an object. It's an string. Okay. Now once you have it, I want to do some line charting. Okay. So there are different ways to do it, right? There are a lot of things to do it. So this is just one teaser I've shown. It's bigger than that, but that comes in advanced Python. So that is something you have to cover quickly. At your end, I'll also help you, but I'll give you some resources to read about it. Okay. Now, guys, what I'm going to do here, I'm going to show you in df underscore store, right? Order year, unique. So that gives you what? Shows the unique years in the data, right? What are the years you are seeing, guys? 2017, 16, 15, 18, right? So let's take only 2 years of data. Okay, so set year as a conditional criteria. I'll say df underscore store and I'll take year. Focus, you have seen me doing all those things. Order year greater than 2016. And now I'm going to create a subset of data df score sub, and I'll use here set year. Now, if I go back just to check that whether it has been taken care of or not, I'll again print my unique values, guys. Come on. And it will only show me 17, 18. Is it happening, guys? Yes. So what I've done, the first thing I've done here, I have just subset the data only for, that's what I've done. Now, if I focus on this, I have data for 2017, 2018. So now the next task I'm planning to do is what? I'm planning to plot the line chart of sales. Okay. So that's my target, guys. That's what I'm going to do in 5 minutes or 10 minutes max. Okay. And that will show you the line charts and that will help you understand where the sales are happening and all those things. Okay. But there is one advice which I'll give you in a moment. So let me first show you plots of line chart. So I'll do subplots, you know that. I'll set the figure size. Now it will seem to be all repetitive now. Now I'll say plt dot line chart. You don't need to write line or something. There's nothing called line. So you have to just write plt dot plot. Okay. And then you will say df store sub. On x-axis, you can put your that order month here. Okay. And on y-axis, you can put sales, right? And if you just do a shift enter, you will see some zigzag things happening, right? This is a very beautiful interview question. What's happening there, guys? What's happening there? I can also do this plt.show. Let's understand this. What's happening there? What is this zigzag thing is coming? Take 30 seconds, understand, right? You can make it bigger so that, you can make it 18 so that you can read. I'm not showing a summary of the chart. I want to show every month here it has come, right? More like a line chart. So data is not aggregated, range is not correct. I think there are a couple of things are happening, guys. Okay. So number one is what? Sorting is not happening. You can see you have 2017, then you have 2018, then again 2017. So first you need to make this data sorted. It will not automatically sort it, right, guys? Are you able to understand what I'm saying? You have to do sorting of this data frame by what? By this guy, order, whatever it is, order, or you can sort it by anything, order date. You need to get the column's name, right? Sometimes column names I don't remember. So you have this magical power there, right? What are the column names? Okay, order date. Just copy paste Muddy. Okay, got it? And say ascending equal to true. Even if you don't say, it will by default do it. And this is okay. So I've run this. Now again, I'll go back to my plotting of line chart. Let's see. I'm trying to debug it. Now, if I've done this sorted thing, I have to change this data frame to sorted. Wow. Now what's happening, guys? Do you think it has been sorted? I don't think so. Not yet. And whenever you are in doubt, you can always write. So you can say order, year, month. Now what's happening? Still it is not sorted. Are you guys getting? Something is an issue there, right? Let's see what is it. 31st, 30 January, right? 9 January. So I can quickly see it is not sorted. Okay, let me see by this column, right? So I need to sort it by date. If you sort it by order, how will it will identify, right, which year is which, right? So first of all, I need to sort it by what? Day, order date. Okay, ascending is true. Now let's see what's happening. Order date. No, I don't see it has been sorted. Let me show head of 10. First 2018. Okay, when I say ascending equal to false, let's see what happens. Still it's not happening. So guys, what's going wrong? I have struggled a lot, by the way, on this. You know what is the issue? Nobody has identified that issue. Issue is that how will you sort this? It's a string here. How will you sort it? It's a string. Order date is a string. Issue is date format. You're trying to do a time series and you are not even focusing that whether order date is really a date. Let me show you again. So what was that? DF store sub sorted info. Let me show you. Order date is date. Is it date? No. And that's where you will learn about data handling more. So guys, first thing first, you have to make it a date. It is not a date. So how will you make it a date? Please put the heading, very, very important. Change order, date, and ship date columns from object to date type. That's what I'm going to show you. So how can you do that? You can start df sub sorted. Hold on. Order, you can do in the base data frame as well. Order date. And there is a very good function in Pandas date time, that is pd.to convert it to date time, and you will use this. Okay, and I'll just copy paste. I'll also do it for ship date. Follow. I'll also do it for ship date. Let's focus. Okay, now I'll again run this. I will see the magic. Can you see that now it has been converted into date time? My dear friends, what I'm making you learn is all coming from business. Okay, so I have converted into date time. Did you guys observe? So that is something you should always learn about it. Let me make it more emphatic, right? So the bigger header. Guys, is it okay? Now let's go back to the business. So now again, I'll pick this sorting thing. I'll come down. So I was just trying to pretend that I did not know, so that I wanted to grasp your thoughts here. Definitely ascending false doesn't matter. Date is always sorted by ascending true, right? Starting with oldest date to the latest date. If I just do this, now if I plot, first I'll show you 10 data points. Guys, can you see that? Are you able to sort now? What happened? This is order date. I think I've converted into date time. My sorting is gone for a toss. Okay, so hold on, guys. Let me quickly look at my data set first. It is df store sub. Okay, let me focus on this info. Yeah, so that's the issue, guys. Okay, so I have sorted something else. So generally what we'll do, right, I have sorted this guy. So let me just do one thing. I have to just do this, which is not the right way to do it. I realize what is the issue. Sort values by order date. Now it should work. Okay. So what I'm doing, guys, I am just taking the sub-sorted data frame and again sorting it by order date. Okay. Now if I show you, it will work. It should work. I don't know why it is not working. Sorting is giving me a headache. Okay, so let's do one thing. Let's do in the right data set itself. So I think I can take the sub, okay, and also change it, guys. Hold on, please hold on. I think there's something going. I'm screwing up. I'm not able to, figure it out what's going wrong. This is fine. Now let me delete this. So I'm just correcting myself, guys. Okay. Now this is date time, date time. I'll just delete this guy, this data frame I don't need. So you get lost. Okay. Now I'll create sorted equal to df store sub. I'll use the sub, guys. Please also pay attention and help me out if I'm making some silly mistake. Sort values by order date. Yeah, it's what, guys. Now can you see that? Hello. So I was not doing the right way, and thanks to my health status, my brain is working at a supersonic speed. So guys, what I've done, I have taken the subset of the data, which is what, 2017 and 18, and there I have changed the data type of order date and ship date to date time. That's what I'm showing here. So you have order date, you have ship date in the date time, and then I have done the same step which I was trying to do since long. Take the subset of df underscore store, which is df store sub that contains only the years 2017 and 18, isn't it? What I've done in the next step, change the order and ship date to from object to date time data type, isn't it, guys? Third, then sort the order date from old to new, oldest to newest, oldest to latest, creating a new data frame called df store sub sorted. That's what I've done. Now again if I plot the same chart, let me take it. You guys were talking about aggregation, right? You have not done aggregation, all this blah blah. So let me show you first. Order year month, right? What's happening? Still it's not showing correctly, or you think that some issue is there? Now you cannot say that it's not showing correctly. See, if I have, can you see that? Now it is all in the picture, right? 2017 to 1, right? So now what do you guys think? What is the issue now? Then what you were guys trying to highlight is making a lot of sense. What is that point? You need to aggregate when you want to show year month, right? Now your data is sorted. Your chart is not coming as zigzag. Can you see that? Earlier it was coming as a zigzag. Zigzag was because of sorting issue. Just mind it. Don't tell the wrong answer for everything. Zigzag was because of the sorting issue. Because one data point is here, then other is there, so it will try to connect. Now what you are looking at this is because of the issue that now you're looking at data points and you're converting into months and you're not aggregating. So what it will do, it will try to do what? It will try to take all the data points, different order dates, and try to show you some data points which is going to be having high numbers, and then suddenly it will try to give some other numbers. So actually it's not the right way to show it. So if you really want to plot any data, you need to do an aggregation. An aggregation can be anything. Let's suppose I show you this with respect to order date, that I can do that. Still see. Now this makes still a lot of sense, right? But still you will see that if you see, right, it is not that appropriate, because it can be possible that on the same date multiple SKUs have been ordered. Possible, no? On the same date multiple SKUs would have been ordered, and for every line there will be some sales value. So what we are going to do, we are going to play aggregation, and you know how to play aggregation. So you will do what? You will take the same sub sorted, take the sorted thing only, and then do group by So I'll make an aggregation of what? Day level. So I'll say date, focus, sorted, dot, group by what? Order date, right? First by order date, because I'm trying to aggregate date, not year, month. I'll come to month. Group by order date, and what you will do, you'll do aggregate, and you will say total sales focus equal to, you know what is it? You will say sales, comma, sum, and you will say dot reset dot index. Guys, please pay attention. Now, if I just show you head of 10, you will see that now you have only the dates and the total sales. 2nd January, 3rd January, 4th January, like only one date coming once, right? Now, if I go back to my charting, right? Hello. If I go back to my charting and I'll use this guy, come on, aggregate date, and it will be what? Order date, and this is what? Total sales. Perfect. Let me show you. Now look at this magic. Can you see the chart? I think this is something you might have been interested in, right? I know you guys are trying to say kab dikhaoge danka chart, right? But did you see the journey I've given you, right? That's how we do training. It's not like some good lines of code, some good chart. I'll show you the problems within the path so that when you're doing for the first time, you say, okay, I can understand it. Do you understand the magic happening here, guys? So the way you have done for date, you can also do for month here, my dear friends. How can you do for month here? You can say, now you don't want to show this much detail. You want to show month here. You create a data frame month here, but you don't do this by order date now. You group by but what? Order. I had created this column, remember, order year month, right? And then see, it's so fast to do it. I'll just replace my data frame name. And I have to also do this guy. Now you'll understand, wow, this is good, huh? Here it is so much of noise, you're not able to make sense of it. But the moment you go into month over month, you say, I'll tell you exactly what's happening there, huh? Look at there. So you can go and say that, okay, generally in December time, my sales increase. Generally in November, December time, you go, see 1820. So you see a seasonality is happening there. And that seasonality is happening because of what? In US, a lot of functions like Christmas, I don't know, Halloween day, I don't know when it does it happen, but definitely some event was there. And that's how you are seeing those peaks coming in 17, 18, 11, and 12 months. Can you guys see that? So you can actually make out some sense there, right? Then you might be interested. No, I'm not only interested in this. I need more information, right? And when we have Tableau and Power BI, why do we do this open source? So first of all, Tableau and Power BI, definitely it's very good for plotting the charts and everything. We do it in Python because let's say you are doing some critical analysis and you want to also show these charts to your clients or stakeholders free of cost. Tableau is 500 USD per user per month. Power BI is almost 100 USD per year per month. There's a cost involved, license cost. And then if somebody wants to use it, they also need to take license. So their cost is there, it is free of cost. So when you are really want to do a thorough development of dashboards, you want to make some BI reports, you need Tableau Power BI. But suppose you're doing some analysis, right? You are not going to do, okay, now take me the data and put it into Tableau, right? You want to do what? You want to just plot some charts to make sense of data. Because you remember that a picture is worth 100,000 words. So the moment I plotted it, right, when I'm showing you this, did you make any sense of the data? No. But the moment I showed you this, you said, okay, it makes a lot of sense. Are you getting or not? So charting is all to get you more insights, get deeper insights from data. At the same time, it comes free of cost. Just to conclude my answer. Now, guys, I'm going to just get more excited. I will also take profit on this. So I'm just changing it a bit, my aggregation. I'll say total profit equal to, what is it? Profit, follow, and I'll do sum. See, total profit also coming month over month, right? I can also show you first, I'll go in more detail in here, right? So I'll also show you my total profit in this part of the chart against the total sales. So for that, what I have to do? I have to do nothing. I have to just be a little smart. So I'll just copy this guy. Please focus. And you also do a lot of copy and paste. and here you do total profit. It will come. Now, since I will do it, I'll show you. Now you suddenly see that they have by default taken two different colors. Can you guys see that? It's coming beautiful, right? Now I am superimposing profit and sales just to understand few things there. But now since I have put two colors, right? By default, it has taken two colors. I want to control the colors. So sales is like green for me. Line style is very important. So you can also give some line style. So there are different line styles you learn over the time. So you have hyphen. So it will be dotted line, sorry, solid line, and you have label. So you can give label sales per day. It's per day, right? Similarly, you can have, you just copy these three. I'll correct it. Line style is not line detail. Okay, line style. And you can have dotted lines. You can do column. Okay, column will give you dotted. And it is your profit per day, right? So these are your markers, right? Different markers. Color I want to do. Profit is like what? Sales is like, let's say, call it as blue. Profit is like green, right? So whenever there is profit, it is green. See, not interested. Red, yeah. And in case you're not happy with the width, dotted, and everything, you can go and say that now I want to do a different line style. So you can do a little bit of Googling there, and there are all the options available to you. So you can also do this, I guess, hyphen. So there will be different line style. Can you see that, guys? So up to you, how do you want to do it? Okay. Now, once you have it, and now it looks little zoomed in, that's why, right? Yes, you can also do this. I think it will be marker, not line style, sorry. Rabia, marker you have to select as this. Okay. So I'll talk about marker down the line. So you can also select marker as she's telling, let me give you the marker. These are fixed, fixed things. You cannot just say that I'll take this. Okay. It's up to you. Marker equal to, and you have to put a dot. See, so can you see there is a marker coming, guys? See that solid. Okay. So up to you guys. Look at that. Can you see that, guys? So you have markers coming there. Okay. So this chart looks little cluttered now, but when you go to month level, it will look nice. Okay. Now you can also go into giving the X label, right? You can say it is order date. You can do PLT dot Y label, and you can say it as sales versus profit per day, isn't it, guys? That is your Y. Sorry, that is your title. Sorry, my bad. And if I have to give PLT dot Y label, you can say sales versus profit in dollar, isn't it, guys? So I can say these things. Then you can also show legend, and you can make it something like this. So legend is coming from this title, okay? Sales per day. And since you're looking at the zoom version of the chart, it looks a little awful, but this is how it is, okay? And you can actually write, you can actually do any number of things. But this chart is presentable, right? You cannot say it is not presentable. It is presentable. You cannot say in my face it is not presentable chart. Do you guys say? You can move those legends and everything. Ravya, you can move it. So see, not everything I'll tell you. It's not possible, but this is not also tough. So you can put your legend, you can move it, everything you can do, but you also explore. Okay. For the time being, I can do anything with these charts. I can like just slip it and flip it into any way. Now, guys, looking at this chart, if you see, right, there are some days where the losses are happening, right? Profit negative means what? Loss, right? So losses are happening, right? Isn't it? But if you look at the month level, it's all profit because you are aggregating the data, right? So let's see where it is happening or not. So if I go and take the same chart, so this is now going to be order year month, right? I'm going to month now, year month. And I'll just change my data frame, right? Order year date, order year month. Now this will be per month. So I'm just tweaking it. Be smart. Now, where is my month one? This is right. This is my data frame. So let me copy and paste everywhere. Be smart, guys. And it is what? Order year month. Focus, focus. So you need to change to order year month. Let's see what is there. A total profit it doesn't have. Okay. So I did not created this. This is for date. Similarly, I have to do it for order year month, right? Sorry. So I need to go there and I have to do just copy paste. Guys, also I'm giving you these lines of code in the Slack so that you are also on top of the things. Now profit will come. Now it will work. See guys, do you notice? And now I have to change it is sales per month. Hold on. And this is profit per month. Hold on. Now guys, can you see this? This is so amazing. Okay. Now you can clearly see that when you look at this data, there's nothing coming as negative. Do I see anything negative? Let me show you this data altogether. I think you can plot everything, right? Total profit is never negative, guys. Never negative, never ever. Can you guys see that? So that's where if you look at the month level data, it doesn't give you that profit is also somewhere losses are happening. But overall, each month you are having some profit, isn't it, guys? Come on. Sometime day level you can get a lot of insights. Sometime month level you can get a lot of insights. Now this is not looking that great. So what I'll do, I will do this plt.xtext and I'll do rotation equal to 30 degree. Can you see that, guys? Now it will be looking cool because I'm plotting everything there. Okay. Okay, guys. So this is your, but before you do that, guys, you need to pay attention on this line of code as well. So you have to create this grouping properly. If you don't have a group properly grouped by total profit, total sales, you're not able to do it. Okay. Okay, cool, guys. So if you are able to follow through this, you can see that this is your chart and you can think in n number of ways. You can create this as an area chart, right? So you can create area chart using matplotlib only. So profit can be an area chart. It will be a fill chart, right? So I believe you can do any number of things. There's nothing is stopping you. Okay, you can also plot chart by categories, right? So you have different categories, technology, furniture, or subcategories, and you can see that which category is bleeding. Yeah. So this is something I was trying to ask you guys to do it, right? Now you might be wondering that this is so easy, sir. Yes, it is easy. Did you notice what I just did? I have just changed it. So I don't want to do it here because then you will say what's happening. You're doing in Havame. I'm not doing in Havame, by the way. So guys, what I've done, I just try to do that. I just recall that we can do this, right? PLT dot for area chart, you can do fill between this. And the only thing you have to be careful that there is no marker in this function. So it's not every function will have everything. So this is your area profit chart. See, this is exactly what I was trying to say. So you can clearly see that whenever you have more sales, right, your profit increases. That's a common understanding, right? So when you sell more, your profit has high chance of increasing. But if you focus really very closely, so at this point you did not sell a lot, but still your profit was really good. Can you see that? This is what month? 2018 3. 2018 3, which is March 2018. Your profit was 14 grand, right? $14,000. And similarly, the highest profit was what? $16,000 or $17,000. But still you did not sell more, right? You did not sell more, but still your profit was more. And that's where you can say that, okay, I can also calculate percentage profit. You can say, profit by revenue. Can you see that? You can say that profit by revenue is what? Or profit by sales. And you can go there and you can do the maths, right, guys? So I'm not getting into it, but you can do that, isn't it? The next chart I would show you is what? Pie chart. So line chart and bar chart, you have already seen a lot. You can have multiple series plotted here. Okay, guys. So explore this. See, it's all about you exploring it rather than me telling you everything. So you explore it. I'll give you all funda here. Now, if you want to do this question for each of the subcategories, right? So guys, first you need to get into the data preparation. So if I can give you the steps and you will love it. So let me give you the steps as part of Hint. Steps are very simple. Number one, data preparation. So what you have to do, idea is very simple. You take this same data frame, use the latest data frame and aggregate it to what? It to subcategory level and order month. Isn't it, guys? That's what I'm asking you to do. So first you aggregate your data again by what? Order month here and subcategory. Aggregate it by subcategory level and order year month, right? Once you have that, guys, what you will do, right? You have to think that for first, you can iterate, right? For subcategory k equal to 1, whatever in the index. So let's say it is some category. Plot the same line chart or the same above line chart. Plot the above line chart, isn't it? And you will just iterate it now. What's the issue there? Okay. So there you have to use the looping, or you can also create a function to do that. I don't know. It's up to you guys. So pie chart, I think, is one of the very fundamental charts. Must have done in class 10th as well, right? Generally, must have encountered this chart, right, where students' marks displayed as pie chart. So that's a possibility. Okay. It is a circular statistical graphic used to show distribution of 100% of something total, right? Isn't it, guys? So pie chart can be used to show, how you are getting the total sales value, right? So we have this, whatever, DF store, this data, and then we know that we have sales, then we can just do a sum of it. And you know that total sum of sales is what? 2297, whatever. So it is how much, by the way? $22 million. No, sorry, $2.2 million. Isn't it, guys? You can do this. So 2.29. So this is how you can convert into scientific notation, 1E6. So I've divided by 1 million, which is 10 lakhs. That is what I'm doing here. 1E6 means what? Actually, I've divided by 10 to the power 6. Isn't it, guys? Come on, to convert into millions. So these are the things you can do all the time, all the day. So $2.3 million of sales you have done. Similarly, how much is a profit there? That will be just 0.28 million. And if you want to do percentage of it, so you can say, so this is your profit. Then you can say how much is total sales, and whatever this number, you can see, you can multiply into 100. So 12% is the margin there, right? Profit margin. So if I sell 100 USD, I'll get 12 USD, right? Not bad, isn't it? Now, if I want to show how this $2.29 million is distributed across different categories, I think we can do that. So let's take it as a task. So let's show that how is the total. Let's show the distribution of total sales and total profits by categories. Isn't it, guys? That's by categories, no, by subcategories. First, let's do by categories. There are 3 categories. Isn't it, guys? Come on. That's something we can do right away. Makes sense. So now, guys, let's get into the plotting. So plt dot figure size, plt dot figure of fixed size equal to, let's take more like a square there. Okay. So I'm not doing plt dot subplot, right? If you have observed, I'm just doing plt dot figure, just focusing on figure. Let's talk about data. So data can be df store, okay, and let's take total sales. Sorry, not total sales, just sales, okay. But we have to also prepare the data this time by category, guys. So let's say df store category cat. So you have to do that grouping. I mean to do this. So you have to do group by what? You have to do group by what? You have to do group by categories. Hold on, guys. I'll do it right away. aggregate, and then you can go on the top, and I have already put that aggregate somewhere here. Yeah. So let's not write the same thing. Dot aggregate should be good. Reset index. Okay, so it has not come. Okay, guys, should be good. Now you can just plot it. You will see three categories and their values. Can you see that, guys? Profit. Okay. Now you can also plot it here. So you can see that DF store cat, that will be your total sales. So let me do total underscore sales. So this is your data. Okay, fine. It ran. And now I need my labels. Okay. Labels of the category, right? In pie chart, you want to give label, right? So DF store cat, and this will be my category dot. It should be unique anyway, but I'm just saying. Okay. So this is your unique labels for your chart, for your pie chart. This is also good. Now I'll go into plotting. So data prep is done. I'll do plt dot pie. Then I'll go into my data. So data is data, which is my total sales and my labels. Okay. Then angle. So start angle can be 0 degree by default, but I want to start with 30 degree. Okay. Shadow is true. Perfect. Can't multiply sinkers by non-int of type float. So what is the data? So you might encounter some issues. That's all fine. Can't multiply sequence with non-int of type float. Where is the issue? My level. Okay. My levels. Let me check that. Okay. I guess I need to tell it very clearly. Okay. In pie chart. Okay. I let me try that. So there should be levels equal to, yeah, my levels, right? And since it's showing a lot of things, you know that what you have must have missed. It is PLT show. Good, guys. Interesting. So you have to give you. So now I know you might be thinking he's not even telling me syntax. So go into documentation. Yeah. X is your data. Explode is like taking that more like a pizza slice coming out, more like segregated view. Levels is levels. Colors is color. Auto percentage is like for formatting. So you can do this. Let me show you. So auto is what? It's more for auto percentage. You want to give some percentage, excuse me. So you have to just use this format percentage, 1 decimal, float percentage. That should be good. So that's the syntax you have to keep in mind, or you just Google it when you need it. Don't worry much on it. Right, guys? Can you see that? Now the percentage has come. Now, if I just make it go away, not like this, you will understand. See, there was no percentage. If I put, so it also shows me the distribution. Hello, guys, come on, interact with me there. Can you see now that more or less all the three categories are doing great in terms of sales? Be it technology, be it furniture, be it office supply, they are doing great. All my three categories are doing great. Okay. That is what doesn't tell you. Now you might be wondering, what is the start angle 30 degree? So what is your first data label, guys? Your furniture. Now focus. What is 0 degree here on this line? If you have done basic of geometry, this is your 0 degree line now, horizontal line. Do you see that the starting angle of blue color, which is your furniture, is making somewhere 30 degree? That's your rotation. So if you're not interested in that 30 degree, you can say to me, sir, can I get it into 0? Yeah. So now the furniture will start from 0 degree, guys. Can you see that? So that start angle does for you. Is it okay? Hello? That's what start angle does for you. Okay. Now you might be seeing that shadow has been true. If I just do shadow false, see, you don't see any shadow coming now. Shadow is just to make it more beautifying, right? And see that shadow is coming there. Hello? Then you can do all those basic stuff, title, label, right? All those things. I don't want to do it here. Okay. Now, generally students will also ask me, sir, can I also explode it? So you can explode it. And for that, you have to use my explode equal to you explode. Not don't explode the furniture. I want to only take away my office supplies. So I'll explode it by, let's say, 0.1. See, so I have three categories there. If you see, I've created a list there. I have created a list there. 0 means I'm not exploding. This I'm exploding by 10%, and this I'm not exploding. And now I will go in my plt.py. I'll say explode. That's a parameter there, and I'll say it as my explode. Are you guys able to follow? Can you see that? Suddenly my office supply is exploding. You can change. You can make it the furniture to explode and office supplies to not explode. Can you see that? Now furniture exploding. Hello? So this is what I mean by explode. You're taking that part of the pie little separated out by some number, right? And that number is 0.1. If you want to make it bigger, then it will look very awful. See, it looks like this guy is going away. It's a tectonic shift. It seems like a tectonic plate movement. Huh? So Earth is dividing into, I don't know how many groups now, right? So generally people don't do that. People do 0.05 or 0.1, 10% explosion. Are you able to follow, guys? And there's nothing more than that. Okay, you can think of multiple pie charts. You can do that, right? You can create multiple pie chart by sales and revenue by creating, 2 by 2 matrix, sorry, 1 by 2 matrix or 2 by 1 matrix. So you can create 1 row, 2 columns, right? Something like this. For that, you can use your subplot. So you can see this is my one pie chart. This is will be my other pie chart. You can access this canvas and place this pie chart here. You can access this segment and you can place some other pie chart here. So all these things you can do as you wish and you want to do. So I think, see, charting, there is no limit. That's what if you remember my statement, I'll definitely teach you visualization in a very detailed manner, but there is no limit, right? Someone can come and say, if I hover here, it should show something, right? So that's all Plotly can help you to do it, or some other libraries. But that's not, I would say that's pro advanced charting. But idea is that basic Python charts, that's where you start. Okay. The next topic, I'll do it histogram. I think histogram is something which you have also done. Uh, I think class 9, 10th, where you were doing those manual histogram. Remember that? So you're looking at the data, creating the frequency in the bins, right? And basis that bins, you are counting how many digits are repeating or appearing in that bin, and that becomes the frequency. Okay, like 0 to 5, 5 to 10, 10 to 15, likewise. And then you were able to populate your histogram. Good, thanks. Yeah, thanks for support. So histogram is something which you have seen it for a long time. So what is a histogram? It's a visual representation. Let me give you a couple of pointers there. Is a visual representation of data that is organized into groups. In business, they call it as bins, binning. Concept is binning. Okay, displays numerical data, guys. Keep that in mind. So whenever you're trying to see how the data, numerical data is distributed, you do that, right? In principle, it is a bar graph, right? It is a bar graph. So inherently, it is a bar graph with x-axis representing bin ranges and y-axis representing frequency. You might be trying to explore your data, a column of numeric nature, and you want to see how that has been distributed. Okay, so how is that data distributed? And that's where you want to plot it. Okay, so if I can show you the same plot for the histogram itself, sorry, for the superstore data itself, you will understand what I'm trying to say. Let's do a plot and then try to break it down from there. Okay, so I think starting point, it would be the same. Okay, so you can copy and paste a bit of the code itself, right? And then these things you can remove because you have to use histogram specific function. And you have already in here, as you can see, X is your numeric data or column. Bins is your binning, 0 to 5, 5 to 10. Okay. And then other things I'll tell you, it's very simple: color, width, alignment, everything. So let's not get overwhelmed with a lot of parameters coming there, a lot of arguments you can actually fit in there. So let's see if I take DF sales data aggregated, and in that I take total sales. So this is not aggregated one. Let's see this one. So we can use this one, guys. Okay. Our choice. Ideally, it depends how do you want to explore your data. Okay. So this is your total sales. Color you can select of your choice. You can say blue. You can write full bins. You can say, you can also give bins explicitly that I want just 10 bins. You can also give edge color. So between the bar, you will see some colors coming just to beautify it. So you can say gray or something. Should be good. Okay. And if I can make it, my bad, I did it ulta. I should do this 10 by 6. Are you able to take a quick look at it, this guys? So I know you might be thinking this is super easy. It is super easy. Chatting, I have told you a lot of time. It looks overwhelming, but you have to just start with common sense. Common sense is that you need to find a numeric data. Total sales is what? Numeric data, as you can see that. Total profit is numeric data. Color is blue. Bins is 10. You can see there will be 10 bars. 1, 2, 3, 4, 5, 6, 7, 8. And this is also a bar, but there's now no data, and 10.
Let's have a quick quiz question, guys. And the question is, which of the following is used to measure the variability of dataset? And your options are mean, median, mode, or standard deviation. Please mention your answers in the comment section below.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
You want to expand it to 15, you can also do that, right? So now you will see there are 2 different clusters. So binning also helps you to identify cluster within the cluster, right? If you just give 5 bins, you'll see nothing is segregated. Can you see that, guys? So everything looks like, okay, it's continuous, but the moment you go into the right slicers for the binning, that you can look at the data and do it. So you'll see that, okay, this data looks like, some of the sales value are like amazingly high. So if you look at this $120,000, which is happening right somewhere here. So total sales, do you see? Look at that, 118. So that will come in this range, right? But there are not a lot of sales like that. So 118, and you can also see the frequency is only 1. So this is your frequency. This guy has only repeated once. So this sale has only happened once in the history of 2 years. Can you guys see that? So it's happening in row 14. Can you guys make out? And it has just happened only once. So might be something special, some season, something was running. That's why you had some bombastic sales happening, right? But generally, if you look at here, the binning is telling you that, okay, if you exclude this guy, more or less, maximum numbers of sales are happening in what range? Generally from $20,000 to $60,000 or $80,000. But the highest sales was around, whatever it is, 40, 50,000, 50 grand. And you can also make out from the average. So if you take an average of this guy, what is the average sales across to 2 months? So you can do this, right? Total sales dot sum. So, right, what is it? Because of this guy. So if you exclude it this month, which is 2018-11, so you find median rather than, sorry, average. I did sum. I'm an idiot. Sorry. Yeah, even if you look at it, right, 55K, right? That's what I was telling, somewhere in between 40, 50. And if you find median, then you will understand that it is going to give you a similar picture, a better picture, 52K. And that's where the highest bar is coming. Does it make sense? So guys, histogram starts with, your data and your column, okay? And if you focus on, what is the data you're looking at? So total sales, okay? Now you might be interested to also show total profit. So what you can do, you can just select total profit, okay, right? So you are also able to see that this is more or less in line with what you're looking at sales. So sales and profits, it seems to be a more correlated. You have also some extraordinary sales happening, 18,000 grand, right? And couple of sales happened in that bin, right? So if I look at the syntax, it's pretty simple. I will show you one more time the documentation, guys. Okay, and let's take a look at this. Okay, so plt.hist x bins. Okay, so x is your numeric data, bins is something which you have already highlighted. Density range, you can decide what is the range you want to, put in there. And then guys, it's all about you to explore this. Okay, so you can give range, you can also plot density. So density is nothing, I'll show you, it's very easy. If I go back in my this, if I say density equal to true, it's a Boolean flag. If I can look at the density, so density is going to give you what? Just read about it. I was expecting the distribution, right? If density also true, then the histogram is normalized such that the last bin equals to 1. So what is doing, guys? It's more like a normalization, guys. Ideally, we don't use it, but there is one more kernel density I'll show you. I'll use some other library for that, and we need it all the time, to be honest, and that is coming from Seaborn. So let me show you this here, and it's going to be one line of code. So you have already SNS is Seaborn, so that I can to quickly tell you. So suppose you write total and then you do tab. Don't do control plus space. I'm using Jupyter Notebook. I do tab and then I understand that what is it. Okay. Now guys, I'm plotting histogram. Please pay attention. Histogram using Seaborn library with density curve. So don't confuse this density with the density you have seen. Okay, that's more like normalization to convert bins into, the bins into one. So the scaling changes altogether there. So now what I have to do here, I have to just use SNS dot hist. I'll use my data equal to what? Month here, total sales. Okay, and then there is a parameter called kernel density, KDE. KDE is what, my dear friends? Let me write. KDE means kernel density. So it tries to fit a density plot, just like you must have studied in random variable probability density function. So like that, okay? So kernel density, if you say true, now I will see that. So guys, I've not put any size or anything. So you can see, right? It's the same plot, right? Then you can decide the bin. I think let's go into it, right? Bins is equal to auto if you don't put anything. So let's go there and put bins equal to 10, and then you will see, right? So can you see that, guys? It's try to fit that density curve. Have you seen normal distribution? Similar kind of curve it's trying to fit. Okay, and then you will understand that the peak or the mean of that density is somewhere here, sitting here. Okay, guys, are you able to see or not? So what I have done, this is very, very interesting thing. So you actually can not only plot histogram, my dear friend, you can also show that where the peak of the density curve is happening. So guys, this is all about histogram. Yeah, I think you can do any number of things on histogram, but this is what I suppose I thought I plan to teach you, keeping this topic in mind. Generally, this is what we do. So you can do n numbers of overlapping histogram. So you can create a density curve for one chart, one column, right? And you can also superimpose other, then create that hypothesis kind of stuff. But that is all advanced and not required all the day. Okay, 99% what I have told you, that should be enough. Okay, but yeah, that's where you will build on top of it. Okay, I think I also talked about subcategory, right? So this is category, right? This is category. So if I say subcat, if I do a data prep subcat, so how will I do it? Df store sub, this is not the complete data, sorry, dot agree, sorry, dot group by, what are the columns? Sorry, I keep forgetting the subcategory. What is it? Now guys, please pay attention. So I want to group by subcategory dot aggregate, and then again I'll do the same, total sales, total profit. So I'm going to go top and leverage that line of code. I'm not in mood of, yeah, so I'm not in mood of writing it again. So I'll do this and it should work. Yeah, it worked. And let me print for you guys. So can you guys see that for yourself? Hello, everybody. So I'm doing an interesting thing here, right? So you can clearly see that this is the data frame prepared at the subcategory level. Same data, preparing at different level. Can you see that bookcases is negative profit, means loss is happening, no profit, bleeding. So this category is not doing great. Supply is not doing great, and even tables are not doing great, isn't it, guys? So there are three categories which are highlighted as losses, isn't it? Okay. So now if I want to plot this, so what is my ask? So my question is that, can we show the subcat level profit and do highlight subcategories where the profit is negative? Okay. Isn't it? That could be a question for your business. So I want to show the sub-level profit, and at the same time, I want to highlight the subcategories where the profit is negative. So in simple English, I want to say highlight bookcases, highlight supplies, and highlight tables to be negative. Isn't it, guys? That's what I'm asking you. So you know that how to create a bar plot, right? So let me see. See the way I'm going up. Why I'm going up? Just to leverage the codes I've written somewhere. This is it. So I'll come down. So you already have it. Or I don't want to use this this thing. I want to just use plt.bar. So you can quickly go away from one to, switch over from one to other options. Trust me. It's so easy. Once you are at my level, you can definitely do this. Trust me on this. Okay. Now, guys, what I've done, I have just taken this bar. Now I have to just take the right data frame and right column from there. So see how I'm doing. So I'm taking, what is it? Subcategory, right? So this is my x-axis. And then I'll say, I want to show what? Total profit. Color is, let's take a sky blue, that's fine. Title is total profit in dollar by subcategory, guys. Come on. X-axis, subcategory. Y-axis, total profit. Good. Let's plot and see. So let's say profit is green. Now I know it's not justice because you are also showing negative profit per bookcases for supplies and tables, isn't it? Everybody's comfortable so far, so good. Now I want you to highlight this bar, and this bar, right? Business might say, can you highlight in the chart that wherever we have negative, give it some different color? Hello? Could be a requirement. Can I have different colors for different categories? Different subcategories you can also have. But ideally, what we are trying to answer here, that put all category in the same color, because that's the design principle. Trust me, you generally don't use all the colors, 6, 10 colors. In business, in charting, in visualization, we only use 3 or 4 top colors. Not all the colors, my dear friend. Okay. So if I can tell you that we can do it, any idea, by the way, how will I do it? So that's where that you take all the categories name and give some color. So green, 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 here you put red, right? But you can do that. The other way is that identify wherever you have negative values. So what I'm going to do here, I'm going to put a color dynamically. So this is your playground. So what I'll do, I'll show you something, by the way, first. So if I say np.where, you have seen this np.where, very important. So it's a condition coming from Numpy. For a data frame, you can go in that data frame, which is a Pandas data frame, subcat, and you can say that total profit is wherever total profit is negative. So it will see array 4, 15, and 16. 0, 1, 2, 3, 4. Array 4 is negative. Array 15 is negative. Array 16 is negative. We are giving the indexes, giving the indices, right, guys? Come on. Now using this, if I go and I say that this is my criteria, color criteria equal to this, right? Perfect. And this is a Boolean flag, and I can go there in color and I can say wherever it is negative, I can say red, and wherever it is positive, see, it is green. So I've added just conditions there. Okay. If you focus, I can print you here and show. See, so now you have gotten a color series, green, green, green. Can you see red happening? Then green, 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 red, red. Do you think it will work now? Yes, it will work. Now you can use color criteria in color. Bingo. right? I know width is not that great, so I'll increase the width to 5. Did you like it, guys? I made it very simple, but it's a very, very important business problem that we solve all the day. Cool, guys. Everybody's easy. So that's other. So there are a lot of things you can do, right? You have to just frame your logic. Coding has limitless possibilities. Okay, coding has limitless possibilities. You can do n number of things. Now, guys, I'll go into next plot. So this is not a new plot. This is just, I remember that I should also tell you this from bar chart. So I went into bar chart again and told you this. I think I did not discuss with you guys, right? This example, because that bar chart I got on the sample sale, right? Sample sale data. That data did not have this characteristics. So I could not show it to you there. Okay. Now scatter plot. Scatter plot is another important plot whenever you're doing any machine learning model, or you want to establish any relationship between the variables, you use scatter plot. It's a 2D plot, guys. So let's talk about it to show the relationship between the variables. To show the relationship between the variables, that's what we do. We use scatter plot. So it plots what? Data points on horizontal and vertical axis in order to show how much one variable is affected by other. So linear regression, if you have studied, or I don't think you have studied by now, when it is happening, machine learning for you guys, any plan for that? So there you will be using scatter plot like anything, like a lot of time you use scatter plot. So this is how a typical scatter plot looks like. So let me show you one image quickly. So now guys, you guys can see that you have x-axis, then you have y-axis, and on x-axis and y-axis, you can see, right, you have some data points. So you can understand that you're trying to find some relation, not necessarily every time you will to find some relation. So looking at this data, it doesn't look like it's very much related. Okay, not necessary. So in linear regression, if you see, you have an x-axis and y-axis, and then you have a data like this. So let me show you some data points like this. This is also a scatter plot. So you can clearly see that if x increases, y is also increasing. Can you guys see that? Something like this. So x increases, y increases. So for example, suppose if demand increases, price increases, right? Let's say cylinder gas these days, cylinder gas price is increasing because a lot of demand is coming. Our population is ever growing, right? So demand increases, you don't have a lot of resources, you will be putting a lot of price there. Or some other example, you can think of 10 number of examples there. Okay. So let me show you the scatter plot syntax. Okay. So again, I'll use the same PLT dot. So I'm using this, standard approach of matplotlib. PLT dot, I'll do fixed size. Okay, I can do 8 by 6, and I'll use PLT dot scatter. Then if you look at the syntax, guys, the documentation, so PLT dot scatter, yeah, PLT dot scatter, you will see x-axis, y-axis, right? So you'll see x-axis, y-axis. Padmanabhan, we can also use PLT dot figure. So PLT dot subplot actually gives you a lot of power. It's an object. This is more like a function within that class. PLT dot scatter is what you can show. I would say df, I don't know, it's df store. If I say sales, so I want to put sales on y-axis, x-axis, and then I say df store. This is too much of data. Let's see how does it look like. Profit. So this is the original data, guys. No no aggregation. See, if you just do this, you will see that PLT dot figure, something I'm missing. I think parentheses I'm missing. Wow, it looks so awful, right? So because of the outlier, you don't see any relation there. Okay. So what you should do, if I just remove any sales which is more than 8,000, can I do that, guys? Yes, I can do that. So exclude outlier. A lot of outliers is not letting you see anything. So that is something you will also learn. df store, and you want to say sales should be less than, what is the value I want to freeze on? 6,000, right? That's it. That's my criteria. And if I just go there and put it here, see, that's a smart way of doing the things. Did you notice how fast I did this? So that is something you have to pick it from me as your trainer or instructor. So I put a criteria. I've just used that criteria. This is what we call it masking, masking your data. Can you see that there is some relation? So if you look at that, not highly correlated. So you cannot say that your sales is highly correlated, profit is highly correlated with your sales, but you can say that as your sales increase, right? This is like, not very like this line, right? 45-degree, right? This is line like 15-20 degree, which means that it is indeed correct that if your sales increase, your profit also increase. Can I say that, guys? Hello? Excluding the outlier. And that's true, right? Sales is somehow related to profit. So you would be expecting a more like a straight line that's coming, right? But the slope is not that steep, So that's what I'm trying to highlight here. Okay. Okay, now you can go into it. You can say color equal to I want green. So you can take green. Then you can also say 100 size. So 100 is too much. We can do 30. So you can increase the size, right? You can also make 1. Guys, did you notice? So the size of the bubble can be controlled here. I would say 15, right? Guys, keep keep following it up with me. Now this is an extension of scatter plot bubble chart. So guys, let's talk about bubble chart. So what is a bubble chart? So bubble chart is more like a scatter plot, but it's a 3-dimensional plot. So if I can show you one bubble chart quickly. So this is a bubble chart. So ideally it is a scatter plot, but can you see that? So see, you have an x-axis there, my dear friends, please pay attention. So this is your x-axis, this is your y-axis, right? So 0 to 50, this is your x-axis, this is your y-axis. So you have 1D here, this is your 2-dimension. The moment I say bubble chart is 3-dimension, people say, what are you saying? It's wrong. What if you observe clearly, you can see that you also have size of the bubble. Can you see that? So you can put your third dimension, hello? So you can put your third dimension in the size of the bubble, hello? So size of the bubble will tell you that this, if you focus on this guy, the green guy, you will say it is having, if X is high, Y is also high, can you see that? And let's say it has some Z is also high. So that's why you're trying to say X is high, Y is high, Z is high, then this is your green variable. But if you look at this one, this yellow one, here you will say Y is high, X is not that high, and Z is also not that high, right? That kind of value add, you can get it from this chart. So bubble chart is very important to show 3 variables in one chart. Okay. So let me put it in our notes. And if I go back, so guys, it is now part of our notes. Now what I'm trying to propose here, if I take the DF store data, let's do some magic there. So what I'm going to do a scatter plot of total sales and total profit, and I'm going to put the categories as well. Okay, so hold on guys, give me some time. So now what I'm trying to say that I have this data, subcategory level data. You have this data, guys, come on. So we have total sales, we have total profit, right? I'm going to put it on our x-axis and y-axis, and I give subcategory as a color to this, and I also tell the size of the bubble as profit, right? Total profit. So how will I accomplish that? Let's work on it. So I'll start with our standard plt.figure, okay, and figure size equal to 10,8, and I'll say plt.scatter, and you already know, right? df underscore store subcategory. X-axis you put your profit, this time y-axis you put total sales. Okay, just hold on. So if I show this, and then I also do size, so this is your by default size. If I do 100, you will see, if I do 100, you will see that, okay, size of the bubble is, it is showing something, right? Okay, so now you see that there are some 100. So now you will see there are 17, and I'll do this plt.show. Now please pay attention, everybody. Now you might be interested in showing, that each of these bubbles has different colors for the subcategories, right? That could be a thing going on in your head, right? So let's do that first. So let's say color is what? DF So now put color into the category. How can you do it in PLT format? Okay, subcat, and you can take subcategories. This is your subcategories, but guys, this is not a category, so you will use cat dot codes. Now, few things we need to do here. Can only use cat accessor with the category data type. So this data type we need to change first. Yeah. Now you will learn an important thing here. If I show you the data types for this guy, you will see that subcategory is an object, but it's not a category. So if it's not a category, it cannot use this category codes as part of the color. So what is the resolution for that? You'll go back and you will change the data type of this guy, which is subcat. Okay. You will take this. Let's create a new data type, new column subcat. You have subcategory. Okay. And you want to convert into what? Categorical data type. So you will convert it by using pd.categorical, right? So I'll also give a comment here. Created a categorical variable. See, now if I go back and do data types, you'll see 4 columns. Can you see this is the same data? I can also print it, the whole thing. It's same thing, accessories, appliances, but it's a new category in itself, right? It's not the object data type, the general object string data type. It's a category data type. So what you can use this column, which is subcat. Don't use the original column. See, use this column and you can see the magic is there. These are small, building blocks which you are learning. And you can think innovative ways to use it. But did you guys understand? So sometimes you want to put dynamic colors of your choice. Automatically it will assign some colors. Now you will say, no, I want to assign my color. That's super easy. That you can say, what is the category? Accessories, this color. Art, that color. That way you can also decide. But is it clear, guys? So far, so good. So this is your color on the basis of category, dynamically assigned. Now you have some color map theme, right? So CMap, if you do a documentation here, so you have a CMap. CMap is more like your color palettes, okay? So here a color palette is Z, right? So if I give a Z color types, it will pick some colors from here, okay? So CMap is what? Color mapping. So that gives you range of each color map, okay? What type of data is category? So this is itself a data type category. It has taken it as, as a string and an object. So category is what? This is category itself. No? So you have some classification in the data. So some of the SKUs will be part of one category, like appliances will be your washing machine, TV, fridge, right? That's one category. Data type category is in Python defined as in Pandas is that when you have levels of categories. So when I say level, doesn't mean like 1, 2, 3. It means you have a categorical level, right? And you assign it. So if I can show you this part of the code, you will understand a lot. So you have categorical codes here. So what it has done, this thing is what you have categories, 16 categories. It have converted into codes because the color schema will only work on numeric things, right? So that's how it has converted into codes to get you used into different colors. But category itself means what? You have different SKUs under different category, and you are putting a basket here. So like, for example, if I define category from the data perspective, like, all the appliances like electricity, refrigerator, washing machine, mixer, grinder will be part of one category called appliances. Mobile phones will be all the mobile phones in one category. Data type category is going to accommodate that exactly thing. Okay. Object doesn't tell you category. So it depends on the variable, right? So you have a categorical variable, your data type will be category. In R, it also known as levels. Okay. So suppose you have a data set and it has category column and it has XYZ. So XYZ is your categorical levels there. Okay. Okay. So date is also a data type, which I discussed about yesterday. Okay, guys. So this is something done. Good. Not bad, right? So different colors have come now. Now size is also, I want to make it dynamically. Now this is another thing you will learn. So let's say size, I want to give size as per the profit. So for what generally people do, we'll give some scaling there. So what you want to do, you want to divide the total profit by 10 or by 30. That is something you're doing a sizing on the basis of profit. on the basis of profit. Okay, and now this size we'll put it here. So now what we will do, you can see the magic. So you can see the magic. You have different subcategorical thing, right? You are able to show that you have a bigger bubble, you have a smaller bubble. So bigger bubble will have more profit. Now homework will be to add the legend here, right? So now definitely legend will be a big list. So you can think of adding a legend there as well. Okay. So you can go there in the documentation. You can talk about if they give you the labels or some information on legend. Generally, scatter plot directly doesn't get you that, but try about it. Which you can improvise this. So I want colors. This color, what subcategory, right? I don't know that. Makes sense, guys? So something. So that is my choice of sizing. So if you don't put, you just put one, it will be so big that you can't see anything. Can you see that? So that's where you have to be smart. So one means what? You're using exactly the profit as the size of the bubble. So that's where you want to normalize that. So normalization is what? You will divide with some number. So I thought 30 will do good. You can also think of another numbers. You can do 10 to make it more emphatic. Okay, clear, guys? So that's all on the charting. The last chart here would be box plot.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Because without box plot, I cannot finish it. So box plot is something have already been talked about a lot of time. Box plot is nothing. It's just statistical plot, a graphical way to show the distribution of the data. Okay, so I'll come to this image very soon, but give me some time. So what is it? It's a graphical way to, again, to show the distribution of the data, to display the distribution of the data. Here we have also called it as 5 numbers summary. You have already seen it, let me tell you. So number one is your minimum value you show here. Then you show first quartile. Please mind the spelling. Quartile, quantile, people also do that. So first quartile is also known as Q1, capital Q1. Second quartile is known as Q2. Third quartile, also known as Q3. Don't say fourth quartile. The last one is maximum. So this is your 5 numbers summary. That's what box plot gives. So if you look at that data, that image, where is my pen? So if you look at that plot, that chart, that image here, so you have this box plot. So this is your minimum data point. This is your maximum. So this is how the data is there, right? Data is being distributed on this horizontal line. Now you have a box there. So box is actually for Q1 to Q3. Also call it as 25th percentile to 75th percentile. So this is your first 25, second 25, third 25, fourth 25. So 25, 25 is 50. That's why this is your median will come here. So 25, 25, 50%, right? 25, 75, and then another 25, 100%. Clear? So this chart itself is very, very explanatory. Interquartile range is this, so which is Q3 minus Q1, and outlier is outside these whiskers. Can you see there are some data points which are like outliers? And to calculate outlier, you have to do what? Q3 plus 1.5 times IQR. What is IQR? It is Q3 minus Q1, which you can do that. Because if I don't show you, there's no point discussing it. Now, what is the application of this guy? So it is used to identify outliers in your data. Very, very important. Statistically. Also to determine if my data is, data is skewed or not. So to check the skewness of data as well. Overall, to understand the shape, range, spread of the data. Okay. Guys, if you recall, I have taught you guys DF store, and you can do describe. This describe itself tells you about 5-point number summary, right? So it will pick all the columns of your numeric nature like profit, quantity, sales, and you have min, you have 25, you have 50, 75 max. This is your 5-point number summary already coming in describe. So you don't really need a box plot, but box plot is a visual layer to this. It is really helpful. Okay, makes sense, guys? Now, if I want to show box plot, right? So I'll be showing box plot using Seaborn. So other libraries. the second one which I keep talking about. So I'll do visualization using visualization of box plot using Seaborn. I also use some other data. I'm running out of time, guys. Okay. Now, guys, import. We have already imported. So I'll set the style sns.set style to be dark grid. So I'm changing the style of my plot. Yes, come on. Now I'll take a data. Data is df iris. Iris data is very famous data of flowers. So we have to use SNS load data set iris. So you should be able to see this data, guys. It's a data which talks about flowers. So you have 3 different species of flowers. It is Setosa, it is versicolor, and virginica. So it's a botanical data coming from research. So this data is talking about you have 3 different species of flowers. Can you please focus? And you have Setosa, you have versicolor, you have virginica. And then you know that if you have studied a little bit of biology there, you will know that so you have sepal and you have petal. So petal is like this part is known as petal. Can you see that? This part is petal. And the extended part is known as sepal. I'm not very good at it, okay? So don't judge me on my biology. So this is about the data. So this data is a category wise. If you see, this data has 3 categories. So guys, please run these lines of code, and ideally you should be able to run this and get the data. Everybody is able to print this. So these are your 3 categories: Setosa, versicolor, virginica. Can you focus? Import first line of code before you run this. On the top, import Seaborn as SNS. So now, guys, I'll do a quick box plot. It's very easy. We'll do SNS dot box plot and y equal to df dot df iris, and you will do sepal whatever length or width. See, similarly you can do for guys. Need to spend some time on object oriented programming as well, so let's be a little mindful about time. So this is length. You can also do width. So you can see in width you have some outliers. Can you see these 3 dots? That's outlier. This is your outliers. Now you might be interested in plotting these 2 guys together. You want to compare side by side. So you know that 1 dimension means 1 square braces. You want to go from 1 dimension to 2 dimension. So what you can do, you can put 2 square braces. df underscore iris, sepal length, sepal width. What is the error? Let me do it again. SNS box plot, then data equal to df iris, sepal underscore length. I might have made some column spelling mistake, some syntax error. It should not happen. Can you guys see that? Now you're plotting both sepal length and sepal width side by side, just to compare. So you can clearly see that, okay, now looking at this chart, I can make sense that median width of median, this is 6 inches, right? Around 6 inches. Sepal length, median length in centimeter is 6, but sepal width is on an average, it is around 3 centimeter, isn't it, guys? So that kind of way you can understand, okay, sepal width is smaller in size, sepal length is higher in size, length is always generally higher in size. Then you see that there's no outlier here, and data is very nicely distributed. But this data is little spread out. Can you see that? That's why the size of the box, the thickness of the box tells about the spread of the data. This sepal width, generally all the numbers are like very close to the median, and that's why the size thickness of the width or thickness of width of this box is really very small. Can you guys see that? So that also explains about the size or spread of the box plot, isn't it? Did you understand what I've just mentioned? So that kind of insights you can derive. Okay, now you can also do that. I want to do category wise. Okay, you have 3 species there, right? Now you want to do for one sepal length, right, category wise. So what you can think of, that's where SNS box plot, Seaborn box plot is amazing. So you can say that, okay, my X is what? My category. That's where you have to be very careful. Category is what? Species in the data, right? Species. Your category is species. And now on Y, you want to put your one of your measures, numerical measures. So what is that? You will say, I want to just see sepal length. Okay. And then you will see magic. Now you are seeing that you have three categorical information coming. So you have three category of flower, setosa, versicolor, virginica. And in that, you are plotting sepal length on y-axis. You can also reverse. So now the category will come here, the sepal length will come on x-axis. So x and y-axis, you can always transform, you can transpose it. Now you can clearly see that the virginica is having the highest length in centimeter. Can you see that? And setosa is not having a very big spread about the length. But these two guys are having similar spread, right? If you focus, and the median is right here, it is almost in the center. This is shifted a bit. If you focus, you'll understand. So that's that kind of intelligence you can get it from the box plot. So guys, let's talk about quickly inheritance. So guys, inheritance, it's a very simple English word. So whenever we talk about inheritance in Python, right, in object oriented programming, okay, so the funda is very simple. Just like you inherit your property, your assets from your parents or grandparents, classes also inherit sub properties from the parent class into the child class. Okay, so let's say you have a parent class and you are inheriting the properties of the parent class into a child class. This is what we call it as inheritance. So generally the existing class is going to be a base class or parent class, and some of the property you can actually extract or inherit in your new class, which is going to be the subclass or the child class or the derived class. Okay, so subclass, child class, derived class, all these are like a lot of jargons in OOPS, but trust me, this is all same. So whenever you have a parent class, you are inheriting some properties, and properties can be a lot of things, right? So you want to use some of the their their code blocks from the parent into your child, so that way you can use it, and that's where the reusability of the code comes into the picture, right? So generally the main purpose of inheritance is the reusability of your codes. So idea would be that you make sure that you inherit a lot of properties from the parent class into the child class. Don't write everything line by line, the same thing just to get the same job done. And that's where what I'm trying to say here, right? So inheritance main property is to reuse the code which you have already written for your parent class, so that you are creating a new class for some job and you want to use some of the part of the code. So that's the basic funda here. Okay, so let's take an example, then we will understand. Okay, so let's take an example. So first thing first, I'll create a base class, guys. So let's say if you are present in my older like series on this, oops, you might be seeing that I always use vehicle as a class. So vehicle is a class, and the vehicle can have different attributes like car, you can have a truck, you can have a JCB, right? But everything is vehicle there. So now in this vehicle class, I am having a function which I'm defining as vehicle underscore info, and I will use self method, right? And I just print here that this is the parent class or the base class, parent or base class. Now what I'll do, I'll also create a child class outside this. Now the moment you try to create a child class, you will use class. You can say car. Car is a child of vehicle. Can I say that? In terms of hierarchy, guys, come on. So if I just show you this image, parent class is your the higher hierarchy, child class is your lower hierarchy. So if I say car is parent of vehicle, just understand this. Then to initialize it, you will not use anything like colon. You will use vehicle within the parenthesis. That is something you have to be very careful. So if you focus, I have used the vehicle as part of your car. Can you see that? So I'm defining class car using the vehicle class. Okay, and then I will define car underscore info. So info about the car. So another function, another methods, and then I'll say self. I'll print this is the child class car. So now this is the job I have done. So this part of the code is going to get you the class vehicle. Within that vehicle class, you have a child class called car, or subclass called car. I want to create an object. Let me also give comment, else you will get confused. So create object of car, which is a child class. So I can create that object. So this is an object, okay, and I'll call it as car. Now what I'm gonna do, I'm going to access vehicles info using car object, isn't it, guys? Come on, focus. Ideally, you want to access vehicle information, you have to use vehicle class, right? Here I'm using, right, car class. Can you see that? This is what I've defined here, guys. Come on, car is your class here. So I'm using car class to get the information of our vehicle class, which is my parent class. And I can say object underscore car, and I will print vehicle info. Now this is the moment of truth. Can you guys see that this vehicle info is under which class? Can you guys see that? This is under vehicle class. But since you have created a child class using vehicle as your parent, right, you can still access using car class object, you can print the vehicle info. Do you notice that? So this vehicle info is sitting here, right? That vehicle info you are calling from the car class, which is your subclass. Is it clear? It's a little bit tricky part, but if you focus, you'll understand. Now, if I just run it, you will see, okay, this is the parent or base class. So I just printed this information, which is coming from the block of parent class. It is not within the child class. But since you're creating a child out of your parent, you're able to print that. And definitely you will be able to print what? Object underscore car. You can definitely get your car info as well. That's anyway gonna happen, right? So this is about your inheritance. So to run something from this function, let's understand it. To run this function directly here, you can do this. Then you have different types of inheritance. I will not go into that. It's all easy. So you have multiple inheritance. So, right, you can have multiple parents here. So you have multiple inheritance where you will have one child class mapped to two different parent class. So you can clearly do that. So generally when you're doing this, right, you can have some information sitting in your parent class about employee details in parent class, right, person info, and then you can have company information in company class. That could be the parent thing, right? So you have an employee there, right, and that employee is mapped to the employee information, which is a parent class, and the same employee can also be having some information for their companies, right? So that where you can use those kind of information. So directly when you're trying to code these things, you will understand. Now, in the interest of time, guys, I'll talk about the last bit here, which is your polymorphism. So let me quickly get into it. Not polymorphism, polymorphism. So guys, polymorphism can be thought of, one object is having different properties, right? I have very good example to show to you guys. Okay, just give me a sec. I'm just looking out for that image quickly. So generally I take this example for a girl here, right? And thanks to the guy who have created this. So polymorphism is more of like a funda, and that could be any person here. So you can take Sakshi or any girl in our batch. So she can be an employee role, right? So that's a one attribute of her. Like, one person, many hats. That the same person, let's say if that person is married, so that will be wife role. And let's say she loves to play tennis, so that could be a tennis player. So you can think like that, right? So polymorphism is in object oriented programming. So whenever you are trying to process the same object differently on the basis of your class type or your data type, right? So that's what we call it as polymorphism. So a method can process objects differently depending on the class type or data type. So there's one of the very famous polymorphism function already developed inbuilt function, that's length. And that's where I always take this example to teach this concept. So guys, you know that length, works differently for those different objects, right? So length, right? Length calculates the length of the object depending upon its type. So for example, if your object is a string, it returns the count of characters. But if your object is a list, it returns the count of items in a list. So I'll show you with an example. So let's say we have a list students. So I have Sakshi, I have Mohit, right? I'm just picking some names. I have Abdul, okay? So these are my students, right? Guys, this is my student list. Now, if you focus here, Sakshi, Mohit, Abdul is a list. I can also show you it's a list type of students, right? What is it? It's the list. Now, guys, for the same function, right? For the same function, you will have different things. Now, what I'll do, I'll focus. I will want you guys to focus on this definition. If an object is a string, it returns the count of characters. So first, let's take Sakshi here. So I'll say students, and if I say 0, right, it will print Sakshi. If I do length of this guy, right, Sakshi here, what do you guys think? It will return the words or letters in the name of Sakshi, right? I think Sakshi know, right? 6 letters. But if I do the same thing, I don't put any index. Now see what is showing 3. 3 means what? You have 3 students in the list students, isn't it? That's what polymorphism means, right? I think there is one small topic on broadcasting, if I quickly talk about in Numpy. So I'm just touching on it, but generally we don't really need this property all the time. A lot of teachers also don't teach. Let me be very honest here. Okay, when you're trying to do some arithmetic operations and all that, right? So Numpy helps you to broadcast it. Okay, so for example, you're doing a multiplication. So I'll show you with a very simple example. So different shapes it handles automatically, right? So broadcasting is all about. So the beauty of broadcasting is that it handles automatically different array shape to make sure that your arithmetic operations are going on the go. So I'll show you. So let me take an array 1, which I can do np dot array, right? I'll do 1 2 3. I'll say a multiplier b equal to 2. Now guys, if I do array 1 into b, can you guys see that? So what do you guys expect here? Now this is of different length, right? It has 3 elements in this array. It has just one element, one scalar value. This is scalar value. Hello. Now broadcasting means what? By default, it will go and expand this guy as like this. I'll show you. So to do array multiplication, my dear friends, so what array does, this is your array 1, focus, 1 2 3. And what is this? B. B is actually this, just 2. Broadcasting means it will just make the same shape and it will fill in here 2 2 2 2. So what is doing now? It is doing element by element multiplication only. Can you see that? 1 jar 2 is 2, 2 jar 2 is 4, and 3 jar 2 is 6. So what it has done, broadcasting means it has taken the scalar value b and converted into the shape of the array 1. Right? Wherever it is compatible, it will do that. Okay, makes sense? So this is just such a very small topic, and I can also show you with the image here coming from the Numpy library itself, right? So you have 1 2 3, 2 has been stretched to make sure that it becomes 2 2 2, and then you are multiplying, it becomes 2 4 6. On this note, guys, I think thank you very much.
So now moving to the first question, what do you mean by the term normal distribution? Normal distribution, also known as Gaussian distribution, is a type of probability distribution that is symmetric about the mean. Here, mean, median, and mode are equal. Normal distribution appears to be bell curve in a graphical form. So here, you can see this graph. This graph is symmetry, and also mean, median, and mode are equal. So now, let's move forward. So the next question we are having is, what is a skewed distribution? A skewed distribution takes place when one tail is longer than the other. Skewness defines the asymmetry of a distribution. Here, the data is not distributed equally on both sides of the distribution's peak. So basically, there are different types of skewed distribution. The first one is the left skewed distribution, and the another one is the right skewed distribution. So in left skewed distribution, it occurs when the long tail is on the left side of the distribution. That means here the mean is left to the peak, and also mean is less than the median, and the median is less than the mode. Along with that, left skewed distribution is also known as negatively skewed distribution. Coming to the right skewed distribution, it occurs when the long tail is on the right side of the distribution. It is also called as positive skewed distribution. Here the mean is right to the peak, and also mode is greater than median, and median is greater than mean. Now, so let's see in the graphical form. Here you can see that this is a graph of left skewed, right? So clearly mode is greater than median and median is greater than the mean. So now let's see left and right skewed distribution in graphical form. So here you can see that it's a left skewed graph, right? Because the long tail is on the left side of distribution. Whereas if you are talking about the right skewed distribution, the long tail is on the right side of the distribution. In a left skewed, you can clearly see that mode is greater than median and median is greater than mean. Similarly, coming to the right skewed, here mean is greater than median and median is greater than mode. Now, moving ahead, the next question we are having, what is the difference between bias and variance? Coming to the bias, bias is a prediction error that is introduced in the model due to oversimplifying the machine learning algorithms. It is the difference between the predicted values and the actual values. So let's suppose you have created a machine learning model. So while creating a machine learning model, we'll get some predicted values. So basically, the difference between the actual values and the predicted values is known as the bias. Now, coming to the variance, variance occurs when the machine learning model performs well on the training dataset but not on the test dataset. So now, moving to the next question, how will you handle missing values in data? So there are several ways to handle missing values in the given data. The first one is you can replace the values with mean, median, and mode. For example, let's suppose if you are having any numerical column of, let's say, price, and there are a lot of missing values, then you can replace it with the mean. Now, moving next, we are having the dropping the values. So let's suppose if you are having any column that is present in the data set and the null values are present more than 70%, then you can drop that particular column. The last is replacing with arbitrary values. So that means you can choose a random value without any reason or system. So the next question we are having is, what are the techniques used to detect outliers? So there are various techniques that are used to detect outliers. The first one is the box plot. So talking about the box plot, we know the length of the box is IQR, that is nothing but an interquartile range, right? And the minimum and maximum values are represented by the whiskers. So the whiskers are generally extended into 1.5 times of the IQR distance on either side of the box. Therefore, all the data points outside this range values are flagged as outliers. So the next technique that is used as z-score. So z-score is a parametric outlier detection method in a one or low dimensional feature space. This technique assumes a Gaussian distribution of the data. The outliers are the data points that are in the tails of the distribution and therefore far from the mean. So the last method that we are having is interquartile range. As we know, the formula of interquartile range is that it is quartile 3 minus quartile 1. Basically, it is the difference between the third quartile and the first quartile. So to detect the outliers using this method, we define a new range. So let's call it decision range, and any data point lying outside this range is considered as outlier and is accordingly tailed with. So the next question we are having is, what is the difference between overfitting versus underfitting? As we know that overfitting and underfitting are the two key problems in machine learning that decrease the performance of machine learning models. Now, coming to the overfitting, overfitting occurs when our machine learning model attempts to cover all or more than the required number of data points in the given data set. So you can see that in this graph, our machine learning model tries to cover all the data points, right? So now, what happens here? As a result, the model gives inaccurate values in the dataset, and all of these factors reduce the model efficiency and accuracy. The overfitted model has low bias and high variance. The more we train our model, the more likely it is to become overfitted. Told you, you can see in this graph, the model tries to cover all the data points. So it looks efficient, but in reality, it is not so. Because the goal of the regression model is to find the best fit line. But here, we have not got any best fit, so it will generate the prediction error. So now, let's see how we can avoid the overfitting in model. So there are some ways by which we can reduce the occurrence of overfitting in our model. The first one is the cross-validation. Second, we are having training with more data. So whatever the data is there, we can train it, right? So there are some ways by which we can reduce the occurrence of overfitting in our model. So let's see some of the ways. The first one is the cross-validation. We can also train with more data. Then we can remove features too. We can early stopping the training too. Along with that, we can also apply regularization as well as ensembling. Now, after knowing what is overfitting, now let's see what is underfitting. So underfitting occurs when our machine learning model is unable to capture the underlying trend. So to avoid overfitting in the model, the feeding of the training data can be stopped at an early stage, causing the model to learn insufficiently from the training data. As a result, it may fail to find the best fit of the data's dominant trend. Underfitting occurs when the model is unable to learn enough from the training data, reducing accuracy and producing unreliable predictions. So let's back to the previous slide. So in underfitting, a model that is underfitted has a high bias and a low variance. For example, the following output of the linear regression model can help you understand about the underfitting. So here you can see that the model is unable to capture the data points in the plot, right? So now let's see how we can avoid underfitting in the model. So there are two ways in which we can avoid the underfitting in model. The first one is increase the model's training time, and the another one is the increasing the number of features. Okay guys, so the next question we are having is, what is the difference between supervised and unsupervised learning? Supervised learning is a machine learning method that uses labeled data to train model. For example, here you can see that how a player learns in the presence of his coach. So this is an example of supervised learning. Now, there are two types of problems that can be solved using supervised learning. The first one is the classification and the another one is the regression. So let me give you the example is completed. We will test the model by giving the new sets of car. The model will identify the car and predict the output using a suitable algorithm. So there are different types of supervised learning: linear regression, logistic regression, random forest, decision tree, etc. So now, after understanding supervised learning, let's see what is unsupervised learning. Unsupervised learning seeks to extract structure and patterns from the input data. It requires no supervision like supervised learning. Instead, it discovers pattern in the data on its own. Unsupervised learning can be used for two types of problem. The first one is the clustering and the another one is the association. Here you can see that in this figure, you can see that the model will train itself and divide the groups according to the most similar features between them. So let's take an example. So here we'll not provide any supervision to the model. We'll just provide the input data set to the model and allow the model to find the patterns from the data. With the help of a suitable algorithm, the model will train itself and divide the cars into different groups according to the most similar features between them. So the next question is, what is the difference between regression versus classification? So regression algorithms are used to predict the continuous values. Regression is a process of determining correlations between dependent and independent variables. For example, price, salary, etc. I'll give you the example of price versus experience. So let's understand by taking some examples. So let's suppose I'm having a data set which consists of one dependent variable and one independent variable. So the independent variable contains the years of experience, whereas the dependent variable contains salary. So as we know that as the experience of a person increases, the salary will also increase. So this is the example of the linear regression. So there are different types of regression algorithm: simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree, random forest. Now, talking about classification, classification algorithms are used to predict or classify discrete values. For example, male and female, true or false. Even you can take the example of male, whether the male is a spam male or not spam male, right? So let me explain you how does classification work. So let's suppose a computer program is trained on the training data set, then it will categorize the data into different classes based on that training. Different types of classification algorithms are logistic regression, k-nearest neighbors, support vector machine, and kernel SVM. So guys, let's move further and see what is confusion matrix. So the confusion matrix is a table that used to estimate the performance of a model. It tabulates the actual values and the predicted values into a 2x2 matrix. So now, let's see what is true positive here. So let me give you the definition of true positive. True positive denotes all those records where the actual values are true and the predicted values are true, right? So here you can see that the actual value is 1 and the predicted value is 1, and we got here true positive. Now, coming to the false negative, this denotes all of those records where the actual values are true but the predicted values are false. So you can see that this is false negative, where the actual value was 1 whereas the predicted value was 0. Next, we are having false positive. So in this, the actual values are false but the predicted values are true. So this is our false positive, where the actual value is false. So we are considering false as 0 and true as 1, right? So here we can see that the actual value was false and the predicted value was true, right? So after understanding true positive, false negative, and false positive, now let's see what is true negative. So this is a true negative. Here the actual values are false and the predicted values are also false. So if you see, this is the true negative. Here the actual value is false and the predicted value is also false. So this is how the confusion matrix works. So now coming to the 10th question, what is the use of p-value? P-value is the measure of the statistical importance of an observation. It is the probability that shows the significance of output to the data. We compute the p-value to know the test statistics of a model. Typically, it helps us choose whether we can accept or reject the null hypothesis. If the p-value is less than 0.05, then reject null hypothesis or else accept null hypothesis. Moving to the next question, we'll see what is a residual. So residual in a statistical or machine learning model are the differences between observed and predicted values of data. So here you can see that this is our best fit line, right? So these are the predicted values, whereas these values are the actual values. So the difference between the predicted values and the actual values is known as residual, right? So these are the residuals, right? Again, this is the point that we have done the prediction, right? These are the actual values. So the difference between the actual values and the predicted values will be our residual. The next question we are having is, what is dimensionality reduction? So the dimensionality reduction or dimension reduction is the transformation of data from a high dimensional space into a low dimensional space so that the low dimensional representation retains some meaningful properties of the original data. So let's take an example to understand in a simpler way. In machine learning classification problems, there are often too many factors on the basis of which the final classification is done. These factors are basically variables called features. The higher the number of features, the harder it gets to visualize the training set and then work on it. Sometimes most of the features are correlated and hence redundant. This is where dimensionality reduction algorithms comes into the picture. So there are various methods that is used for the dimensionality reduction. The first one is the PCA. So PCA stands for Principal Component Analysis, and the another one is the LDA, that is Linear Discriminant Analysis. So the next question is, what are the steps involved in machine learning? So the first step is data collection. Basically, we are defining the problem and assembling a data set. Then moving forward, we are having data preparation. So basically, we are preparing our data. Then we have to choose the model and train it, right? And after that, we will evaluate our model. So while evaluating a model, we will choose a measure of success. Also, we will decide on an evaluation protocol. The next step is parameter tuning. So basically, we are doing here scale up, right? Developing a model that overfits and regularizing your model and tuning your parameters. And at last, we will do the predictions. So this is the way, and these are the steps that are involved in machine learning. Moving to the next question, what is pruning and the decision tree? So I will give you the simpler definition here. Pruning simply reduces the size of decision tree by removing parts of the tree that do not provide power to classify instances. Here, in this diagram, you can see that before pruning, there are a lot of sections of a decision tree, but after pruning, so here in this figure, you can see that before pruning, there are a lot of sections of the tree that are unnecessary, right? But after pruning, we have removed that particular section. Okay, so let me read the definition for you. Pruning in a decision tree is the process of removing the sections of the tree that are not necessary and redundant, right? So why do we use pruning basically? So why do we do pruning in the decision tree? So that our model performs better and gives a higher accuracy, right? What is RMSE in a linear regression model? RMSE stands for root mean square error. It is computed by taking the square root of MSE. MSE is where mean square error, right? RMSE measures the average magnitude of the errors and is concerned with the deviations from the actual value. RMSE value with 0 indicates that the model has a perfect fit. The lower the RMSE, the better the model and its predictions. A higher RMSE indicates that there is a large deviation from the residual to the ground truth. RMSE can be used with different features as it helps in figuring out if the feature is improving the model's prediction or not. Now coming to the question number 16, what is the use of elbow method in k-means clustering? So first, we'll understand what is elbow method. Elbow method is one of the most popular methods to determine this optimal value of k. So what is k here? K means here the number of clusters. As I already told you, it is the most popular method for selecting k for the k-means algorithm, right? So to do this, you need to calculate the within cluster sum of squared error for different k values. So here you can see that it is written as WCSS, which is nothing but a within cluster sum of squared error, right? So it is described as the sum of the square of the distance between each data value and its centroid. You will then choose the value of k for which the WCSS error starts to become negligible. So here in this graph, you can see that this is the number of cluster and this is nothing but WCSS, right? And here at this point, this is your elbow. So the number of clusters will be 5. So the next question that we are having is, what is naive Bayes? So naive Bayes classifiers are a collection of classification algorithms based on Bayes theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle, that is, every pair of features being classified is independent of each other. So basically you have to keep remember the assumption, right? So the assumption about each feature is that a feature should be independent and equal. So the next question is, what are the disadvantages of linear model? The first disadvantage is prone to underfitting. What does it mean? It means that it is a situation that arises when a machine learning model fails to capture the data properly. So this typically occurs when the hypothesis function can't fit the data well. Next, it is sensitive to outliers. So as you know that outliers of a dataset are anomalies or extreme values that deviate from other data points of the distribution. Data outliers can damage the performance of a machine learning model drastically and can often lead to models with low accuracy. Next, so the next thing is that you have to take the assumption of a linearity between features and the target variables. So here you have to assume that the feature is having a linear relationship with the target variable. Moving to the 19th question, when do we use normalization and standardization? So first we'll see what is normalization. So in normalization, it is used when features are of different scales. Along with that, it is affected by outliers too. So when do we use normalization? It is useful when we don't know about the distribution. Also, it varies from -1 to 1 or sometimes 0 to 1. Along with that, if you want to use it, then there is a scikit-learn library that provides a transformer called min-max scalar. So you can use this transformer and you can apply normalization. Next, we are having standardization. So standardization is used when we want to ensure zero mean and unit standard deviation. Unit standard deviation means standard deviation is equal to 1. Along with that, it is not bounded to a certain range like normalization. So in normalization, the scale was from -1 to 1 or 0 to 1, but here it is not bounded to a certain range. Next, it is much less affected by the outliers. So if you want to use standardization, then there is a library scikit-learn that provides a transformer known as standard scalar. So this is all about normalization and standardization. Next question, explain hypothesis testing. Hypothesis testing is the process of testing assumptions for a population parameter on a sample of data. The process involves different hypotheses and statistical proof to accept or reject the hypothesis. Here, null hypothesis denotes as H0, whereas alternate hypothesis denotes as H1. Now, after understanding what is hypothesis testing, let's see the steps involved in hypothesis testing. So the first step is stating the hypothesis. For example, you can take the example of students with height more than 5 feet have BMI more than 20. Next, collect data. And after that, we will see the evidence to fail or accept the hypothesis. Then we will test the hypothesis, and according to that, we will take the decisions. So as I already told you, that let's suppose there is a student with height more than 5 feet and having BMI more than 20. So this will be your null hypothesis. So what will be your alternate hypothesis? Opposite of it. That is, students with height more than 5 feet do not have BMI more than 20. Now, according to the statistical test, we'll support the alternate hypothesis or null hypothesis, right? So this is how it works. So the next question is, what is the difference between training test, validation set, and a test set? So first, we'll discuss about training test. It is a portion of our actual data set that is fed into the machine learning model to discover and learn patterns. So let's suppose that if you are having 100% values in the data set, so we'll take 70% of the values or 60% of the values to train that data set. Next, we will see about the validation test. So the validation test is used for hyperparameter tuning. And at last, we'll see what is test set. So the test set is used for the final evaluation of the best model. Moving to the next question, what are the different statistical techniques used in data science? The first one is the correlation. So it establishes and measures relationship between different variables. For example, if we are having data set, then we are having a lot of features along with the dependent variable. So it will show the relationship of features with the dependent variables. So next we are having regression. It allows identifying if the evolution of one variable affects others. You can take the example of experience versus salary, right? Where one variable is affecting the other dependent variable. Next we are having time series. It predicts future values by analyzing sequence of past values. Basically, time series is used for the forecasting. Next, we are having the sentiment analysis. It determines the attitude of specific agents or people towards an issue, often using data from social networks. So the next question we are having, what is box plot? A box and whisker plot, also known as box plot, is used to show the spread and centers of a dataset. It is also used to detect outliers. It shows the dispersion of data across the mean. It summarizes the result as the minimum. So here you can see that. So this is a minimum, which means minimum value in the dataset excluding the outliers. Next, we are having first quartile. So this is the first quartile, or you can also say this as a lower quartile. So it means 25% of the data lies below the first quartile, right? So here, these are the 25% of the data that lies below the first quartile. Next, we are having median. Median is nothing but the midpoint of the dataset. Half of the values lie below it and half above. So this is the median. Next, we are having upper quartile, that we say Q3, right? So it means 75% of the data lies below the third quartile. So here if you can see, this is our upper quartile, right? So 75% of the data lie below this quartile. Next, we are having maximum. So it means maximum value in the dataset excluding the outliers. After that, we are having interquartile range. So this is our interquartile range, which is nothing but the length of the box, right? So it consists 50% of the data. Okay guys? Now, we will see what is whisker. So whisker is nothing but the upper and the lower whisker represent scores outside the middle 50%, right? So here you can see that we are having the lower whisker here, upper whisker is here. So this is all about the box plot. So the next question, what is SVM? So SVM stands for support vector machine. So what is the use of SVM? SVM are used for classification as well as the prediction task, right? So let us understand about SVM. It consists of a separating plane that discriminates between the two classes of variables. And this separating plane is known as hyperplane. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future, right? SVM chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are also called as support vectors. So these are the support vectors. That's why we used to call the algorithm as support vector machine. So after understanding SVM, now let's see some of the kernels used in SVM. So the kernels that are used in SVM are polynomial kernel, Gaussian, sigmoid and hyperbolic. So moving to the 25th question, what are a z-test, chi-square test, f-test and t-test? Okay, so first let's see what is t-test. So we use t-test to compare the mean of two given samples. Also, t-test assumes a normal distribution of the sample. So when we have to use t-test, when we don't know the population parameter, that is nothing but mean and standard deviation, right? In that case, we use t-test. So after knowing t-test, let's see what is z-test. So a z-score is calculated with population parameters such as population mean and population standard deviation. So in a z-test, we assume the sample is normally distributed. So what is the use of z-test? So we use this test to validate a hypothesis that states the sample belongs to the same population. So in a simple terms, when we have to use the t-test as well as the z-test, so we will use the t-test for the small sample size, whereas we will use the z-test for the large sample. Coming to the chi-square test, or even you can say chi-square test, it depends, right? So we use the chi-square test to compare the categorical variables. A chi-square test fit for the two independent variables, used to compare two variables in a contingency table to check if the data fits. So let's see the definition here. So chi-square test is used to determine the difference observed and expected frequencies of a certain observations. Alright, so the last test we are having as F-test. So when we use F-test, so when the hypotheses of the interest are about the differences between population means. Okay guys, so the next question that we are having is, what is the difference between correlation and covariance? So now, first we'll discuss about the covariance. So covariance shows the extent to which the two variables are dependent on each other. Basically, higher the number, higher the dependency. Now, what is the range of covariance? It varies from -infinity to infinity. Right? Now, moving to the third point, it is affected by a scale of a variable. So now, let's see what is correlation. So, in covariance, it indicates the direction of linear relationship between variables. Basically, it shows the extent how two variables are dependent on each other, right? But in correlation, it measures the strength of two variables considering other conditions are constant, right? The next point is the range of correlation is from -1 to 1. So basically here we are having the Pearson correlation whose range is varying from the -1 to 1, right? Along with that, it is not affected by scale unlike covariance. Next question, what is cross-validation? In a simple term, cross-validation is used to validate models' efficiency, right? So let me give you the formal definition of cross-validation. It is a technique for validating model efficiency that involves training the model on a subset of input data and testing it on a previously unseen subset of input data. In a simple term, it is a statistical method of evaluating and comparing learning algorithms by dividing data into two segments, one used to learn or train a model and the other used to validate the model. Next, we are having the cross-validation by k-fold. We can also do the cross-validation with one exception and many more. So this is the idea about the cross-validation. Moving to the next question, what is sampling? Mention some techniques used for sampling. So let me give you the definition of sampling. Sampling is defined as the process of selecting a sample from a group of people or from any particular kind for research purposes. It is one of the most important factors which decide the accuracy of a research or survey result. For example, if you want to take the sample that how many people are affected by COVID, so you will directly go into the population and out of that particular population you will take the sample about 1 or 2%. So this is nothing but known as sampling, right? So mainly there are two types of sampling techniques. The first one is the probability sampling and the another one is the non-probability sampling. So what is probability sampling? It involves random selection which makes every element get a chance to be selected. That was the example just now I have given to you. So what are the different types of probability sampling? So repeat. We will see that probability sampling has various subtypes. We are having the such as simple random sampling, stratified sampling, cluster sampling and many more. Now, after understanding probability sampling, let's see what is non-probability sampling. So non-probability sampling follows non-random selection, which means the selection is done based on your ease or any other required criteria. This helps to collect the data easily, right? So what are the subtypes of non-probability sampling? Convenience sampling, quota sampling, referral sampling, and many more. So this was the overall idea about sampling. The next question, what is ROC curve? So ROC stands for Receiver Operating Characteristic. It is basically a plot between a true positive rate and a false positive rate. So here you can see that we are having the graph of true positive rate and false positive rate, right? Also, it helps us to find out the right trade-off between the true positive rate and the false positive rate for different probability thresholds of the predicted values. So I will give you the idea about ROC curve. So let's suppose if the curve is closer to the upper left corner forest from the number of weak classifier. It is done by building a model by using weak models in series. So what happens here? Firstly, a model is built from a training data. Then the second model is built which tries to correct the errors present in the first model. This procedure is continued and models are added until either the complete training data set is predicted correctly or the maximum number of models is added, right? So what is the uses of boosting? It is used to reduce the bias. As I told you here, each new subset contains the components that were misclassified by previous models. It is a way of connecting predictions that belong to the different types. Here, the models are weighted by their performance. Along with that, new models are affected by the performance of the previously developed model. What is bagging? Bagging is also known as bootstrap aggregating. So it is also a machine learning assembling algorithm which is used to design to improve the stability and accuracy of a machine learning algorithm. Right? So what happens here in bagging? It decreases the variance. Right? So bagging is used to reduce the variance of a decision tree. Along with that, it attempts to tackle the overfitting issue. So here every model receives an equal weight. Alright? Unlike boosting, here every model is constructed independently. Right? So this is the overall idea about boosting and bagging. Explain univariate, bivariate and multivariate analysis. So first we will see what is univariate analysis. So univariate analysis involves analyzing data with only one variable, or in other words, a single column or a vector of the data. This analysis allows us to understand the data and extract patterns and trends out of it. For example, analyzing the weight of a group of people. Moving next, we are having bivariate analysis. So here, it involves analyzing the data with exactly two variables so that the data can be put into a two-column table. For example, analyzing the data that contains temperature and altitude. Okay? Also, this kind of analysis allows us to figure out the relationship between the variables. Next, we are having multivariate analysis. Multivariate analysis involves analyzing the data with more than two variables.
Let's have a quick quiz question, guys. And the question is, which of the following is an example of polymorphism in Python? And your options are calling a method with different number of arguments based on the object type, or defining two methods with the same name in the same class, or defining a variable with same name as method in the same class, or finally, none of the above. Please mention your answers in the comment section below.
So here, the number of columns of the data can be anything, even more than two. This kind of analysis allows us to figure out the effects of all other variables on a single variable. For example, analyzing data about house prices, which contains the information about the houses, such as locality, crime rate, area, the number of floors, etc. Next question, what is recall? Recall tells you how many times the model was able to detect a specific category. In a simpler term, out of the total positive, what percentage are predictive positive? So let me give you the definition of it. It is a metric that quantifies the number of correct positive predictions made out of all the positive predictions that could have been made. For example, here you can see that this is a formula of recall, right? So recall formula is true positive upon true positive plus false negative. So basically out of the total positive, what percentage are predicted positive? Moving next, we are having precision. Precision is how good the model is at predicting a specific category. Basically, it measures the accuracy of correct positive predictions. So let's see the formula. So precision is equal to true positive upon true positive plus false positive. As I told you, basically it measures the accuracy of correct positive predictions. Also, the precision value lies between 0 and 1. Now, moving to the question number 37. What are the popular libraries used in data science? So there are popular libraries that are used in data science such as TensorFlow, SciPy, Pandas, Matplotlib, PyTorch, Scikit-learn. Let me explain you some libraries. For example, Pandas. Pandas is used for data analysis. Coming to the Matplotlib, this is a library that is used for data visualization, whereas Scikit-learn is a machine learning library. So moving to the question number 38, what is deep learning? Deep learning is a subset of machine learning, which is essentially a neural network with 3 or more layers. Deep learning is an advanced version of neural networks to make the machine learn from the data. In deep learning, the neural networks comprise many hidden layers that are connected to each other, and the output of the previous layer is the input of the current layer. I will give you the example of deep learning in a simple term. Deep learning teaches computers to do what comes naturally to humans. Along with that, it is a key technology behind the driverless cars, such that enabling them to recognize a stop sign, etc. So now, moving to the question number 39, what do you understand about linear regression? So when I'm talking about the simple linear regression, so there is one independent variable and there is one dependent variable. For example, experience versus the salary. So let's see the points here. So linear regression helps in understanding the linear relationship between the dependent and the independent variable. So as I told you the example of experience versus salary, as you are having the experience more than 3 to 5 years, your salary will be gradually increasing. Next, linear regression is a supervised learning which helps in finding the linear relationship between two variables. So here, one is the predictor or the independent variable and the other is the response or the dependent variable. So this is the basic idea about the linear regression. So now, coming to the last question, how to calculate the accuracy of a binary classification algorithm using its confusion matrix. So first of all, let me give you the definition of accuracy. So accuracy is also a metric that is used for evaluating classification models. So what is the formula of accuracy? Accuracy is basically the number of correct predictions upon the total number of predictions. So here, to calculate the accuracy, we need to divide the sum of the correct classified observation by the number of total observations. So when I am talking about the number of total observations, so it will include true positive, it will include true negative, it will include false positive as well as false negative. The accuracy will be true positive plus true negative upon the total number of observations. Okay guys, that being said, I wish you good luck on your data science journey. I hope these steps will help you plan your learning schedule. That's all we have for this video. I hope this video was informative for all of you guys out there willing to take your career to new heights with data science. Thank you for being there till the end of this video. If you have liked this video, make sure to hit that thumbs up button. Also, do not forget to enable subscribe button to never miss any update from Intellipaat YouTube channel.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.